adoption, transfer, and commercialization of available technologies. We ensure timely and effective delivery of research results. The Council encompasses sectors under these priority areas. And all of these are backed by a highly skilled and science technology workforce for quality technologies and innovations. We are driven in bringing homegrown science and technology to the fore of the competitive global arena, creating impact on the country's progress and improving the quality of life of every Filipino. We uplift lives through innovations. Be assured, we are the Innovation Council for Industry, Energy, and Emerging Technologies.
Transmission, closure of borders, lockdowns, millions of deaths. The unprecedented crisis brought about by COVID-19 has brought the world to a standstill. Amongst the first frontline government agencies to lead the fight against COVID-19 was the Department of Science and Technology, Philippine Council for Industry, Energy, and Emerging Technology for Research and Development.
Also known as the DOST PCIEERD, the Council was able to deliver innovations to the Filipino people at the height of the pandemic in 2020.
Among the projects supported by the Council in response to the pandemic include the Specimen Collection Booth. A total of 132 units were deployed to 92 hospitals throughout the country to help frontline workers collect specimens from suspected COVID-19 patients. The Additive Manufacturing Center, or AMCen, together with its partner centers, also provided 3D printed face shields, ear relief bands, and 3D printed Venturi valves distributed to hospitals all over the country. Ventilators were also developed to address the shortage of essential medical supplies, critical to the delivery of public health services, primarily among COVID-stricken patients. The Council also supported innovations in safety monitoring, border control, and mobility assistance, such as Vision-Based Traffic Information Analysis, or TITAN, Optimal Allocation of Personnel, or OLAP, and the Intelligent Electric Transportation Network Program. The Bayan Co-op's Unified Market Inventory System was also brought online to address shortage and hoarding of essential supplies. ReWear, a washable 4-layer face mask, is able to repel water and similar liquids, adding a layer of protection against COVID-19. Other powerful pandemic inventions also include the Mobile Artificial Intelligence Thermal Scanner and the LISA robot in mitigating the spread of the dreaded novel coronavirus disease. We, the Council, also rolled out human resource and institutional development programs that seek to empower Filipino researchers, scientists, and engineers amid these trying times. These programs are a testament to the capability of the Filipino to make wonders that are scientifically sound and socially relevant.
With Filipino innovators, researchers, and scientists taking the lead against the pandemic, DOST PCIEERD is committed to bringing more innovations in response to the most challenging period of our time.
Research not communicated is research not done.
The Innovation Council and the University of the Philippines Los Baños College of Development Communication has launched the Science Communication Fellowship Program, popularizing research for the people. The program will empower 40 scientists, researchers, and communication specialists to better promote their innovations and research results to the public.
The fellowship program is composed of a series of mentoring activities that will introduce the concepts of science communication, popularization techniques, and skills in developing communications materials. Aspiring Pinoy science communicators should be part of an ongoing PCIEERD-supported project with a remaining duration of at least 6 months. Researchers from completed projects may join, provided that the project is still being sustained in their organization. To be one of the 40 SciComm program trainees, visit this link, fill it out, and submit the following documents until July 29, 2021. Applications will be evaluated through the quality of their capstone projects, guided by these criteria. Number 1, innovativeness, 30%. Number 2, feasibility, 20%. Number 3, impact, 25%. And number 4, sustainability, 25%.
Ready to optimize your science communication skills? Join the DOST PCIEERD Science Communications Fellowship Program to reach and educate more Filipinos.
COVID-19 has shined the light on the importance of science, technology, innovation experts, and researchers in the Philippines, as they were amongst crucial frontliners tapped to aid in the country's fight against the pandemic. Most of these experts helped the country through game-changing programs, projects, and initiatives of the Department of Science and Technology, or DOST, to ensure that the DOST continues to arm experts and enrich the country's S&T human resource. It crafted the DOST Science and Technology Fellows Program.
The DOST S&T Fellows Program aims to engage S&T experts to craft and shepherd R&D roadmaps for sectoral planning councils and strengthen the capabilities of the department's research and development institutes.
S&T Fellows will direct, undertake, and promote R&D in the country that will spur socioeconomic, health, and nutritional growth, as well as speed up inclusive growth and development in the countryside through state-of-the-art innovations. They will be the pathfinders that chart roadmaps of the sectors they are assigned to. As an S&T Fellow, they will help the DOST in identifying cutting-edge research, bringing Philippine innovations to the next level. The S&T Fellow must, number 1, be a Filipino citizen not more than 60 years of age. Number 2, be a career service professional. Number 3, be organized and a good team player. Number 4, have excellent written and oral communication skills, with a capacity for simplifying complex ideas and concepts for the understanding of various stakeholders. And number 5, have an outstanding contribution in their field of specialization. Read the full list of qualifications and application requirements through the link displayed on the screen.
Be an S&T Fellow and champion DOST's goal to empower and upgrade the Philippines' capabilities in science and technology.
We would like to request everyone to please stand up as we begin our program with the invocation to be followed by the Philippine National Anthem and the DOST hymn.
I'm so blessed, my Lord, I can see you in all the lovely things so fine and true. I see you in the beauty of the flowers and the rain. I see you between the lines of a sweet refrain. I'm so blessed, my Lord, I can see you. Even when I'm lonely and in pain, I see you in the beauty of the stars at night. I see you in my life, I feel alright. I see you, Lord, in sorrow and in happiness. I see you in the glory of sweet success. I see you, Lord, every hour, every day. I can see you, Lord, whenever I pray.
Mga kababayan, ang pambansang awit ng Pilipinas.
Ang siyensya ay sa amin.
You may now be seated. Ladies and gentlemen, welcome to DOST PCIEERD's 12th anniversary celebration. This is Innovate Pinas, the 2022 Philippine Research, Development, and Innovation Conference. Please welcome our hosts, Mr. Christian Zamora and Ms. Maribel Manawi.
Hello, hello, hello. Good morning, everyone. I hope you're doing well.
Good morning, Christian, and good morning to all of our participants.
Morning as well, Belle. And we would like to welcome everyone to this exciting commencement of DOST PCIEERD's completed projects only here at the Innovate Pinas. Before we formally begin, we would like to thank everyone who has joined us physically here for this event at the Dusitani, Manila to celebrate PCIEERD's anniversary. Shout out as well to all those joining us virtually via Zoom and Facebook Live.
Yes, indeed. For those who are online, please key in the comment section where you are watching from. Please like, share, and comment as well throughout the program.
As we are celebrating the Innovation Council's 12th founding anniversary, we are excited to showcase to everyone our completed projects under the industry sector.
Yes, we are very eager to share with the public the brilliance of our researchers from the industry sector. Officially welcoming us today is an outstanding engineer who led and worked at numerous game-changing programs and projects in the fields of land surveying, remote sensing, and geographic information system, environmental monitoring, and disaster risk assessment and management. One of these is the Disaster Risk Exposure, Assessment, and Mitigation Light Ranging and Detection Technology, or DREAM LiDAR, which addressed and helped mitigate the effects of flooding disasters in the country by producing accurate national terrain elevation maps and training highly skilled LiDAR and flood mapping experts all over the country. These initiatives have been proven essential in the country's resource monitoring and management and in various government agencies' decision-making processes for policy formulation. Please give a warm round of applause to our Executive Director, Dr. Enrico C. Paringit.
Pleasant day to everyone. I'd like to, of course, especially greet our beloved and valued guests for this morning's affair. Of course, our very accomplished researchers from the different universities and research and development institutions that are attending today's event. Of course, our esteemed partners from the private sector, our friends from the media, of course, my co-workers at PCIEERD and in government. Of course, I'd like to give due recognition to our special guests for this morning. We have the University President of the University of Science and Technology Philippines, Dr. Ambrosio B. Cultura II. Thank you very much, sir, for being with us. Together with him is Mr. Mark Pave Cerobito.
the Director in Infrastructure Planning, Facilities Development, ARD, Fernando Dumpa, sir. Thank you very much for being with us. The Assistant Regional Director of DTI Region 2, Winston P. Singon, sir. Thank you very much for coming. The Chairperson of the Women's Business Council Philippines, Evelyn Singson, ma'am. Also the representatives of the different industries, I think a great part of which is coming from Central Luzon. Thank you very much din po sa inyong pagdating. Our friends from media, I said I already recognize, of course, my co-workers at the DOST PCIEERD who has tirelessly prepared for all of these activities leading to this day and all the days moving forward. I see we at the DOST PCIEERD congratulate all the researchers, project leaders, team members, and everyone involved in the projects we are about to feature today for accomplishing your hindi lang tasks. And I think tasks is too small a word to describe the projects and initiatives that you have started. We labeled this as some sort of for lack of a better term, a graduation. No? Kasi if you run an analogy with that of students doing their work, this is sort of a commencement of all the hard work that our researchers have put through in the years that they have implemented all of their projects. Alam niyo po, in PCIEERD, we endeavored to recognize both the projects that are starting through our CBOL event programs that we have initiated. Yung CBOL, ito yung parang send-off ceremony sa ating mga newly launched projects. Projects that are launched in the year. So baka magtaka kayo, newly launched, December na nila-launch. It so happened that it was in the same year. So by definition, yun din pong ating, so tawag natin din CBOL. So inisip ko parang ito yung ani. Wherein we already recognize also the contributions or the achievements of the projects and project leaders and project implementers and implementing agencies and institutions for what they've done in the years of their research and development. So yun naman po ang ating i-recognize ngayon. So, and we've been doing this in a segmented fashion as well. Kasi, let me give you a rundown first why we're doing this. For the year 2021, PCIEERD had tallied the following. If we go by the numbers. Did you know that there are 106 completed projects in 2021 alone? And then out of this, of course, we have responded duly also to the need during the COVID-19 crisis. And we are not out of the woods yet. There were 36 projects that were completed also at that time. There were 94 projects that were started to be funded. And then out of the 100, the ongoing projects at that time, we were able to monitor despite the restrictions caused by the pandemic, 122 projects. Iba ka rin kasi pag nakikita namin yung mga projects ninyo on-site, rather than us just asking you what had happened. And 2021 was also a breakthrough year for us sa PCIEERD. It's a challenge year for us because we received 940 proposals. So if there were 100 new projects that were started, so parang you're lucky to be one of the 10% that were able to make it through. We were able to engage 32 new project leaders, so that also tells us that that we need to increase the level of engagement to have more project leaders on board. In terms of institutions, we have 32 higher educational institutions. We have 13 national government agencies, 52 non-governmental organizations and people's organizations. taking part in any one of the projects. And there were 13 international cooperation projects also, 13 cooperations forged. No? So thank you for actively engaging with DOST PCIEERD in these endeavors. Nabanggit ko na kanina na we opened by our CIBOL event and we closed projects through our Innovate PINAS event. And today is actually the second leg of the Innovate PINAS in 2022. Or this was called the Philippine Research and Development and Innovation Conference, which we started in 2021. No? And today we will be highlighting 42 completed projects from the industry sector. Medyo tall order na ipaparada natin lahat ng mga 42 projects na to. So bear with the information overload. And kasi last year, we did the conference, pero all of the projects were being presented in one day. Maghapon yun. No? So kung overload ngayon, back then, baka overload. So we endeavored to make it into bite-sized pieces. Of course, the 42 projects includes now for this segment, kasi I think our first Innovate PINAS segment was 1 or 2 months ago. And this time, we will be featuring projects from the environment, food, metals and engineering, mining and minerals, and industrial processes sectors. And this is coming really at a very opportune time because of the challenges that beset us. Soaring prices of basic commodities, as well as fuel, no? Our challenges, of course, posed by the renormalizing, no? Of our economy, of our economic activities. And we believe, no, that with the advent of this new normal, we should take cognizance, no, of new technologies that are coming about that could perhaps see the light of commercialization and adoption. This year's graduating class, if I may just use that analogy again, will bring the Filipino innovative environment projects that can help reduce air pollution. So isa yun sa mga set. I mentioned that environment is one of the sectors that we support, environment-related technologies. Our researchers are developing wastewater compact treatment system that can be used by restaurants and reduce industrial wastes. Meron din po tayong projects that have finished in the food sector. These are technologies that are using byproduct materials for fish processing. Very exciting area. As well as ways to strengthen our industry for halal certified food products. We will also share to the public today our the new halal center where local food manufacturers can standardize and further develop their native delicacies and be halal compliant, as well as to determine the shelf life. And one of the things that they did was to provide appropriate packaging and labeling. We'll hear more about that later. For our metals and engineering group, well, which includes, of course, mining and minerals, we will share the developed techniques and technologies to further improve the environment friendliness and efficiency to improve our mining output. We will also be featuring value-adding technologies as a step forward to achieving our dream of a circular economy in the manufacturing process. We will showcase how we can make plywood adhesive from used tea leaves and tobacco dust, as well as the inkjet digital printing ink from natural dyes. As a added feature, perhaps, of or segment of today's Innovate PINAS, we will be recognizing today projects that have excelled in project implementation. And you might wonder, what are the gauges, no? What are the criteria, no, for the recognition? If you could recall, if your projects are being evaluated, we always ask about your accomplishments, your progress. And we also ask about your efficiency in utilizing your budget. So yun pa yung magiging basis. And we will tell you more about this later. We're quite excited about this recognition because we also want to sound out to other researchers out there what it takes, no, to actually do your project and do your project well. So this is a new way for us to honor our project leaders who have painstakingly steered their projects to fusion. To end, we hope that through these projects that we will be featuring today, we will be able to rise up from the crisis that we've gone through, and slowly, but surely begin ramp up our economic activities that will lead to growth. So we hope that you can stick around, especially also to our followers that are following us online. By the way, this is the first face-to-face event that we have for Innovate Pinas as well, no? After a long while. So sa halip na ipi-play yung video, well, i-play pa rin naman yung mga videos, we will be actually interacting also with our speakers. So do hang around. I hope this is also a moment of to network. I think this is a good opportunity for our researchers, our industry representatives to, feel free to roam around and ask questions to the researchers that have presented, and do interact. Kasi what we're after is really find ways for us to work together. So maraming salamat po ulit sa pagdalo ng ating Innovate Pinas at the Philippine Research, Development and Innovation Conference for 2022. Maraming salamat po at mabuhay tayong lahat.
Thank you very much for the warm welcome, Dr. Eric. We are also joined virtually today by our very own DOST Undersecretary for Research and Development, Dr. Rowena Cristina L. Guevara. Dr. Guevara is seconded from the University of the Philippines, Diliman, where she is Professor 12 at the Electrical and Electronics Institute, where she specializes in speech and audio signal processing, time frequency analysis and synthesis, as well as artificial intelligence. She was the youngest and the first female dean of the UP College of Engineering and was executive director of the UP National Engineering Center from 2004 up until 2010. Prior to her appointment as the undersecretary, she also served as the executive director of the DOST PCIEERD from July 2012 up until 2015. Ladies and gentlemen, let us all give a warm virtual round of applause to Dr. Guevara as she gives her opening message.
A warm welcome and good morning to all our attendees in the second leg of Innovate Pinas, the 2022 Philippine Research, Development and Innovation Conference. The Department of Science and Technology congratulates the researchers, scientists, project leaders, project managers, and everyone involved in the projects that we will showcase today for a job well done. We would like to give everyone a pat in the back for successfully completing the arduous task of making scientific breakthroughs and converting these breakthroughs into functional innovations for the people. The R&D projects featured in this webinar are those completed in the industry sector in the past year, parang graduation. This covers the food sector, metals and engineering, mining and minerals, process, and the environment sector. Each of these sectors play a key role in the recovery of our economy, and we are glad that despite all the challenges posed by the pandemic, we can push ahead and accomplish the tasks at hand. Our country is facing major challenges ahead of the transition to the new leadership, with our national debt ballooning to almost 13 trillion pesos. We need to generate more revenues for our national treasury. This can be done through persistent R&D and the empowerment of our people and the transfer of these technologies. According to the research done by Oxford Business Group, the industry sector accounted for roughly 30% of the total GDP between 2017 and 2019. This was on pace for rapid growth thanks to the manufacturing sector, but COVID-19 pandemic caused our industries to contract and stagnate. We need to rebuild this momentum by transforming our industries into a dynamic and resilient sector through research and development. By developing technologies that make our processes become more efficient, energy saving, and data driven, we can truly innovate Pinas. Like what a wise man once said, innovation is any change, big or small, that makes a difference. Maraming salamat at muli, magandang agham po sa ating lahat.
Thank you so much, Undersecretary Guevara. Indeed, we are excited to see the functional innovations we have for our people. This event wouldn't be possible without the man who was with us for the past 6 years. He was the father who championed the developments in science and technology in the country. Secretary Boy has been working with the department for the last 30 years. He became the head of DOST's planning services, appointed as director of the Technology, Application and Promotion Institute, or TAPI, worked as undersecretary for scientific and technological services, and since 2016 as the DOST secretary. When he entered DOST, he was a part-time professor at the University of the Philippines, Diliman. Throughout the years, he rose the ranks and became chair of the UP's Department of Industrial Engineering and Operations Research, full-time industrial engineering professor, director of UP's Small-Scale Industries, and vice president of the UP Systems Planning and Development. All this while also holding key roles in different organizations, such as the Congressional Commission on Science, Technology, and Engineering in 2008, and chairman of the United Nations Commission on Science and Technology and for Development in 2011. At this juncture, let us listen to the Department of Science and Technology. Joining us virtually, we have Secretary Fortunato T. de la Peña. Please give him a warm round of applause.
Pleasant morning to all of our honored guests, participants, and our colleagues in the OST. Thank you for being with us today as we build a new foundation for the future. This month's Innovate PINAS is on its second graduation ceremony for completed DOST shared projects, and these offerings batch are for projects from the industry sector. We congratulate our project leaders who have successfully completed and accomplished their projects. Our harmonized national research and development agenda 2017 to 2022 was right on track as it integrates the research and development efforts in our partnerships with national government agencies. This enables other stakeholders to see the value of R&D and seamlessly apply it in their respective fields. The so-called domino effect effectively brought rapid technological changes in this increasingly globalized economy. A good example for this is the establishment of the Advanced Mechatronics, Robotics, and Industrial Automation Laboratory, or MERIAL, which was inaugurated in December of last year. This laboratory aims to be a national facility for capability development in the field of mechatronics and robotics. It can be our springboard to adopt automation in our industry. We see the future where automation, robotics, and artificial intelligence plays a vital role in functioning and industry players in the region. Technologies like this are game changers for the country, and we are optimistic that the next leadership will support our R&D efforts to truly bring us in changes. On behalf of the OSA, I would like to express my gratitude and appreciation to all the researchers, project leaders, and industry partners who took part in the development of this project. The past few years have been challenging, and but this only strengthened our resolve and dedication to making science work good. I remember very well, and this has been my advocacy even while I was serving duty as director of the Institute for Small Scale Industries. Industrial automation has been one of our focus, and this was way back more than 30 years ago. And I'm really happy that DOST has picked it up. We hope to see more projects like this in the years to come, and we hope the public can join us in uplifting the people through research and development. DOST will always be here to listen to your ideas. Thank you. Mabuhay tayo lahat.
Thank you very much, Secretary de la Peña. As Director Paringit and the Secretary have mentioned, this Innovate Pinas is the graduation ceremony for our project leaders as they share the outputs and developments of their research endeavors. I hope everyone here today with us are excited to learn about these initiatives, beginning with the projects under the environment sector. As we all know and realize by now, our environment is already in dire conditions. Here in the Philippines, being good stewards of the environment has been a gargantuan task, not only for the government, but also for the general populace as well. Our natural resources play a critical role in boosting the Philippine economy as it accounts for 10% of our gross domestic product and 30% of our employment. It is in this light that science, technology, and innovation become key to striking the balance between environmental and economic interests. So for this first segment of the Innovate Pinas, let us listen to the projects to be presented by Ms. Melissa May Boado of the St. Louis University, Engineer Reynaldo Esguera of the DOSC Industrial and Technology Development Institute, and Dr. Merlinda Palencia of the Adamson University. Let us all give them a warm round of applause.
Good day. I am Engineer Melissa May M. Buado of St. Louis University, Baguio City, here to talk about Zeoskin, a green indoor air filter. This project was conceived from the problem on indoor air quality, which I think often goes unrecognized. My experience and observation, especially in basement parking lots, is that most people seem to not mind the stench in there. Bad indoor air quality results from various substances such as volatile organic compounds released by our furniture and common household cleaning substances, from recirculated air in poorly ventilated spaces, or odors from our pets. Yet we have accepted them as normal. What we usually brush off as irritants or unpleasant odors are actually toxic substances that we breathe and may affect our health. The Zeoskin project intended to build upon the idea of a composite that has selective catalytic reduction capabilities, or SCR, initially proposed to target vehicular emissions. What began as a tailpipe filter for cars has evolved into its current application as a wall plaster. Hence, the term filter is actually a misnomer. We aim to optimize this composite for its SCR capabilities as well as characterize its plaster properties to ensure that it can be applied to indoor surfaces. We developed a ready-mixed powder that when combined with water can be made into a paste and applied to indoor walls. While many of us agree about the health hazards and risks of poor indoor air quality, it has gone unnoticed for so long. But when COVID-19 pandemic struck, suddenly we were all mindful of the air we breathe. Its adaptation, therefore, can contribute to a better and sustainable living and working spaces. Not to mention, improved productivity and overall wellness. As a result, we wouldn't be expected to tolerate stale office air or musty condo units. It is envisioned that Zeoskin will impact the construction industry to consider wall plastering not just for aesthetics, but as a functional passive air purifier. We see it as a complement to existing ventilation systems, which can reduce the risk caused by polluted air that most of us are exposed to. The project journey has not been easy. The thought of submitting a proposal was initiated in 2017 by people who believed in the potential of the idea. The grant was finally approved late in 2019 and originally set for implementation in April of 2020, which is supposed to run for 1 year. Even as the pandemic happened, we pursued to begin in July 2020 when the crisis was in its height. We encountered logistics challenges from restrictions. There were acquisition delays, limited access to potential test sites, and even work schedule limitations. But we were motivated by the vision of this project and by the people, including DOST PCIEERD, who support and encourage research endeavors such as this. And that is why we persisted. While we met most of our objectives and our results were satisfactory, there is still a long way to go for Zeoskin. For one, we still need to improve the technology itself, our data collection methodologies, and our analysis. We are grateful for the chance to put our ideas to the test and for the boost this grant has provided. We will continue to develop it until it can reach our target beneficiaries. May I encourage you, therefore, to be aware of how indoor air quality affects our health and well-being. So, the next time you notice persistent odors, imagine the difference it would make if our walls can help clean the air we breathe. Thank you very much.
Today I will be presenting the compact wastewater treatment system developed by ITDI for micro, small, and medium enterprises and restaurants. This developed technology is related to our completed project entitled Development of a Compact Wastewater Treatment System for Restaurants and MSMEs Discharging to Manila Bay Area under the program Support the Rehabilitation of Manila Bay. The project's main objective was to design and develop a compact wastewater treatment system for high organic wastewater that could be utilized by restaurants or MSMEs discharging to Manila Bay and its tributaries and comply with the regulatory standards of the Philippine Clean Water Act. MSMEs play a vital role in the development of the Philippine economy. More than 99% of companies in the Philippines are MSMEs and employ more than 60% of the country's workforce. Due to their large number, the environmental pollution released from these establishments can be substantial, especially if left untreated. Unfortunately, most of these enterprises have difficulty ensuring compliance with environmental policies and standards. One of the growing environmental pressures that MSMEs face is the need to treat their generated wastewater before being released into the water basins. Most standalone restaurants or MSMEs with limited space use only a system composed of a grease trap and a septic tank for the treatment of their wastewater. However, this type of system is not adequate to achieve the treatment efficiency to meet the regulatory requirements of the Philippine Clean Water Act. On the other hand, commercially available wastewater treatment systems require large areas and are too costly to be practically used by standalone restaurants or MSMEs. Thus, ITDI responded to these challenges that the MSMEs are facing. The ITDI, through this project, has developed a compact wastewater treatment system that requires less space and less capital investment for easier adoption. The system developed by the project team is composed of two tanks made of fiber-reinforced plastic with metal frame, stands, and auxiliaries. This is a modification of the previous ITDI developed compact wastewater treatment system. It has an improved clarifier design, vertically configured to reduce footprint. Each reactor has a smaller volume that can handle 2 to 4 cubic meters of wastewater with BOD of 800 to 1,200 milligrams per liter per day. Reactor tanks can be added if required to treat large volume of wastewater. The developed system was installed and commissioned in a fruit juice making facility in NCR. Several samples of the raw water and treated water from the system have been collected and sent to a DNR accredited laboratory for analysis to monitor the performance of the ITDI developed technology. The results of the pilot testings showed that the developed system could be used for the treatment of wastewater similar to fruit juice making. A pretreatment or a solid removal system is necessary for wastewater with high solids. Several establishments around the Manila Bay area, mostly restaurants, have been given cease and desist order for not complying with the required effluent standards. Through this project, restaurants and MSMEs now have the option to adopt the compact wastewater treatment system to comply with the standards. As a result, the rehabilitation and restoration of Manila Bay can be achieved faster when more establishments comply with effluent standards. The project was conceptualized when several restaurants discharging to Manila Bay were given cease and desist orders. This project was one of the 3 projects implemented under the Support to the Rehabilitation of Manila Bay program. Manila Bay Cooperating Agency of DNR funded the program and DOST PCIEERD monitored the implementation. Initially, identifying cooperators was challenging since many restaurants were closed or had limited operations due to the pandemic. Thus, MSMEs were considered for this project. As mentioned earlier, the compact wastewater treatment system has been successfully installed in a fruit juice making facility. The results showed that it could be used in other industries similar to fruit juice making company. However, it cannot be used directly for wastewater with a very high solids content. On December 18, 2008, the Supreme Court issued SC mandamus on Manila Bay, directing 13 government agencies to clean up, rehabilitate, and preserve Manila Bay. Several cleanup drives and rehabilitation programs were implemented in Manila Bay area, but the efforts were not effectively manifested in the waters. Awareness and availability of technology for sustainable environment and tourism can help address this issue. Moving ahead, the technologies introduced must be practical and can easily be adopted by industries, so they will be encouraged to set up their own system. This will lead to more establishments complying with effluent standards, which results in greater chances of achieving the objective of rehabilitating Manila Bay. Thank you and have a pleasant day.
A pleasant day to all. Before the COVID-19 pandemic, the Philippines remains one of the fastest growing economies in Asia. In 2017, with a full year GDP of 6.7%, the World Bank latest edition of Global Economic Prospects considered the vibrant economy of our country as the 10th fastest growing economy in the world and the 3rd fastest growing economy in Asia, mainly because of our ecotourism activities. But the greater challenge we are facing is how to preserve the natural beauty of our country's water resources, specifically the pristine water of Boracay Island, and promote and sustain ecotourism industries. According to the studies, 85% of the wastewater generated is released to the environment untreated, and domestic activities is the main source of almost 50% of the total pollution load. The inefficient septic system of households and of micro, small, and medium-scale establishments pose a serious threat to our natural water resources. The sewerage system failure not only caused flood but also degrade further the pollution level of our wastewater. Consequently, most wastewater effluent released to the rivers, lakes, and seas are not compliant with the Clean Water Act and do not meet DNR standards. The UST Region 6 and Adamson University proposed the modular, eco-friendly domestic wastewater treatment to provide an alternative technology that can allow the participation of all sectors in the treatment of wastewater. It will demonstrate the application of meadow for the treatment of use of septic water for our Alte community in Boracay Island, Malay, Aklan. Specifically, the project hopes to improve the quality of domestic wastewater effluent from the Alte community and comply within our Class SB standards. Train Alte community residents on the proper management of meadow facility. Train Alte community members, residents on the potential reuse of treated wastewater in the drip watering of plants and vegetables. Promote awareness of the benefits of freshwater conservation and develop the capability of Ati community in abating public health risks due to water contamination, and demonstrate that a residential community can significantly contribute to the rehabilitation of Boracay Island and not become a source of pollution to its pristine water. Other private sector or other agencies supported this endeavor. One of these is the project of Globe Telecom, which distributed Figurmin to the different households in Boracay Island. But this is not enough. We need another project to sustain water treatment in the community. This is done through bioremediation or biostimulation, where organic wastes are biologically treated or degraded through the application of Figurmin. It uses naturally occurring indigenous microorganisms like bacteria to degrade substances hazardous to human health and to the environment. It also promotes gaseous absorption. Bitumen has a high surface area for the retention of pollutants, and it promotes molecular superstructure for the attraction of cationic or polar pollution load. It also utilizes biofiltration through the installation of buoyant filter media, or what we call the floating bed bioreactor. It uses light density plastic cartridges filter and allow the upflow filtration, which serve as the bioreactor in the meadow system. It improves its clarification stage, and this system is suitable for domestic, small, and medium-scale application. This is a sample of the diagram or the layout of the Figurmin, or rather of the meadow installation plan in Boracay. You will notice that the septic tanks were connected parallel and then connected to the main line leading to the meadow system near the garden of the Ati community. Other activities are information education campaign, where we conducted meetings with the Office of the Malay Acting Mayor then, with the barangay officials of Manok Manok, and also with the Ati village leaders and the Daughters of Charity who were managing the community. The first project information education campaign was aimed to explain project objectives, significance, its expected output, and to promote active support and collaboration among the members of the community. These are the activities that we conducted. This one is about the pipeline excavation works, where the members of the community were actively participating in the activities. The pipeline layout and elevation setting. You have the excavation for the tanks and the elevation setting for all the tanks and the main pipeline. And then the actual tank installation and connections, and the installation of the filter media in tank 3. We also have the drain field excavation and the layout of pipelines. And this is how the drain field of the meadow drain field would look like in preparation for the garden plots. After the installation, we also conducted IEC to promote collaboration on the maintenance and train the community on the proper application of Figurmin in their individual toilets. After months, this is how the garden would look like, and the community now is enjoying the fruits of the garden. These are the samples of our effluent, and you will see how clear the water is after the meadow treatment. So all of these activities actually are aimed towards sustainable ecotourism, not only for the present generation, but most importantly for the future generation. The installation of the system clearly demonstrated how household, micro, small, or medium-scale enterprises can effectively treat wastewater in a cost-effective and natural system. Meadow treatment promotes an effective participation of individual households in a sustainable treatment of domestic wastewater. Meadow installation can be replicated and applied to other communities, specifically or especially in environment challenged areas all over the country. Together, we can ensure sustainable and carefully economic growth for our country. Thank you.
Thank you so much to our project leaders from the environment sector. I hope that everyone here is enjoying their snacks and their coffee. Also, please reserve your questions or queries later on, since we will be having a question and answer portion. I look forward to the day when we will be able to buy the Zeoskin paint in our stores nationwide. And for our compact wastewater treatment system in Meadow, we urge the LGUs and the industries to consider adapting this treatment system for your wastewater concerns. So the pandemic has exposed the need for innovative, more on the engineering sector, as the industry faced lockdowns and construction work made a setback as it entails on-site monitoring and evaluation of progress. Through research and development, smart solutions can be discovered and innovative systems and operations in the construction sector. So may we now introduce to you the project leaders from the metals and engineering sector project. So to begin the presentation, we will be having Engineer Jonathan Puerto from the Metals Industry Research and Development Institute for Project Buhawi. Let's give him a warm round of applause.
Hello everyone. Allow me to present the Project Buhawi, which stands for Building a Universal Mount for Heavy Barrel Automated Weapons Integration. Buhawi is the first locally developed remote-controlled weapon station in the country equipped with a 50 caliber heavy barrel machine gun. The project promotes the adage, Gawang Pilipino para sa Pilipino. Buhawi is a collaborative project undertaken by DOST MRDC, the Department of National Defense with the Philippine Navy, and the Mechatronics and Robotics Society of the Philippines. But first, let us watch a video footage of an actual encounter between the Philippine Navy and insurgents. Please take note that there is a spotter, the one holding the binoculars and giving directions to the gunner. And also, please observe that both the gunner and the spotter are in the direct line of fire. It is in this setting that the project was conceived. So the general objective of the project is to improve the firepower capability of Navy floating assets and provide personal safety through the design and development of an automated gun mount for 50 caliber machine gun. The design of the mechanical system was developed by the MRDC team. The materials used are made from stainless steel 316L, otherwise known as marine stainless steel, to prevent corrosion. Also, 3D printing technologies were used for the housing of components to make the gun mount lighter. For the gun control system, it is both developed by MRSP and MIRDC. We use Python programming because it's a very useful tool for making software prototypes. We also developed 3 algorithms for the tracking and locking program of the Buhawi. In order to prove the functionality, reliability, and durability, a series of land-based live test fires were conducted. The result of the land-based testing was a success. The next step undertaken was installing Buhawi onto one of the Navy's patrol craft, the BRP Heracleo Alano or PC-376. So on April 4, 2022 was the first sea trial testing in the vicinity of Corregidor Islands. Let us now watch a video footage of the sea testing.
Meanwhile, at the PC-376, Navy and MIRDC teams alike prepare for the firing sequence to commence. Once cleared, the firing sequence at different intervals and varying distances began.
Firing. First shot.
Beginning at around 2 in the afternoon, the Dayfire sea trial ended around sunset. With the successful Dayfire, the next endeavor was to test Buhawi's effectiveness during the night at sea. Starting at around 2 in the morning, the current sea state proved to be quite a challenge to the Buhawi. However, after a few more attempts, target was locked and shots were fired. In order to ensure Buhawi's full operating efficacy at night, another test fire activity was done. This time, not only was the target acquired, the floating target sunk due to the hits it sustained.
The result of the sea testing proves that Buhawi is operational and effective at acquiring and hitting the floating target on both night and day at moderate to rough sea states condition. With the success of the live fire sea testing, the Buhawi was turned over to the Philippine Navy on May 20, 2022 by none other than DOST Secretary Fortunato T. de la Peña and DND Secretary Delphine N. Lorenzana. And at present, the Buhawi is being tested for actual operation somewhere at the location of the West Philippine Sea. It is envisioned that more Buhawi units can be locally manufactured to serve the needs of the armed forces of the Philippines. In conclusion, the DOST MRDC, together with its partner, proves that Filipinos can develop and manufacture defense technologies that are at par with the current global trends. Thank you.
For our next presentation, we have Engineer Melanie Cabrera from the Holy Angel University. Please give her a warm round of applause.
Holy Angel University believes that one way of fueling the economic growth of the community is through the academic industry R&D partnerships. To show HAU's commitment to its second strategic objective, to become an authentic instrument for countryside development, the university capitalizes on its resources with respect to its potential technologies applicable for commercialization. The conceptualization of the design and development of a mechanical garlic and cashew chipper all started last 2018 during the year's Science for Change program. Together with the researchers are the DOST-3 and DOST Pampanga, as well as the MSMEs in the food sector. It was raised that time that the MSMEs needed to automate the slicing of garlic cloves and the cashew nuts. For those not familiar kasi, these two products are one of the delicacies that the Kapampangans are really proud of. Anyway, so the automation basically wanted to increase the productivity of MSMEs for revenue increments. To cut the story short, our job is to help MSMEs provide engineering solutions to increase their productivity. The first Cradle project of HAU was born. And that we were still fortunate to have Edelin's Homemade Nuts as the partner agency. We started January 2020 and began to collect problems and information of the corporate agency. We were actually able to create 4 prototypes to date, with that outputs include several challenges throughout the project. Now, to share the challenges during the R&D, here is Engineer Ariel Camilo.
From the workforce point of view, the consequences of the COVID-19 are very direct. From the remote working, social distancing, shift work schedule, difficulties with the materials delivery delays, and the need to combine caring responsibilities with work may all have impact on the fabrication side. COVID-19 challenged us to implement the proper timeline and the importance of the limited time due to the quarantine protocol that to ensure all deadlines are met. All of these challenges are made easy by the way of team effort, with the good collaboration from the fabricator and proper management of the whole project, and also the support of Holy Angel University.
Personally, my advocacy is to be of help to the community. Holy Angel University and the Department of Science and Technology gave me the chance to do something for our community by conceptualizing and providing engineering solutions to the problem of the SMEs in the region through one of the DOST program, which is the CRADLE, or the Collaborative and Research and Development to Leverage the Philippine Economy, because they invited us to participate with the CRADLE program. That was the start. We interview our industry partners, their current situations, and their initial solutions to the problem. Because as proponents, we need first to get the real problem. We can only get that by getting the user story. When we say user story, those are our industry partners or the firm owner or the SMEs. Then we have to discover what are the measures they had taken to solve the problem, where they stopped, and that is the point where we need to start conceptualizing solutions and formulate objectives. As leader, you also need to identify your team members to achieve your objective. Aside from the technical skills of the team, I am also looking for the members with the same advocacy and passion to help the community and discovering something that could advance the science and technology in our country and promote innovations and commercializations. With the right team members, coupled with their determination to help the beneficiaries, the project will surely be of success.
Thank you very much, Engineer Puerto and Engineer Cabrera and team. With the presented technologies, we can see that innovation truly comes in different forms and sizes, which are all necessitated by a need that arises from the industry. We at the DOSC hope that collaborations between the implementing and collaborating agencies continue even after project completion, as they are our ambassadors showing that innovation truly works for the people. Moving forward, we'll now take a look at the projects intended for the manufacturing and the process sectors. Our manufacturing companies actually comprise more than half of the Philippines' industrial sector. This particular industry provides higher employment, income, and output multipliers relative to the agriculture and services sector, and even promotes stronger inter-industry and intersectoral linkages, firm productivity, as well as technological development and innovations. The Philippine government envisions to create a globally competitive manufacturing industry with strong forward and backward linkages to serve as hubs in both the regional and the international production networks of our automotives, electronics, garments, and food, which are all supported by well-managed supply chains. Without further ado, may we now call on the project leaders to introduce the first batch of projects under our process sector, beginning with Dr. Fabian Dairit of the Ateneo de Manila University.
I would like to share with you the results of two projects in a research program on upgrading the Philippine national standard for virgin coconut oil, as well as the Philippine VCO industry. Project 1 is entitled Physicochemical Factors which Affect the Quality of VCO. This is the status of Philippine VCO industry. As you can see, 75% of Philippine VCO processors are micro and small scale enterprises with a capitalization of less than 15 million pesos. These MSMEs need the most assistance in terms of technical requirements in order to maintain the quality of VCO. This is export performance of Philippine VCO from 2006 projected to 2020. As you can see, the exports peaked in 2015 and slowly declined afterwards. This may be due to increased competition globally, which points to the need to improve the quality of Philippine VCO. Virgin coconut oil is the oil obtained from the fresh, mature kernel of the coconut by mechanical or natural means, with or without the use of heat, without undergoing chemical refining, bleaching, or deodorizing. This is RBD coconut oil, and which does not lead to the alteration of the nature of the oil. There are three methods of making VCO. The first is the expeller method, the second is a fermentation method, and the third is a centrifuge method. However, regardless of the method, the quality of the VCO should be the same, and it should meet the standards for VCO. In 2007, the Philippine National Standard for VCO was adopted. Table 1 gives the GC profile of fatty acid composition of VCO. However, this table was obtained mainly from Codex Alimentarius, which is the international coconut products which are obtained, sent to Rotterdam. Therefore, this is not specific to Philippine VCO. Table 2 gives a table of properties of VCO, such as the moisture content, free fatty acids, peroxide value. However, this is not sufficient to ensure the quality of VCO. So there's a need to upgrade the Philippine National Standard to improve VCO quality, as well as to prevent adulteration, in particular, adulteration of VCO with RBD coconut oil. So the objective is to upgrade the Philippine VCO industry as well in order to meet these new standards. These are the results of this study. This is the fatty acid composition by GC. If you compare the fatty acid range from the 2007 PINAS and this work, you can see that this work was obtained from Philippine VCO. So we are sure that the VCO coming from the Philippines will meet the fatty acid profile. We were able to develop a simple method for detection of adulteration of VCO, in particular by RBD coconut oil. So at 2078 nanometers, VCO absorbs below 1.5 absorbance units, while non-VCO samples, including RBD coconut oil and white coconut oil, absorb at around 3 absorbance units. Therefore, the maximum absorbance value for VCO is set at 278 nanometers and should be less than 1.5. Another important result of this study was to understand the effects of various parameters in VCO quality, such as moisture, the effect of microorganisms, as well as high heat. The effect moisture increases the free fatty acids in VCO, which leads to rancidity. Presence of microorganisms gives the acid flavor due to acetic acid, and high heat may lead to the yellowing of the VCO due to the reaction of proteins with carbohydrates during the processing. So as a result of this study, we're able to, we're in the final stages of drafting the new Philippine National Standard for VCO for human consumption, as well as VCO for cosmetic use. I'd like to acknowledge again and thank PCIEERD DOST for funding this project, the Philippine Coconut Authority and the Virgin Coconut Oil Philippines Association for the coordination, and the VCO cooperators who participated in this study. So on that note, we thank you, and we hope that the quality of VCO continues to improve. Thank you.
Thank you very much, Dr. Dairit. For the next project under the VCO program, we have with us Dr. Crisanto Lopez, also from the Ateneo de Manila University.
Good morning, everyone, and welcome to the Innovate PINAS 2022 Philippine Research, Development, and Innovation Conference. I am Crisanto Lopez, and I will be presenting our Project 2 investigation of the microbiological factors which affect the quality of VCO. This is a part of the research program entitled Upgrading the Philippine National Standard and the Improvement of the VCO Industry in the Philippines. To start with, I'd like to give to you the objectives of our study. First, to determine and measure all of the relevant microbiological parameters of VCO products and on-site samples from selected VCO producers, wherein we did a study on the microbiological analysis of samples from the VCO production. The second objective was to correlate the microbiological parameters with physicochemical profile and sensory analysis, wherein we conducted two studies. First, microbiological analysis of shelf life samples, and second, microbiological analysis of commercially available VCO samples. Our third objective was to identify microorganisms that contribute to the deterioration of VCO produced by each of the VCO production methods. In this particular objective, we were able to do metagenome analysis of microorganisms involved in the fermentation-based production of VCO. To present to you some of the highlights of our outputs, for the publications, we were able to, as of now, submit a manuscript and metagenome, and it is now being accepted for publication. The second publication is being prepared, and the manuscript is still being processed. However, aside from that, we were able to present a paper entitled Upgrading the Philippine National Standard for Virgin Coconut Oil in the Philippine VCO Industry, Translational Research for the Coconut Industry, during the research colloquium of the webinar on research and development by the Philippine Chamber of Commerce and Industry. This is under the Education Committee, Subcommittee on Research and Development on July 8, 2021. Aside from publications and dissemination, one of our outputs was also people services, wherein we expected to support students in the accomplishment of their thesis by involving them in the project. However, aside from that, we were able to first support 2 BS biology students and 1 MS biology student and 1 PhD biology student who were enrolled in Ateneo de Manila University. But aside from that, we were able to train and include in our discussions some online talks to VCO producers and their employees on the microbiological safety and quality of VCO. One of them was microorganisms in the VCO production, possible sources and effects, during the technical webinar on advancing the safety and quality of VCO, which was organized by the Project 4 of this particular program on May 14, 2021. The second being microbiological parameters in the quality of VCO during the research symposium Upgrading the PINAS for VCO and the Philippine VCO industry, organized by the Philippine Coconut Authority and the VCO producers of the Philippines on June 16, 2021. As part of our outputs, we also had a collaboration with the Philippine Coconut Authority and the Virgin Coconut Oil Producers and Traders Associations of the Philippines, or the VCOP. The actual output included the two organizations. As part of the policy, we were able to draft revision to the Philippine National Standard for VCO, and specifically, we were able to make a draft to the Philippine National Standard for VCO for submission to the Technical Working Group on VCO of the Philippine Food and Drug Administration. To give you some of what we have done in terms of our journey for this particular project. So our activities included visits to the VCO producers in the first year of the project implementation, wherein we went to 9 different VCO producers all across the Philippines, and we collected samples from the raw materials up to the packaged products. The second activity or set of activities that we did was on Zoom meetings with VCO products and producers and VCOP regarding results of the project for dissemination. This was because we were already implementing the restrictions due to the pandemic. The third one being program meetings for planning, execution, and plans, discussion and analysis of results, and dissemination to various stakeholders. As a call to action, please take note that microorganisms affect the quality and safety of virgin coconut oil. Production of VCO necessitates the application of good manufacturing practices and implementation of an effective hazards analysis and critical control points plan. And third, we would like to really push for the revision of the 2007 Philippine National Standard for Virgin Coconut Oil to be able for us to produce VCO that is safe and of high quality that can compete in the global market. With that, I'd like to thank the project team, namely Pia Clarice Argulpeo, Zomesh Maini, Anne-Marie Matubis, and Ralph Allen C. Geronimo. And of course, we'd like to acknowledge the Philippine Council for Industry, Energy, and Emerging Technology Research and Development, or PCIEERD, the Philippine Institute of Pure and Applied Chemistry, the Virgin Coconut Oil Philippines, and the Department of Agriculture Philippine Coconut Authority, together with the Department of Biology of Ateneo de Manila University. Thank you very much.
Thank you very much, Dr. Lopez. Up next to share her research under the VCO program, we have Dr. Casiana Blanca Villarino from the College of Home Economics of UP Diliman. Let's all give her a warm round of applause.
Good morning, everyone. So before I proceed with the presentation of our project entitled Investigation of Factors Affecting the Sensory Properties and Consumer Acceptability of Virgin Coconut Oil under the program Upgrading the PINAS for VCO in the Philippine VCO industry, let me acknowledge my co-workers, Dr. Maria Concepcion C. Lisada, Ms. Basinang, Ms. Velasquez, Ms. Ong, and Mr. Pagulayan, who served as our research specialists. So the current Philippine National Standard for Virgin Coconut Oil, specifically under Section 4.2, states that virgin coconut oil shall be colorless, sediment-free, with natural fresh coconut scent, and free from rancid odors or taste. So it is clear that there's a need for more precise definitions of these attributes to monitor compliance to this specification. Likewise, there was a need to further understand the factors affecting these sensory characteristics. So our project determined the factors that affect or influence the sensory properties and consumer acceptability of virgin coconut oil. Specifically, we evaluated the effects of processes, adulteration, and storage conditions on the sensory characteristics and consumer acceptability of VCO. We also evaluated its susceptibility to hydrolytic rancidity. So the sensory evaluation method that we developed will be included in the revised Philippine National Standards. The manuals we produce can be used by the VCO manufacturers and service laboratories in the evaluation of the sensory quality of VCO. And more importantly, consumers can be guided in the terms of sensory quality of VCO, especially when they're deciding to buy a particular brand. Okay, the sensory evaluation, let me just give you a brief story of our journey in this project. So sensory evaluations, particularly descriptive sensory analysis, was used to establish the sensory profiles of VCO samples. So we train panelists like instruments to determine the sensory profile of VCO and determine if the differences in terms or differentiate samples from different processes, or determine if the samples were adulterated, and establish its shelf life. So the methods we developed in differentiating the processes, VCO processes, adulteration, and effects of adulteration, and shelf life evaluation or determination from this, we were able to develop manuals both in English and Filipino. And these manuals describe how to prepare the samples, how to prepare the standards in the evaluation of the VCO samples, and up to the evaluation of the samples. And these manuals were shared with our project collaborators, the manufacturers who provided the VCO samples that we evaluated for future use, and of course for their feedback on how we can improve the manuals, how we can improve the manuals. So it is our hope with the results of our study that more VCO manufacturers can improve or maintain the sensory quality of their products with a foregoing interest from both local and international consumers. We believe that Philippine VCO can be a world-class product, but only if manufacturers can provide an acceptable and safe product.
Thank you very much, Dr. Villarino. Up next, we'd like to once again call Dr. Fabian Dairit of the Ateneo de Manila University to present their findings on another project under the VCO program.
I would like to share with you the second study on the upgrading the Philippine national standard for virgin coconut oil and the Philippine VCO industry. This project was entitled the Assessment of VCO Production, GMP, and HACCP. What are GMP and HACCP? HACCP is Hazard Analysis Critical Control Point, which is a systematic and risk-based approach for identifying and controlling hazards to ensure food safety. HACCP is a very important aspect of the food industry. And then, as you can see in this triangle, below HACCP, you have the Sanitation Standards Operation Procedures, and at the bottom, which is the most basic, is good manufacturing practice. In order to achieve HACCP, you have to have GMP as well as SSOP. And HACCP certification is a requirement of the international market to ensure food safety, traceability, environmental sustainability, and fair trade. Therefore, HACCP is very important for the VCO industry. So the objective of this project is to assess a VCO production process using GMP and HACCP and to recommend specific improvements to each of the VCO producers. The status of HACCP implementation in the Philippine VCO industry is still very low. HACCP is one of the most mandated food safety management systems in food processing industries worldwide, and compliance with international product certifications such as HACCP constrains the performance and access of VCO value chain in the export market. Therefore, HACCP is needed for the VCO industry. Right now, many of the VCO industries are medium, micro, small, and medium scale enterprises, they showed low levels of compliance with GMP. Therefore, they had no compliance with HACCP as well. So this project looked at the design and layout of the production plants, and they were not efficient. And there were also unsanitary conditions and practices were observed during our visits. So we undertook plant visits to each of the participating plants, and we collected samples. So shown in these photographs are the plant visits we undertook during this project. We did on-site inspection, and we collected samples of the final product as well as the intermediate products, and we presented the findings and recommendations to the VCO producers. So we wanted to make sure that they understood the importance of GMP, SSOP, and HACCP. During the process of the inspection, we undertook a study of the physical-chemical properties of the whole process, the microbiological contamination that occurs, and how this is cleaned up during the process, the SSOP, GMP, and ASAP, as well as the sensory and the water analysis. So this is an example of the process flow of a VCO production facility, wherein each step was analyzed in terms of the physical-chemical, microbiological parameters, as well as sensory properties. The results were discussed with the companies. So we showed them the initial findings on site during the audit after the first visit. And then after the analysis of their samples, we gave a formal presentation of the findings with recommendations. The evaluation of the action plans was undertaken. So we recommended things for each VCO company to do, and then these were evaluated after a second visit. So the results were verified. The action plans they proposed were verified, and the reassessment of the plant was done in order to comply with GMP and to see that they would comply also as well with HACCP. This is an example of the assessment of a VCO layout plan. So the figure on the left was the original setup, and then with the recommendations, it was recommended that they improve the layout, and that improved layout is shown on the right. Therefore, this project worked very closely with the VCO producers. These are examples of improvements in the plant sanitation in terms of installation of hand washing sinks, entrance door with PVC strips, and the improvement in the comfort rooms, the setup of the husking nuts to minimize contamination, improved sanitary dispensing system, and improved electrical system. So this project also produced several manuals and guidebooks, which were turned over to the VCO producers, and workshops were undertaken with them. So this research program was undertaken by 5 research projects. Project 1 was the physical-chemical factors, which I described earlier. Project 2 was investigation of microbiological factors, which affect the quality of VCO. Project 3 was an investigation of factors affecting sensory properties and acceptability of VCO. Project 4 is this project which I just described, assessment of VCO production, GMP and HACCP. And Project 5 was a moisture and water activity determination and its effect on VCO stability. So this was a comprehensive and integrated research program to ensure that the quality of VCO is improved, as well as the VCO companies themselves will be able to meet the VCO standards. So again, we'd like to thank PCIEERD DOST for the funding. Coordination is acknowledged with PCA as well as the VCO Association, and we'd like to thank the companies, the VCO operators. So on that note, we thank you for listening, and we hope that the VCO quality of VCO in the Philippines continues to improve.
Again, thank you, Dr. Fabian Dairit from the Ateneo de Manila University. And last but not the least, as mentioned earlier by Dr. Dairit, we also have Dr. Erwin Enriquez from the Ateneo de Manila University to discuss or to share his findings on the last project component under this VCO program. Let us all give him another round of applause.
Hi, this is just a short presentation on measurement of water activity and percent moisture on VCO products from the Philippines. I'm Erwin Enriquez from Ateneo de Manila University. So in this short presentation, we would like to note the difference between moisture and water activity, what the mean values of water activity for VCO, and also how we can measure it using the kit that we developed. I will define water activity a little later, but it is important to note now that water activity plays a major role in establishing the stability of foodstuffs. And this of course includes virgin coconut oil, because we know virgin coconut oil can undergo physical and chemical changes which can impact the quality of the product. One such property is the off-smelling odor and rancid taste over time if it's not stored when it is stable. So water activity is an important parameter that establishes stability of the product. There are many ways to mitigate degradation of foodstuffs, and one of the best ways is actually to keep the water activity intact. Water activity is a number from 0 to 1, and the most important value to note is 0.6, because above 0.6 water activity, most microbes will grow. This is just a simple slide trying to illustrate the difference between water activity and percent moisture. Basically, what is generally generated is a so-called moisture sorption isotherm, which is the curve plotting the percent moisture versus water activity. Notice that it's not a linear correlation. So you cannot predict water activity directly from percent moisture because the curve is not a straight line. And so it's important that we have a critical region where, as shown here, above water activity of 0.6, the microbial growth will ensure. And so it's very important to monitor water activity so that we know that the food is already stable. And again, you cannot directly assess it from percent moisture alone. Water, the free water, are the ones that are not strongly bound to the food component, and this is what is measured by the parameter water activity. There is actually not a lot of report when we started the project on the water activity of oil or even coconut oil. So we had surveyed different brands that are commercially available, and what you see here is a plot showing water activity. The stable value is at 0.6, and most products are stable, and there's just a few that aren't above 0.6. And actually, we noticed that there's also a slight dependence on the method of manufacturing the VCO, whether it's centrifugation, expeller, or fermentation type process. And the overall average is good, 0.51. And as again, there are some outliers that go above that value. Unfortunately, water activity is not usually measured because there's no availability of water activity meters, or they can be very expensive. So we have developed in our project an affordable water activity meter shown here, and this is a good test as a way to predict stability. So it's a surrogate test for propensity for microbial growth, and the cost is around less than 5,000, around that value, and we have calibrated it within a good uncertainty range of 0.06. So, and our early feedback from users said that this is good enough for their applications. Of course, the kit is calibrated against water activity standards, and this is used to give very good prediction for the water activity of VCO. As a quick summary, so we have measured the water activity and percent moisture of many VCO products and established that they are within acceptable limits. But it's also important to note that there are differences between different methods of production. And it's important also that we monitor water activity because this is the one that will establish shelf life stability of the product. So we would like to thank the PCIEERD UST and the VCO Producers Association and the Philippine Coconut Authority for their assistance in this project, and of course our partners at the University of the Philippines, Diliman. So we hope that as soon as we can commercialize the kit, that water activity will be a measure that will be monitored in the industry. Thank you.
Wow, that was a great presentation from our VCO program. Thank you to our project leaders from the process sector. VCO truly has a lot of benefits, and it is very important for us to study its profile and develop a Philippine national standards on VCO to identify its possible application with the aim of continually improving the quality of VCO in the Philippines. I hope you are not yet experiencing information overload because we still have a lot more in store for everyone. So we know that you also have a lot of questions in your mind regarding the projects that we have already presented. We are no longer delaying your agony, thus the floor is open for questions. May we request our project leaders present here in Dusitani to please go on stage to join us for our question and answer portion. May I call on Engineer Melissa Buwada, Engineer Reynaldo Esguerra, Dr. Merlinda Palencia, Engineer Jonathan Puerto, Engineer Melanie Cabrera, Dr. Fabian Dairit. Also, we also have project leaders joining us via Zoom Live. We have Dr. Crisanto Lopez, Ms. Carciana Villarino, and Dr. Erwin Enriquez. Please give them a warm round of applause, everyone. Okay. So once again, good morning, everyone. Do we have any questions from our live or virtual audiences? Please raise your hand if you have any questions for our presenters in the first session. So I think some of you are still shy. So to steer the discussion, let me ask a question to our project leaders here present in the stage. This is applicable to all of you, and may I request around the 2-minute answer from you? Well, so may we know with your current R&D projects, with your completed projects. And of course, we hope for your commercialization and adoption of our possible beneficiaries. What is your timeline in terms of putting out your technologies so that it can be used by your intended beneficiaries or the general public? May we begin with Ma'am Melissa?
Good morning, everyone. So that is a very tough question because it entails also a lot of expectation. But we see for Project Zeoskin, we still have a long way to go, but hopefully we are targeting that by the end of in 3 years, maybe we can start the process of commercialization. So we still have a long way to go in terms of tech development.
We have here Ma'am Dr. Merlinda Palencia. May we also hear a comment from you?
Pleasant morning to all. For the modular and ecology-friendly domestic wastewater treatment, we are now currently filing the patent for the design of the system. But since it is modular, the commercialization aspect, it actually will be the adoption of the technology, wherein we just provide technical services. And if the company or the adopter will decide, we will be willing to install them the facility. Currently, some local government units are very interested. We had a meeting with the governor of Ilocos Norte. Also, we have initial meeting with, we installed actually 2 units in Mabini, Batangas with the help of DOST Region 4, Calabarzon DOST. So the commercialization of our product is not something that you need to sell, but rather it is more of an adoption. And we need the support of the environment so conscious local government and business entities so that we can be of service to them. Thank you.
Good morning. Morning, and nice to see a lot of familiar faces finally for the first time after the long pandemic. Well, for those of you who may be familiar with our treatment system, it's already the second version. The first version is a horizontal one for which we have filed for a for IP, and we are looking forward for a patent for this because there are 23 claims for the technology. Now the one that is being shown is a vertical one. It's a variation. So this would be filed for maybe a utility model for that. Right now, we have 2 units of this one already operating. One of the what was presented earlier, and then another one in Calibo, Aklan, and it's working well. No problem according to the adapters. So we're eventually be looking for fabricators of this. The only thing that we're discussing among ourselves, because it's a biological treatment system, is do we also what do we do with the startup of the system? Not the company startup, but when you do biological wastewater treatment, you have to acclimatize the organisms that we use in this. So that's the status at the moment.
We proceed with sir, let us first acknowledge and welcome our virtual participants, our speakers joining us live here. So may we hear from Dr. Lopez about your answer to my question a while ago, sir?
Hi, good morning, everyone. I think it all depends on when the technical working group for the implementation of the national standard will be formed and, of course, be implemented. The results of our study is mainly to provide information with regards to the revision of the Philippine National Standard. And so the data is already there. We're just waiting for the technical working group to be formed, and so we can contribute to the revision of the Philippine National Standard for VCO.
To my question a while ago, may we hear from engineer about your comment on their plan for commercialization, sir?
Yes, good morning, everyone. I forgot to mention in my presentation that the imported one for our remote controlled weapon station costs about 24 million. The development cost for Project Buhawi is only 14 million. If we mass produce it, it will go down definitely about 12 million. And honestly, the Project Buhawi is not part of the modernization plan of the Philippine Navy. It's just like a disruptive technology for them that now that they see that the Project Buhawi is successful, they are now considering as part of their modernization plan. And on September, Project Buhawi will participate on a Navy exercise. They will try to use it. And we have another project for the armored personnel vehicle. It's Project Cobra. It's a smaller version of the Buhawi. We hopefully it will be funded po. And ayun, hopefully with the new leadership, they will now consider yung self-reliant defense posture program of the Department of National Defense. So we're waiting for them to really finalize everything. I hope that this year or early next year po. Thank you.
Thank you, sir. We look forward to that. Before we proceed with Engineer Cabrera, may we go back to our live presenter? We have here Engineer Dr. Erwin Enriquez. Sir, may we have a few words from you po?
Yes, good morning, everyone. I'm sorry I cannot join you so this sit. But for our project, I guess our biggest output is really the availability, the development of an affordable water activity meter. As I mentioned in my presentation, water activity is an important parameter for stability of food and many products, including virgin coconut oil. So we have already disclosed the design of the water activity meter. And in fact, we have already deployed a number of these. And some producers are using the early prototypes that we have given them. And so the next step is really to be able to mass produce them so that many people can benefit from the technology from this project. So again, thank you, PCIEERD, for helping us develop this project that will help the industry. Thank you.
So may we hear now from Engineer Cabrera. But before that, ma'am, may we acknowledge the presence of Ms. Villarino joining us also online. However, she's not able to turn on her camera. So later, we will hear a word from her po. Yes, ma'am, you may proceed.
Good morning, everyone. Ours is a garlic chipper, a garlic cashew chipper from the Region 3. The beneficiary of our project are actually the SMEs in the Region 3 under the DOST Pampanga. So our project or our machine is already available. It's actually already using by the beneficiaries, the Edelin Home and the Wow Money. It is also under, I think, filed under the IP protection right now, and fabricators are also communicated, and I think we have already the fabricator for it. So we can say that ours is already, I mean, it can be available or be ready for commercialization after the approval of the item.
That's good to hear, ma'am. So, not last but not the least, let us hear from Miss Karina Villarino joining us live. Ma'am, may we hear a few words from you po regarding your timeline in terms of putting your technology to our intended beneficiaries?
Can you hear me? Hello? Hello?
Hello, ma'am. Yes, we can hear you loud and clear.
Okay. So actually our technology, I'm not sure if it's really a technology, but it's more of like we developed manuals for the sensory evaluation of our VCO samples. So we've already provided copies of these manuals for sa mga manufacturers, VCO manufacturers, especially our collaborators. So I'm hoping they were able to use it. And as Dr. Chris mentioned, we are contributing to the revision of the PNS, the Philippine National Standards, or revision of the Philippine National Standards in terms of the sensory properties of VCO. So that is the the current situation of our technology, if you can call it a technology. Thank you.
Villarino. So that was a very formative and engaging exchange of thoughts and knowledge. So presenting to you again our project leaders for our first session. May I call you all in front for our photo opportunity. Together with Dr. Paringit, may we request you to join our project leaders here on stage. So while waiting, for those who still have questions, you may approach the speakers later during the break. For those online, kindly type them in the Q&A box and our speakers will answer them for you online. Yes, requesting for the presence of Dr. Paringit on stage for our quick photo opportunity with our first set of project leaders. Okay, that was a refreshing first session that we had. I hope everyone is feeling good, and I hope that we have captured a lot of knowledge from our first batch of presenters here today. So may I call on my partner here on stage to move forward to our next part of the program.
Thank you very much to our project leaders again for sharing the results of their hard work over the past year. So moving forward, here at the DOST, we recognize the hard work of these men and women behind the scenes implementing these projects. Without them, these results and endeavors would not materialize. To recognize the efficient and timely implementation of the projects we support, we are actually giving away the Excellence in Project Implementation and Completion, or the EPIC Award. So now may I call on stage the chair of the 2022 Philippine Innovation Expo, Mr. Mark Ivan Robles, to share more about this EPIC Award. Sir Ivan.
Good morning, everyone. Narito na po tayo sa exciting part. DOST PCIEERD puts a premium on the efficiency and of the implementation and completion of projects and programs that we support. Through our magnificent project managers, palakpakan naman po natin mga PM na nandito ngayon. And also those who are online. We ensure that these initiatives are on time, within budget, and completely accomplished. So, in everybody's friend, kaibigan po nating lahat yung ating project management information system. We are able to track the progress of these projects and ensure that they are accomplished. We thank our esteemed project leaders for joining us in this journey in making sure that we maintain the trust that the Filipino people give us through the funds that are given to us. Today, as we mark our 12th anniversary, we are giving for the first time the Excellence in Project Implementation and Completion Award, or simply the EPIC Award. Palapakan po natin mga project leaders. We looked into the way the completed projects of 2021 were accomplished. We had 3 criteria for this award. 1, budget utilization. 2, timely completion of the project. And 3, accomplishment of the project objectives. Our awardees for this year have at least 90% of budget utilization, finished the project on time, without extensions, and achieved their objectives 100%. We hope that through the EPIC Award, we can inspire our researchers to be diligent and efficient in making innovations work for the people. So to award our first EPIC awardee, I would like to call our newly minted Chief of the Industrial Technology Development Division, Ms. Mary Grace Benavides.
Yes, Sir Ivan. So for the first awardee, let me read the certificate. The Department of Science and Technology, Philippine Council for Industry, Energy and Emerging Technology, Research and Development awards the Certificate of Recognition for their exemplary project implementation and completion in 2021. Awarded during the 12th DOST PCIEERD anniversary celebration with the theme Empowering the Filipino through Innovative Engagement. Given this 29th day of June 2022 at Lusitani, Manila, Makati City. Signed by none other than Dr. Enrico C. Paringit, Executive Director of the UST PCIEERD. So, congratulations to the first awardee, Zeoskin. Round of applause.
Round of applause, please, for our Skin project, the first awardee of our EPIC Award. So may we call on the team members of Skin, a green indoor air filter, to join us here on stage. May we call on Dr. Paringit, our Executive Director, Engineer Escorial, our Deputy Executive Director, our Division Chief, Ms. Mary Grace Benavides, and of course, the Project Manager from the environment sector to join us for a quick photo opportunity. Once again, ma'am, congratulations on receiving this award, and we hope that we were able to encourage more to perform better in your successful project. Thank you so much. And again, congratulations to our team, Skin. I hope that we encourage everyone to proceed, to utilize your budget more and to accomplish your project objectives as well, to be able to be nominated and to be able to receive this award also in the future. So may I call on again Mr. Christian for our next part?
Again, warm congratulations to the Zeoskin team for winning the first EPIC Award of the day. Please do note that this is only the first award that we are giving away, and we still have 3 more actually to be awarded within the day, so please do stay tuned.
Oh yes, now we will continue with our introduction of the second batch of projects under the process sector. So we have here various presentations to be led first by Dr. Juanito Jimenez from the Forest Products Research Development Institute. Let us welcome him with a warm round of applause, everyone.
Good day to all. The DOST GIA-funded project entitled Utilization of Spent Tea Leaf in Tobacco Dust as Additive for Plywood Adhesives was conceptualized by the project team to utilize the untapped potential of these two voluminous industrial and agricultural solid waste as potential replacement for the traditional glue mix additives used in plywood manufacture. The project team was composed of specialists from chemistry, entomology, economics, and wood-based composite panels. Any wood-based panels bonded by formaldehyde-based adhesives can emit formaldehyde gas due to presence of free formaldehyde, which can escape from the panels. This formaldehyde gas, based on studies of the World Health Organization, is carcinogenic and may possibly accumulate in the body through prolonged inhalation or exposure to it. Hence, formaldehyde emission from wood-based panels is regulated by various countries such as USA, Europe, Japan, Australia, and New Zealand. In the Philippines, formaldehyde emission was recently became a mandatory test that need to be passed by plywood manufacturers. On the other hand, one major disadvantage of using plywood as housing components is its susceptibility to termites. There are two types of termites that may attack wood-based structures. One is the drywood termites, and another is the subterranean termites. Both termites are destructive. However, between the two, the subterranean termites is easily detected due to presence of visible mud tunnels, while drywood termites is initially undetected as it does not make tunnel and may be detected only when fecal pellets is found at the base of the wall, floor, or corners of the wood-based products such as cabinets, tables, or plywood partition walls. As a potential solution to these two major problems, wood-based panels, we studied the use of spent tea leaves, an industrial solid waste from making of tea flavored drinks and waste tobacco stalks after harvesting of the leaves, as an alternative glue mix additives in lieu of traditional extender with flour and filler, rice hull, or coconut shell flour. We processed the alternative glue mix additives to produce powder of flour-like texture. Because of the presence of rich polyphenolic substance and protein in the spent tea leaves, it was hypothesized to scavenge free formaldehyde in the wood-based panels. On the other hand, waste tobacco stalks contain alkaloids such as nicotine that can act as repellent substance against termites. The potential impact in the industry and community are the following. For the spent tea leaves, utilization of about 18 tons wet basis daily waste can significantly reduce solid waste disposal by adding value to this material. For the waste tobacco stalks, about 900 kilogram tobacco stalks per hectare can have additional value which may potentially add income to the tobacco farmers. For the plywood producers, the reduction in formaldehyde emission may help pass the stringent requirements of the PINAS ISO standards. For the plywood consumers, service life of plywood may be extended, hence break and replacement due to damages caused by termites may be avoided. Also, there will be better air quality in enclosed rooms due to lesser formaldehyde gas emissions. For the project journey, we formulated several glue mixes both for the urea formaldehyde and phenol formaldehyde adhesive. We tested their pH and viscosity to determine which glue mix can proceed to experimental plywood making. Using the laboratory facilities of FPRDI and veneers obtained from the plywood industry, we made several experimental plywood from the glue mixes that passed the pH and viscosity requirements. We tested the experimental plywood for their bond strength, formaldehyde emission, and the resistance against the drywood and subterranean termites. We use ISO standards adopted by the DTI-BPS as PNS ISO standards to determine the bond strength of the experimental plywood. The same with the formaldehyde emission, we use the PNS ISO standard and established PNS limits for the formaldehyde emission. Based on tests conducted, the best glue mix formulations developed with acceptable plywood properties were piloted to produce full-size plywood in 2 factories. We obtained the pH and viscosity for comparison to our laboratory data. The pilot-produced plywood were tested in actual construction in partnership with a construction company and a house owner operator to determine the workability and performance of the produced plywood. The pilot produced plywood will be observed for 5 years to determine its thermal performance in service, as well as the bond integrity, especially the plywood used for sealing. We are calling on the concerned national government agency and the private industries to collaborate to produce the alternative additives for the use of the plywood industry. The missing link to commercialize this technology is the company which will produce the alternative glue mix additives. For further inquiries, you may connect with us by visiting the FPRD website and contact us through our telephone numbers or by emailing us. Thank you.
Thank you, Dr. Juanito Jimenez from FPRDI. Our next presenter is Dr. Annabel V. Briones from the Industrial and Technology Development Institute, DOST-TDI. Please give her a warm round of applause.
Good day, everyone. Today, we will be presenting one of the latest facilities ITDI has built to better serve the industry, particularly those who are in need of pilot-scale equipment and machinery for their enterprises. This facility is called the Modular Multi-Industry Innovation Center, or MMIC. It is located here right inside the DOST compound and is managed by the Chemicals and Energy Division of ITDI. The MMIC is an industrial processing facility with multifunctional and application modular unit operation equipment that can be retrofitted to different manufacturing lines. This facility was established to address the various concerns of different industrial sectors such as absence of equipment for research and development, economic assistance, technology assistance, and lack of efficient manufacturing facilities. MMIC is envisioned to cater to food, dietary food supplements and personal care products, particularly oral hygiene, as part of its primary lines. The MMIC has 3 processing lines, namely, the nuts and seed oil line, mixed blends and powder line, and the liquid and emulsions line. For nut and seed oils, our facility can offer the use of a screw press, hydraulic ram press, graters, pressure filter, and a vacuum dryer. Meanwhile, for powder and mixed blends, the MMIC can offer a cabinet-type dryer, agglomerator, pulverizer, or hammer mill, V-type mixer, ribbon-type mixer, and a tableting machine for the industry to use. And last, for liquid and emulsion products, our new facility can offer the use of a steam-jacketed kettle, water spray retort, homogenizer, colloid mill, as well as non-viscous and viscous filling machines. For industries or clientele that are interested in our MMIC facility, they may engage with us primarily through 4 ways. First is through the use of facilities. Second is through technical services. Third is by technology transfer. And fourth is through contract research. When clients avail the use of facility or equipment, this allows them to use any MMIC equipment or line they need at a certain fixed fee, and with assistance from one of our personnel, particularly in terms of the equipment operation. When clients avail our technical services, they may submit their products for specific tests and analyses using our available laboratory equipment and instruments. Meanwhile, with technology transfer, a client may adopt any MMIC-developed technology they prefer, subject to a licensing agreement and royalty fee. And last, with contract research, the client and ITDI may agree to conduct a collaborative research and development undertaking, working specifically on the client's concept or idea. The MMIC can assist the industry's research and development needs, particularly about byproduct utilization, new product development, product equivalent, product variances, and product reintroduction. Our research focuses mainly on raw materials that are considered byproducts of commercial operations which could generate new innovative products on food ingredients, beauty nutritional supplements, as well as development of more efficient processes. Currently, we have already developed product prototypes for nuts and seed oil. These include pile pulp oil, calamansi seed oil, and massage oils using VCO with essential oils. For powder and mixed blends, our researchers have also already developed product prototypes, such as dietary fibers from calamansi peels, mango peels, tomato pomace, and pile pulp, as well as a gourmet salt mix product. And for liquids and emulsions, We have now developed product prototypes for tomato garlic sauce, mouthwash, toothpaste, and ready-to-drink herbal teas. As part of our commitment to the people, the MMIC is open to all interested industries, the academe, and other stakeholders. For further inquiries, you may contact our director, Dr. Annabelle V. Briones, or ITDI's Technological Services Division through the following contact details. Thank you very much.
Thank you, Dr. Annabelle B. Briones. So next up, we have Ms. Saila Payag from the Philippine Textile Research Institute. Let us welcome her with our warm applauses.
The current global market projection of printed textiles will reach 36.8 billion square meters by 2024, and this is driven by the technological developments and innovations associated in inks and consumables, printhead, and printing machinery. Digital printing is a technique of transferring printing colorants to textile substrates in a particular design and pattern using inkjet technology. This is one of the fastest growing printing technologies due to its advantages such as high reliability, longer print life, and lower overall cost production. In contrast to textile dyeing, water consumption is less when one opts for printing as means to add color and aesthetic value to textiles. The project development of inkjet CMYK digital printing inks from Philippine natural dyes focus on the development of key digital printing ink colors based on the CMYK system. This provides a basic color gamut that encompasses the fundamental colors needed in printing using endemic natural colorants. The production of digital inkjet printing inks based on the natural dyes aligned itself with SDG 12 as it is a business proposition that is set to catalyze and offer additional prospect through development in the capability to do eco-friendly digital printing on textile and beyond. The need for backward integration to mobilize raw material sources needed to sustain the value chain will extend the reach and distribute the value created and generated to countryside farmers, processors, producers, gatherers, and this time, the mobilization of the strategically positioned PTRI nut dyes production hubs. This initiative aligns itself with SDG 8. Through the nut dyes hub and facilities scattered all around the Philippines, 7 natural dye sources were identified as base colorants for the formulation of digital printing inks. Natural dye colorants were extracted using an optimized solvent and aqueous extraction process appropriate to the individual natural dye sources. This extraction process targets specific colorants. Large-scale batch extraction was conducted to the natural dye extract and powder production to maintain quality and minimize variation of samples. All extracts and natural dye powder samples were evaluated for pH and colorimetric properties before development for digital printing. Heavy metal, skin dermal irritation, microbial activity profiles were also used as reference to ensure proper handling and sterility of the raw materials. Under the Nut Dyes Digital Printing Inks or Nut Dye DPI brand, these inks were formulated, standardized, tested, and evaluated for their performance, thus establishing its color on natural textile fibers. The formulation was optimized to meet the standard requirements of the industry and also compatibility with selected printhead. Digital printing performance of the developed nut dyes inks, including color and fastness, was also evaluated. Digitally printed cotton blended fabric showed color array limited to basic shades, which showcases the potential of blending these colors in different proportions to create a myriad to get a large number of colors. Widening the range of digital printing colors can be possible by looking for more combinations of natural dyes with good synergy with one another. The use of brighteners and neutral color boosters may also be explored. So partner with us as we commit to develop an environment-friendly and sustainable digital inkjet textile printing and beyond.
Okay, thank you so much, Ms. Zaila Payag, for your presentation. Now, we have Dr. Arnold Lubguban from the Mindanao State University, Ligan Institute of Technology, to present the first project under the polyols. So please give him a warm round of applause.
How do you turn post-harvest waste rice straws into roof insulation for buildings? Our team proudly presents Lignopol and LignoRoof, rice straw-based research products from our completed project on the production of bio-based polyols from lignocellulosic biomass. All around the globe, energy efficiency is becoming more and more important in buildings, vehicles, and electric devices, which will lead to the increasing use of polyurethane as insulating material. Polyurethane production results from the reaction of polyols with diisocyanates, which are mostly derived from petrochemical feedstock. The growth in demand for polyols is largely a function of growth in polyurethane foam usage, a multi-billion-dollar industry with an estimated global market of $95.13 billion in 2019. The compound annual growth rate is about 12%, a significant indication of how this market will grow. This project dealt with the research, product development, and pre-commercialization of alternative bio-based polyol and polyurethane insulation products, namely Lignopol and LignoRoof, respectively. Its overarching goal is to ease global dependence on petroleum through the use of alternative bio-based raw materials such as rice straw and crude glycerol as solvent. Lignopol was produced through a patent-pending liquefaction process by which rice straw is liquefied catalytically along with crude glycerol. Lignopol was then used as the main reactant in the production of LignoRoof. LignoRoof is a polyurethane foam roof insulation in the form of prefabricated insulation blocks. Our research products address multiple problems existing globally and in the Philippine economy's agriculture and construction sectors. Globally, there is tremendous pressure to move towards using renewable alternatives as raw materials for the manufacture of industrially important products. In the Philippines, coconut and rice farming significantly constitute a big part of our economy. Adding high value to rice straw, which is considered an agricultural waste from rice farming, and low-grade coconut biodiesel's byproduct crude glycerol to produce Lignopol is the major impact of this project. LignoRoof performed at par with existing available roof insulation brands in terms of standard R-value, compressive strength, and density. This project's journey started out with USAID Science, Technology, Research and Innovation for Development, or the STRIDE program, as a research grant award to MSU IIT in 2016. The small laboratory facility pioneered the research on biomass-based polymeric material synthesis and testing in this institute. With significant data gathered in a year's duration of the research project, the polyols and polyurethane projects came about in 2017 as a part of the 3-year research program under the Department of Science and Technology, Philippine Council for Industry, Energy and Emerging Technology Research and Development, or the DOST PCIEERD. This external grant had a significant impact on the research capability of MSU IIT, especially in the field of material science, and engineering and has grown in its capacity to provide technical expertise and testing services related to polymeric materials. The facility has since shown excellence in sustainable polymer research and development owing to the Institute's strong administrative and research faculty support and hard-working research personnel. As for our research product, Ligno roof foam insulation is being produced using cheaper and renewable lignopol. Based on initial estimates, you can save at least 1,000 Philippine peso on HVAC electricity bill per square meter of insulation installed in homes and buildings. With a simple chemical process and low-cost raw materials, these translate to relatively lower production and product costs, which are economically advantageous to startup companies or licensees willing to adopt this technology. With our insulation product, Ligno Roof, we go green to build green.
All right, thank you, Dr. Lugbuban. Now to proceed with Polyols Project 2, we have Dr. Arnold Alguno, also from Mindanao State University, Iligan Institute of Technology. Please give him a warm round of applause.
Is it possible to turn coconut oil into a protective anti-corrosive coating on metal surfaces? Our project on the development of anti-corrosive coatings from vegetable oil has successfully accomplished this task, effective as a green alternative to its existing organic counterpart due to CocoShield's comparable waterborne and anti-corrosion properties in addition to its other physical properties. Anti-corrosion coatings are used in various end-user industries to protect metal components from structural failures caused by corrosion. The product is heavily consumed where metals are consumed in large quantities, including oil and gas, automotive, and infrastructure. The biggest challenge for end-user industries is to choose anti-corrosion coatings with a little impact on the environment. Thus, the demand for waterborne anti-corrosion coatings will rise significantly in the coming years. The global anti-corrosion coatings market size was $13.5 billion in 2020 and will showcase a growth rate of around 4.3% CAGR from 2021 to 2027. This project dealt with research, product development, and pre-commercialization of alternative coconut oil-based polyol and polyurethane waterborne anti-corrosive coating, namely CocoShield. This is a groundbreaking work that utilized coconut oil as a major component in the polyol blend for the synthesis of waterborne polyurethane coatings for corrosion protection. Coconut oil was successfully functionalized using a patent-pending process to produce the bio-based polyols blend. Globally, there is a tremendous pressure to move towards using renewable alternatives as raw materials for the manufacture of industrially important products. In the Philippines, the coconut industry constitutes a big part of our economy. This project answers to call to boost the Philippine coconut industry through research and development of high-value coconut products. CocoShield perform at par with existing available anti-corrosive and waterborne coating brands in terms of its major and important physical properties. These projects' journey started out with USAID's Science, Technology, Research and Innovation for Development, or the STRIDE program, as a research grant award to MSU IIT in 2016. The small laboratory facility pioneered the research on biomass-based polymeric material synthesis and testing in this institute. With the significant data gathered in a year's duration of the project, the Polyols and Polyurethanes project came about in 2017 as a part of the 3-year research program under the Department of Science and Technology, Philippine Council for Industry, Energy and Emerging Technology, Research and Development, or the DOST PCIEERD. This external grant had a significant impact on the research capability of MSU IIT, especially in the field of materials science and engineering, and has grown in its capacity to provide technical expertise and testing services related to polymeric materials. The facility has since shown excellence in sustainable polymer research and development owing to the Institute's strong administrative and research faculty support and hard-working research personnel. Cocoa Shield is now in the pre-commercialization stage. With its simple chemical process and low-cost raw materials, this translates to relatively lower production and product costs, which are economically advantageous to startup companies or licensees willing to adopt this technology.
That was a great presentation from Dr. Alguno. So moving forward, let us welcome Dr. Dominica Dacera from the University of Philippines, Mindanao. May I hear a clap of hands for her? Let's welcome her in her presentation.
Good day, everyone. I am Dominica Dacera from UP Mindanao and the leader of the project entitled Value-Added Product from Fruit Processing Waste, Acetic Acid for Potential Industrial Application. My co-project leader is Professor Jennifer P. Fronteras, and Ms. Daisy Balio and Ms. Kathleen Joy de los Santos are our research and administrative staff, respectively. Before I start with my presentation, let me first express my thanks to DOST through PCIEERD for providing the financial support and technical advice to our team. Waste from fruit peels pose increasing disposal and pollution problems as they represent a large fraction of the fruit. One mitigating measure to address this concern is conversion of this waste into high-value products. The general objective of the study was to investigate the potential of using food processing waste to produce value-added products. Specifically, the project aimed to determine the physicochemical characteristics of fruit peels, to produce acetic acid from fruit peels using individual fruits and mixtures of extracts, including the pasteurized liquid from Davao Thermobiotech, or DTBC, which is a local solid waste treatment facility in Davao, to determine possible pesticide contamination of fruit peels before and after processing, and to determine the economic feasibility of producing acetic acid. Physicochemical characterization using AOAC method showed an initial sugar content of 12.6% for banana peels, 11.61% for pineapple peels, 14.24% for calamansi peels, 18.65% for mango peels, and for mixed fruit, it's 21.38%, and for DTBC, it's 6.24%. Further, the pesticide residue analysis in the peels revealed that organochlorines, where 20 compounds were analyzed, organophosphorus, where 19 compounds were analyzed, and pyrethroids, where 17 compounds were analyzed, are way below the maximum residue limit set by regulatory agencies. Processing the peels to achieve various sugar concentrations of 15%, 20%, and 25%, and the subsequent addition of the yeast Saccharomyces cerevisiae allowed the peels to undergo anaerobic fermentation to produce ethanol. Aerobic fermentation of the extract with Acetobacter acetate converted ethanol to acetic acid. Now, these figures show the result of the laboratory scale analysis. Among the samples used for fermentation, banana peels seem to produce a relatively higher acetic acid concentration at the shortest possible time. It was therefore selected as raw material for pilot scale study. After anaerobic fermentation, the maximum amount of alcohol obtained was 10.12%, which were then subject to aerobic fermentation to produce acetic acid at 4.66% on day 19 with a pH of 3.31 and room temperature. The total fermentation time was 30 days. A feasibility study was done using cost, volume, profit, or CVP analysis to determine the commercial viability of acetic acid production from banana peels to be sold as a non-toxic herbicide. Assuming 20,000 liters of acetic acid per month, the CPP projection revealed that the actual cost of production is much less than the assumed selling price. And since the total production cost is less than the profit margin, the business is profitable for the company. The plant design was also based on 20,000 liters capacity, and this describes actually some design considerations of the plant. The turn-up ratio of 120% and turn-down ratio of 50% were assumed in the plant design. Now, this figure shows the process flow chart for a full-scale acetic acid production. Aside from the unit operations identified here, a wastewater treatment facility is also included to comply with the regulatory requirements. Indeed, utilization of fruit processing waste can produce value-added products which can be economically feasible. This waste management option prevents the loss of valuable biomass and nutrients which would have been disposed in landfill, causing the generation of foul odors and leaching of undesirable organics, resulting in the pollution of groundwater. With regards to challenges, of course, just like other research projects, we have also encountered several challenges, foremost of which was the pandemic. A team member got positive in COVID, and most of us have been identified as F1 and F2 and had to undergo quarantine, which has actually hampered the project implementation. Also, during the lockdown, the fruit processing factories were closed, so the raw materials were not available. This prompted us to request for an extension, which was graciously granted by PCIEERD. With the extension, we were able to meet all the project objectives. Let me end this presentation by again thanking PCIEERD, including the fruit processing factories which support the project, and to everyone who, in one way or another, has contributed to the success of the project. Thank you very much.
Thank you, Dr. Dominica Becerra. Now we have the last presenter from the process sector. Let us welcome Dr. J.R. Ventura from the University of the Philippines, Los Baños. Let us welcome him warmly with our applause.
Good day, everyone. Please allow us to present the completed project headed by Dr. J.R.S. Ventura of the Department of Engineering Science, UPLB. The title of the project is Polyhydroxyalkanoate Production from Agricultural Residues. This is in collaboration with the UPLB Biotech. Plastic has become one of the basic human commodities because of its versatile qualities of strength, lightness, and durability. Its inertness, however, made it one of the recalcitrant pollutants in the environment. Plastic pollution has already been a serious problem in our world's ocean. In a study conducted by the United Nations in 2006, it was predicted that an empty ocean is inevitable by 2048. Among the plastic offenders, the Philippines is third next to Indonesia and China. Alternatives to petrochemical-based plastics, categorized as chemically synthesized polymer, starch-based, PHAs, are already available in the market. Note, however, that not all bioplastics are biodegradable. It is only PHA that is ultimately biodegradable. Realizing the problems that arise in the use of conventional plastics, PHA could be an excellent candidate. PHAs are water-insoluble, ultraviolet-resistant, biocompatible, sinks in water, non-toxic and less sticky, and have properties that may be manipulated by blending polymers or through genetic modifications. Since PHAs have almost similar properties to fossil-based plastics, it could be used in single-use plastics such as bottles, sandal bags, containers, straws, cutlery, and films for food packaging. PHA has a lot of applications not only as a replacement to common plastic commodities, but also to some specialized high-value applications such as in pharmaceuticals or medical fields. To show you the project's journey, the project has made a lot of developments such as the following: identification of a well-performing local strain, collection and testing of agricultural residues for PHA production, pretreatment and hydrolysis optimizations parallel to model fermentation optimization studies, production of PHAs from actual hydrolysates, improvement of the PHA product, and finally, PHA production using a 20-liter bioreactor. We have also conducted incorporation of natural fillers in PHP to improve its property without compromising its biodegradability. For the scale of production of our project, corn stover biomass was collected. We processed the biomass to a powdered form. These are the processes that were employed: undrying, oven drying, shredding, hammer milling, and cutting milling. We need a lot of corn stover hydrolysate or substrate for the PHA production. Hence, we seek the help of a third-party service provider, Taiwan Einer. This is the whole picture of the PHA production process using agricultural substrates such as corn stover. First was the biomass and hydrolysate preparation, followed by fermentation to produce PHA, and finally extraction to get the crude PHA. In conclusion, the PHA market has a potential in the Philippines. Cheap and abundant feedstock can lower PHA cost. Incorporation of natural fillers or biopolymers may improve PHA property and lower product costs. There is a need to find the proper niche for the PHA market. There are many explorable areas for the material development of PHA. These are the core members of the PHA project. Thank you for your attention.
Thank you very much, our dear project leaders from the process sector. You can see how diverse the supported projects of the USC are, ranging from the development of plywood adhesives, polyurethane-based products, acetic acid, and more, which are all sourced from renewable and waste materials. So for the MSMEs, LGUs, or companies out there or are joining us here today who are looking for possible solutions to your problems, look no further than these projects presented earlier. We also reach out to our project leaders so they could assist you in determining the specific assistance that you would need. For the next part, we'll now listen to the next set of researchers coming from one of the 21 sectors that PCIEERD is handling. Over the years, many critics have argued that irresponsible mining is still apparent, which causes destruction of our natural resources. To ensure that we prevent further mishaps, sustainable mining should be strictly implemented. We at the DOST are optimistic that the Philippines is heading towards the right direction with our research and development investments geared towards finding viable solutions for our mining sector. It is our belief that for us to truly make sustainable mining work, we would need to have the indigenous people capacitated and involved in our initiatives, our policies changed, our mining and manufacturing industries connected, as well as to have our mining initiatives truly backed by science. To give us further details about our sustainable mining projects, we'd like to welcome Mr. Chris Reven Gibaga, the project leader for the first batch of mining and mineral sector projects. May we all give him a warm round of applause.
Good morning. I am Cruz Rebengibaga of the UST PNRI. Today I will be presenting our project, Characterization and Resource Estimation of Valuable Rare Earth Elements and Natural Radionuclides in the Philippine Coal and Feldspar Deposits. Critical raw materials are defined as materials that are economically important but have a high risk related with their supply. The European Union listed 30 CRMs, including REEs or rare earth elements. Rare earth element is the collective name for 17 chemically similar elements, the 15 lanthanides, lanthanum, potassium, together with yttrium and scandium. REEs have diverse application in several industries such as clean energy, electronics, aerospace, etc. China is the leading RE producer, and its monopoly adds to the uncertainties to the RE supply picture. Since RE supply is not sufficient in the next 15 years, researchers are looking for alternative RE sources. In the US, elevated RE contents are discovered in coal basins, while in China, the weathering material of granitic rocks, which is mainly consists of feldspar, is considered an RE source. The overall objective of the project is to characterize the valuable REs and radionuclides in the Philippine coal and feldspar deposits using handheld leaves analyzer for REs and handheld gamma ray spectrometer for natural radionuclides. Leaves or laser-induced breakdown spectroscopy is an emerging tool in mineral exploration. Our industry partners for this study are Semirara Mining and Power Corporation and PNOC Exploration Corporation or PNOCEC. Leaves analysis shows that some REEs in both Semirara and PNOC coals are higher than the crustal average. PNOC has higher total REEs relative to Semirara coal, and based on the current prices, the REEs in Semirara and PNOC coal ash samples could be worth 53 and 94 US dollars per metric ton, respectively. Regarding the radionuclide contents, potassium, uranium, and thorium in Semirara and PNOC coals are close to the average crust. Surprisingly, elevated gold contents are reported in Semirara and PNOC coals. The gold content of PNOC coal is up to 0.5 grams per ton, higher than the 0.32 grams per ton gold cutoff grade in Padcal mine. For feldspar deposits, the RE content of Ilocos Norte feldspar is below the crustal average, while the RE concentrations of El Nido feldspar are almost 2 times higher than the average crust. Also, Ce, Sm, Dy, and Y contents of El Nido feldspar are close to the cutoff grade of RE mines in southern China. The RE in El Nido feldspar could be worth 45 US dollars per metric ton. The radionuclide contents in Ilocos Norte feldspar are also close to the average crust. In contrast, the reported radionuclides in El Nido feldspar are higher than the average crust since Northern Palawan has a continental affinity. To analyze REEs, our handheld leaves analyzer was calibrated using a spectrum standardization method. We also compared the handheld leaves result with the laboratory ICP-MS result. As shown in the table on the right, LACE, PR, ND, SM, and GD contents of El Nido feldspar determined using leaves are close to those obtained using ICP-MS. Results suggest that handheld leaves can be an alternative to ICP-MS in determining the values of some REEs in feldspar samples. Based on our study, we encourage the funding agencies and coal mining companies to invest in R&D studies related to the physical beneficiation of coal ash to further enrich the RE contents and to conduct further studies about gold occurrence in the Philippine coal. The United States, they are investing millions of dollars in coal RE research. We also recommend government agencies and exploration companies to conduct detailed mineral exploration in the El Nido feldspar deposit and to explore other areas for RE-bearing feldspar deposits like Mindoro and Tawi-Tawi. We also invite interested parties for possible collaborations to utilize leaves in determining REs in different geological materials. And lastly, we encourage the government and the mining industry to consider developing our coal and feldspar deposits as alternative sources of REs, especially since RE mines in southern China has been closed since 2016. We should grab this opportunity to benefit economically from these potential RE sources. For further details and possible collaboration, don't hesitate to contact me at my email and our telephone number. Thank you very much. Good morning. Today, I will be presenting our project, Application of Radiation Techniques in Geochemical Characterization of Cobalt and Other Valuable Metals in the Selected Metallic Deposits. Critical raw materials are defined as materials that are economically important but have a high risk related to their supply. Examples of these are cobalt and scandium. Cobalt is one of the critical components of electric vehicle batteries. Driven by climate change and energy security concern, many plan to transition to electric vehicles. Cobalt is the only EV battery raw material that is now considered as CRM. It is because it is estimated that from 2023, there will be a deficit in the cobalt supply. Also, in DR Congo, the primary source of cobalt, child labor remains a problem in cobalt mines. This is the reason why EV manufacturers are looking for an alternative source of cobalt. One of the mineral deposits considered as cobalt source is nickel laterite. Luckily, our country has several nickel laterite deposits as shown on the map. But previous mineral resource estimations done by laterite mining companies did not consider cobalt content of their laterite deposit. The project's overall objective is to apply radiation techniques such as LIBS and XRF or X-ray fluorescence in characterizing cobalt and other valuable metals in selected Philippine metallic deposits, which include nickel laterite and other metallic deposits are shown in the map. So these deposits are located in different parts of the country. Our partners for this study are Mount Labo, Mark Ventures, Philex Mining Corporations, Jose Panganiban LGU, MGB Region 3, and MGB Region 5. Geochemical analysis shows that high cobalt contents are present in nickel laterite and Panganiban skarn samples. Nickel laterites and bauxite samples have high scandium concentrations. High copper concentrations are reported in skarns, massive sulfide, epithermal gold, and porphyry copper samples. And lastly, skarn and beach placer samples have high iron concentrations. Summer bauxites also have high REE contents are shown in the table. This study is the first to characterize REEs in the Philippine bauxites. Based on the current prices, the REEs in summer bauxites could be worth $246 to $323 per metric ton, respectively. High uranium contents are also reported in Panganiban skarns. Uranium contents up to 1,000 ppm is detected in an outcrop in Nakalaya. High gold and silver contents are also reported in the waste rocks from Paracali epithermal gold deposit. High concentration of precious metals, palladium and platinum are present in Pulang Daga nickel laterite. To analyze valuable metals and laterites, our handheld LIBS analyzer was calibrated using spectrum standardization method. We also compared the handheld LIBS result with laboratory ICP-MS result. As shown in the table, nickel, cobalt, scandium, chromium, and zinc contents determined using LIBS are close to those obtained using ICP-MS. Results suggest that LIBS can be an alternative to ICP in determining the values of valuable metals in laterites. LIBS can also perform elemental mapping. In this epithermal gold ore sample, gold and cobalt are associated with pyrite and iron sulfide, while silver and nickel are related to chalcocite or copper sulfide. LIBS elemental mapping is helpful in determining the mineral association of critical and precious metals. Based on the results of our study, we encourage the nickel laterite companies to characterize and to recover cobalt and scandium in their nickel laterite ores instead of giving them away for free to the overseas processor. Our revenue from nickel laterite ores could increase by 4 to 11 times if we recover cobalt and scandium. We also invite interested parties for possible collaboration to utilize LIBS in determining valuable metals in their metallic ores. We recommend funding agencies and mining companies to support R&D studies that recover cobalt, scandium, and other valuable metals from their ores using novel solvent. And we encourage government agencies and interested companies to conduct detailed mineral exploration in Pulang Daga nickel laterite deposit and to consider Panganiban skarns as potential sources of uranium for nuclear energy. Especially the Philippine government approves the inclusion of nuclear program in the energy mix. Lastly, we encourage the government and mining industry to conduct further inventory and characterization of other critical raw materials in the mineral deposits of the Philippines to fully utilize the economic benefits we can get from these deposits. For further details and possible collaborations, please contact me at my email and our telephone number. Thank you very much.
All right, thank you to Mr. Chris Ibaga for presenting the first batch of projects under our mining and mineral sector. Now we are again opening the floor for your questions. We encourage everyone to ask questions as this is a great opportunity for knowledge sharing. Again, may I request our project leaders present here to join us on stage for our open forum. May we have we have here Dr. Juanito Jimenez joining us live via Zoom. May we have Dr. Apollo Victor Bawagan representing Dr. Annabel Briones. May we call on Ms. Zayla Payag, Dr. Arnold Dugguban. We have Dr. Roberto Malaluan representing Dr. Arnold Algudo. We have Dr. Dominica Dacera joining us via Zoom. We also have Dr. J.R. Ventura. And last, we have Mr. Chris Reven Kibaga. Please go up here on stage po for our short question and answer portion. Okay, so I hope our participants have burning questions or clarifications for our project leaders. May I have a raise of hand for those who have questions for our presenters here in front? Okay, I think our crowd is a bit shy. Maybe later on you can message or chat with our presenters if you have any clarifications or queries for them. So let me just ask you again po, on behalf of our participants, I'll be the one asking you so that we can have a productive discussion here this morning. So my question for all of our presenters for the second batch is that, what were the challenges that you experienced in implementing your project and how were you able to handle this hurdle? Maybe begin with you, ma'am.
Thank you for your question. So I think it's 2020, so pandemic time talaga siya. So the biggest challenge is the people doing the research and of course the testing. Okay, the project implementation is 2020, so definitely it's the pandemic time, height of the pandemic. And the major problem would be the manpower doing the laboratory activities. But still, our COS and people doing the project would come and stay at the office, dedicating their time to do work at the office. And also, the testing of our samples. So usually we submit our samples to a testing laboratory, and definitely the long queue of testing samples would really affect the implementation of the project. So that's only. Thank you.
Sir, may we hear a few words from you?
Thank you. Good morning to everybody. For the MMIC facility of ITDI, our major problem during that time was in the infrastructure, the facility, the building itself. We had difficulty in the completion of our building structure. However, what we did with our facility, since it's compartmentalized, so we did some activities even though the whole building was not yet completed. So some of the activities were already ongoing even though there were construction. So those activities, aside from the equipment acquisition, so those were really a struggle for us. But we eventually completed the whole facility, and it's now ready for adoption by our industry, MSMEs. Even the academe has already availed of our services at MMIC. So it's now open to the public.
That's great to hear, sir. Now may we hear a few words from Dr. Juanito Jimenez joining us live via Zoom. Sir, can you hear us?
Yes, good morning. Can you hear me?
Yes, sir, we hear you loud and clear.
Okay, regarding the challenges, actually, our main challenge in the implementation was to convince the plywood manufacturer initially to try the formulation we made. But then, nung nakita naman nila yung mga data namin sa laboratory na talagang possible. So, nakapag-pilot din kami. Una kasi parang nahirapan kaming doon sa piloting part. Pero okay naman siya. Tapos nung isang major challenge nung nag-implement pala kami ng piloting, yung second piloting namin, ito na nag-occur yung pandemic na eh. So yung unang cooperator namin, is parang ayaw nilang magpapasok sa planta, nag-back out na. So naghanap kami ng another cooperator. It was December 2020, and then nag-piloting kami, second piloting na 2 weeks before mag-end yung project. That was March 2021. So okay naman. So na-conduct namin yung piloting, and then we test the properties of the panel. Actually, tapos na yung duration ng project, pero ginawa pa rin namin yung mga tests. And then, okay naman yung mga results. And then we actually now are present namin sa kanila and also sa cooperators sa National Tobacco Administration. They're excited kasi magkakaroon ng parang feeling ng additional income yung mga tobacco farmers sa pag-produce ng additive. So siguro ang challenge dito is sino yung magpo-produce ng additive, kasi base doon sa study namin okay naman, kaya lang ang tanong sa amin ng mga manufacturers, saan kami bibili ng additives na pinopropose nyo. So siguro yun yung next step na gagawin namin sa project, convince yung mga small companies na mag-produce ng additives. Actually, we are starting na with the NTA. May mga nakausap na sila na mga small tobacco farmers cooperative na willing na mag-produce ng additives. Yan po. Thank you.
Thank you for sharing that to us, sir. So to virtually continue the discussion, maybe first hear from Dr. Dominica Dacera to share her insights on their hurdles for the project. Hello, ma'am. I think you're on mute po.
Sorry. Hi, good morning. Yeah, thank you. And of course, first I would like to congratulate PCIEERD for its 12th anniversary, And actually, I have mentioned the challenges that we have encountered already during my presentation. And that's the major challenge was actually the pandemic, because one of our staff actually got positive, so she cannot work. And of course, all the experiments would have to be delayed. And another thing is that the source of raw materials, because we collect the raw materials from the factories, and during that time, that was already actually locked down. So we could not get the raw materials. But of course, eventually, we were able to get it. But of course, there has been a delay in the project implementation. And I was thankful that we were granted an extension to be able to meet all the project objectives. And another challenge was that we were supposed to do field trials as well as a continuation of the project, but we did not push through because, again, of the pandemic. But overall, actually, we have overcome those challenges, and I would also would like to congratulate the other project leaders who were able to accomplish their objectives despite all these challenges that we met. Again, thank you very much.
Thank you, ma'am. So I think the project leaders were really affected by the pandemic. It really shows that even as PM, we were able to connect on how you were encountering those problems during the implementation. It was really a big hurdle, really, during 2020 and 2021. Now we proceed to our gentleman on the left side of the stage. May we begin with you, sir.
Good afternoon, everyone, and thank you, PCIEERD, for the support for our completed projects. So I think I agree with everybody. It's the pandemic, and it's really a challenge for our procurement, especially that we are doing the 40-liter pilot testing for Lignopol in the presentation a while ago. We have to procure chemicals from Luzon, and we are doing it in Mindanao. And then so the logistics really a challenge for us. So, but despite this, the scheduling actually is one of those things that we really need to arrange with the university. So despite that, because of our very willing RAs and also very supportive admin, so we did we successfully implemented our objectives. So the 40 liter, and then the reactor, and then the chemicals, and also some catalysts. Those are hard to find. So yes, those were the challenges really that mahirap sa amin during the pandemic.
Mayang buntag sa kanan. Okay, in the case of the Cuckoo Shield, the anti-corrosive coating, one of the challenges is how you functionalize the coconut oil into its polyol. Kasi yung objective doon, nag-iba talaga in the actual implementation. So thanks to our researchers, na talagang silang nag-research na talaga, and then we really come up with the polyol coming from the coconut oil. This is the first time na naging polyol yung coconut oil. So actually, we applied a patent for this already. And also another one is yung testing na ngayon ng ating anti-corrosive coating. So we need to have a partner. So thanks to Cambridge Technologies Incorporated. So sila yung tumulong din sa amin for the industrial testing. So, and also their technical advice, because from time to time we have a meeting with them. So giving us the feedback on how to improve our product, the anti-corrosive coating. So daghang salamat.
Sir, you may proceed in sharing your hurdles for the project.
Okay po. So good afternoon po. So actually my own challenge in conducting our research is that this is my first project. So initially we don't have the resources. So I don't know how to start the project itself, but because of the help of UPLB Biotech, so we initiated the project. Not that smooth, but it's going well. We have a lot of project objectives, as you can see in our presentation. But and another problem is we only have one research assistant and one laboratory technician. So we have problem on the people. But because we have students that is working on project, we deliver, nagawa naman po ng maayos yung project. And another one is problem on resources. So one part of the project is also on the upscaling of the whole technology. So we're just working on the lab scale. So we don't know how to produce this voluminous sample for the fermentation operation. So we tried to search for a third-party provider, but the process of getting this or acquiring the services of a third-party provider through procurement is not that easy. So you need to undergo several process. So that's one of the major hindrances in delivering our project. So it took us I think almost a year to procure the services of a third-party provider. So I think although these challenges, I think we deliver the project, all the objectives. I think we accomplished it. Not on time, but I think nagawa naman po siya.
Thank you, sir. Last but not the least, may we hear a few words, sir?
For us, for the coal, feldspar, and cobalt project, our main challenges is the travel restrictions during the pandemic, since for our project, we need to collect samples in specific mineral deposits to determine the elemental concentrations in the sample. So I think we are the few researchers that's conducting field works in 2020 and 2021. I think the first part of 2020, we conducted the field work without vaccine. So we risk ourselves for the research and for the science. So I think, but by the grace of God, we are able to deliver what is needed in the project. We visited all the required coal and feldspar deposits and almost all metallic mineral deposits in the Philippines. Thank you.
Okay, so thank you to our project leader. So it really is that despite the pandemic that we have encountered, the projects were able to be completed. They were able to deliver the accomplishments and the expected outputs. And it really shows that the completion of the team, the inputs from the RAs, the students were really complementing the project as a whole. And so it was able to be completed. So aside from the hurdles, it was still a great news that we are here graduating as completed projects. So presenting to you our batch 2 of graduated project leaders. So please go in front for our photo opportunity. May I also call on Dr. Paringit to join us. So let's give them again a warm round of applause for our batch 2 of project leaders. Again, thank you so much to everyone. You may now proceed to your respective seats. Colleague here, my partner, will proceed with the next part of our program.
Again, if you have any additional questions, you may still type them in the Q&A box on Zoom or leave it in the comment section on our Facebook Live, or you may personally talk to the project leaders present here today, and they will be able to answer your queries. So I know we're all a bit hungry, it's lunchtime and all, but we still have one last segment for this morning. And quoting Sir Ivan earlier, papunta pa lang po tayo sa exciting part, as we are now awarding another EPIC award. So for this second EPIC award, may we call on Ms. Grace Estiliore, the Chief of the Policy Coordination and Monitoring Division, to read the citation and award the certificate.
Grace, a warm round of applause.
The DOST PCIEERD awards this certificate of recognition for their exemplary project implementation and completion in 2021, awarded during the 12th DOST PCIEERD anniversary celebration with the theme Empowering the Filipino through Innovative Engagement. Given this 29th day of June 2022 at Dusit Tani, Manila, Makati City. Signed, Dr. Enrico C. Paringit, Executive Director. Congratulations, Bayan Co-ops.
Okay, may we call on the team members of the Bayan Ops project. We call on as well our Executive Director, Dr. Paringit. We have Engineer Niñalisa Escoria, our Deputy Executive Director. We have Engineer Danilo Peña, the Chief SRS from the EUSTP, and the project managers from the transport sector to join us on stage for our quick photo opportunity. Once again, let's give a warm round of applause to our Bayan Co-ops, our second EPIC awardee. Thank you so much. Please give them another warm of applause for the Bayan Co-ops project. So again, congratulations to everyone. This is only the second award, EPIC award that we are giving. We still have more awards for the rest of our day. So we will be pausing for a quick break and we will return. We will be hearing more of our projects as well as the remaining 2 EPIC awardees. We have a lot of projects lined up in the afternoon as well. So I hope that everyone will enjoy the rest of your mealtime. And we will be back after an hour. Also, may I plug in that we have a photo booth for our participants here. They will resume at around 1 p.m. and will end at around 3 p.m. So I hope that you will accommodate the photo booth for your commemorative picture as we celebrate our 12th anniversary. So once again, our lunch is a buffet style lunch. So you may, I think this will be accommodated per table number. Okay, so those who are for tables 1, 2, and 3, so please quietly and quietly proceed to our buffet table, and I hope you enjoy your meal. Those joining us live, unfortunately, we won't be able to sending any food virtually, but please do enjoy your meal at your respective locations. So once again, thank you. Please join us in our afternoon session. Thank you. Enjoy your meal, everyone.
Before anyone leaves, in case anyone is leaving for the afternoon, please be advised there are green folders po on your respective tables. You may fill those out if you need certificates of attendance for this event, as well as for the registration or the attendance sheet for this session. So kindly please fill it out if you'll be leaving for the afternoon. And again, happy lunch everyone. Thank you.
Let's welcome back our hosts, Engineer Christian Mari Zamora and Miss Maribel Manawis. A round of applause, please.
All right, all right. Good afternoon, everyone. We hope everyone is full and have enjoyed your lunch. And time to get possibly more coffee and some more desserts as we begin our afternoon session. For those joining us via Zoom, we hope that you're all still here, you're all still present, and are ready to learn and listen to the next wave of presentations. We do encourage everyone to invite your friends and colleagues to tune in and discover more innovations for the industry sector. So before we formally begin our afternoon session, I just like to plug our anniversary giveaway challenge. So Mechanic says, so share the happenings for today's celebration through your social media accounts and have a chance to win the USCP shirt merchandise. So for the mechanics, simply share photos and videos with engaging and creative captions, either on your Facebook accounts, Instagram, or Twitter, and tag the official DOST PCIEERD page with the hashtag PCIEERD at 12. You could also follow the social media pages of DOST PCIEERD and make sure that your post is visible to the public. There's no limit to the number of posts you can make, so post away.
Oh, yes. We also will be having a total of 12 winners. This will be selected and will be announced at the latter part of our program. So good luck to everyone, and I hope that everyone will join our anniversary giveaway challenge. So again, hashtag PCIEERD at 12. Okay, welcome back, everyone. I know you have been waiting for the second set of our mining and minerals project. So to begin, we have Ms. Jeneline Ramirez from the Philippine Nuclear Research Institute to begin the second batch of presentation of our project. So again, I hope everyone had a sumptuous lunch. Please do enjoy eating while watching the presentation of our mining and mineral projects. Please give her a warm round of applause. Thank you.
Good afternoon, everyone. My name is Genevieve Ramirez from PNRI, and I am here with you today to share to you our major results for our project entitled Extraction of Radionuclides, Rare Earths, and Other Valuable Industrial Elements from Philippine Phosphogypsum Tailings. This is the conventional processing of phosphate fertilizers from phosphate rocks, which are being imported from more than 10 countries since 1980s. This phosphate rocks is known to contain significant concentrations of uranium, radium, REE, and several industrial elements. During wet acid processing with sulfuric acid, two byproducts are formed, phosphoric acid and phosphogypsum, which is a residue or a waste byproduct. Here, 80% uranium goes to phosphoric acid, while 60 to 80% radium and REE precipitates with phosphogypsum. Other elements goes to both byproducts. We have estimated about 10 billion metric tons of accumulated PG, and the lack of sustainable processing and the recycling options for this residue could result to successive accumulation, which may cause negative impacts to human health and the environment. In this project, we see phosphogypsum as an underestimated secondary resource of critical elements, which are not being recovered and are therefore lost forever from our economy. So the main objectives of this project is to conduct research and exploration to characterize our PG tailings, to select an applicable method for REE recovery, and to assess its radiation risks and resource opportunities. The next steps of this study would be to develop REE technology, leading to its demonstration in a commercial scale. This is actually a spin-off from our UXP project, or the uranium extraction from phosphoric acid, and this was officially started in 2018, and in the same year we had an IAEA expert mission on potential utilization and management of phosphate resources up to its scaled-up developments. In the same year until 2019, we did our fieldworks. We had in-situ radiometric survey at 270 point location in these 8 PG ponds, and characterization of 120 surface PG samples and pit samples. And in 2020 to 21, we did our preliminary REE recovery or acid leaching. We had 2 publications from this study, and let me share to you in the next slides our main results. The high standard deviation and the range of activity concentrations of KUTH radio elements indicate varying radioactive characteristics in each pond that is attributed to the processing of more than 10 types of phosphate rocks. We can also see here that the mean activity concentrations of potassium and thorium are within permissible limits, while the concentration of uranium is around 19 times the world average. All mean values of these radiological risk indices exceed the recommendable safe limits, and the practical way to mitigate this is just a simple dilution of PG residue with non-radioactive materials to lower the radiological risks to reasonable level. Shown in these figures are the RE concentrations in 2-meter trenches in these 24-point locations. Figure D shows us that RE concentrations range from 187 to 375 ppm, but it could go as high as 6,000 ppm. Evident in Figure C is the cerium depletion and yttrium enrichment found in Pond 2-3. And also here in Figure D are the major rare earths that is dominated by yttrium, followed by cerium, lanthanum, then neodymium. With the 10 million tons of PG, there's an estimated of 2,600 tons of rare earth oxides that amounts to $80 million. And assuming 50% recovery, our ongoing fertilizer production could supply 7 to 10% of the country's demand. We can see from these historic pilot scale experiments that REE recovery from PG is not a new idea, and up to this date, there is no commercial operation due to its technical and economic challenges. But given the economic importance of rare earths and the uncertainty of its future supply, we urge to go one step further and accept its techno-economic challenges and implement research and policy measures that encourage public-private partnerships with the goal of developing commercial methods to recover and use, rather than loose rare earths associated with PG here in the Philippines. That ends my presentation. Maraming salamat po.
Okay, thank you so much to Ms. Genevieve Ramirez for presenting the first project on the second batch of our Mining in Minerals project. Now, to move forward, we will be having Dr. Aileen Orbesido from the De La Salle University to present the project one of their mining program. Let's give her a warm round of applause.
Good afternoon, everyone. It is an honor to present to you the result of our project titled Utilization of Nickel Laterite Ore Rock for Low-Grade Ore for Acid Mine Drainage Treatment and Carbon Sequestration. It is a research collaboration among several universities locally and abroad, and with our partner mining industry, the Agata Mining Ventures Incorporated. So the main project proponents are from De La Salle University with me, Aileen Orbesido, as the project leader. And we have collaborators from University of the Philippines, Los Baños, and Curtin University, Australia. The Philippines is known to be one of the top exporters or producer of nickel in the world. Thus, laterite mine waste needs to be managed properly. So this research project aims to utilize laterite mine waste for acid mine drainage neutralization and for indirect carbon dioxide mineralization. So it aims to address 7 SDGs listed in here. So I'll start first with a discussion about acid mine drainage to be followed by carbon dioxide mineralization. So what is acid mine drainage? Actually, it is also one of the byproducts of mining waste, also known as acid rock drainage. It is characterized by low pH, high salinity, high heavy metal toxicity, and it is being generated at the start of the mining operation and continue even after mine closure and or abandonment. AMD needs to be treated prior to the discharge to the environment or receiving bodies of water, or else it will have a detrimental effect to these bodies of water. So for this project, we have used the following characteristics for synthetic AMD. So for the raw material characterization, so we have 4 materials used in this research project. We characterize the low-grade ore, mixed dump, siltation pond, limestone in terms of XRD, XRF, surface area, bulk density, and specific gravity. So we have conducted several experimental runs utilizing both jar test and batch test to test different operating conditions. So the results showed that the laterite mine waste is comparable to its to limestone. The results is comparable to limestone, and most of the heavy metals and pH is within the effluent standard indicated in the DENR Administrative Order 2016-08 for Class C or SC bodies of water. For carbon sequestration via mineral carbonation, practically the laterite mine waste is being used to capture carbon dioxide emissions through the process known as mineral carbonation, producing carbonates as the byproducts. So here is the reactor setup for leaching experiments. The results of the carbon mineralization showed that there is a sequestration potential of around 328 milligrams carbon dioxide per gram of mixed dump used, or that is also around 140 milligrams of carbon dioxide per gram of silt. And also for low-grade ore, it could capture 330 milligrams carbon dioxide per gram of low-grade ore nickel rock. So for the 6 Ps, this project has produced way beyond the target publications and of course, people's services. Practically, the project has strengthened its partnership with Agata Mining Ventures Incorporated and also has partnered with Tokyo Institute of Technology in Japan. The project produced 6 journal publications as well as attended or supported 8 conference presentations, both locally and internationally, We have the 7th seminar workshop on the utilization of waste materials and the research 7th or the 2nd Research Congress, BLSC. Also conference at Asia Pacific, at the 18th Asia Pacific Confederation of the Chemical Engineering Congress in Sapporo, Japan, and in Kuala Lumpur, the 26th Regional Symposium on Chemical Engineering. The project also supported 7 undergraduate students and 8 senior high school students. Thank you very much for the support given by the funding agency, PCIEERD, and also the hard work of the whole team. Thank you for your attention.
Thank you to Dr. Eileen Orbesido for presenting Project 1 under the TR program. Now, presenting Project 2 under the same program, we have Dr. Einstein Opiso from Central Mindanao University. Please give him a round of applause.
The Philippines is one of the major suppliers of nickel laterite ore in the world, but the mining companies tend to convert mountain ecosystem into surface mining by stripping down the original ecosystem in order to get the mineralized soil. And this leads to a higher risk of soil erosion and siltation problem. And this also accelerates biodiversity loss, reduce forest cover, and contaminate the rivers and sea concerning and affecting the way of life of people who are mostly dependent on farming and fishing. Our project developed a novel 3-step extraction, reduction, and precipitation method to extract iron from nickel laterite mining waste and repurpose this waste into magnetic absorbents for arsenic removal. To do this, we extracted iron and synthesized the extracted iron into magnetic materials. The extraction step was done by hydrochloric acid digestion at 60 degrees Celsius. Hydrochloric acid was selected instead of sulfuric acid because the former not only improves iron solubility by forming iron chloride complex, but also prevents iron precipitation as jarosite and swartmanite. The reduction step was conducted by preparing iron 2 solution from digestion leachate, while the precipitation step was carried out by neutralization of Fe3+ mixture from steps 1 and 2. Moreover, the effects of 3 drying procedures, freeze drying, air drying, and sun drying on properties of synthesized products were also examined. Detailed characterization of nickel laterite mining waste and synthesized products was also conducted using X-ray fluorescence spectroscopy, X-ray powder diffraction, Fourier transform infrared spectroscopy, scanning electron microscopy with energy dispersive X-ray spectroscopy, and dynamic light scattering. Arsenite and arsenate adsorption experiments was conducted, coupled with geochemical modeling and time-of-flight secondary iron mass spectrometry or TUPSIMS to ascertain its adsorption mechanism. This project successfully developed a novel method that will add value to mine waste of nickel laterite silts, as well as minimize siltation problems that will affect the environment and agricultural livelihood of surrounding communities. It is our hope that the mining industry, particularly the nickel laterite mining companies, will adapt or develop novel 3-step approach to produce magnetite adsorbent with arsenic adsorption properties, with excellent arsenic adsorption properties from their siltation sediments.
Okay, that has been Dr. Einstein Opiso for Project of the TR program. Now we move forward to Dr. Evelyn Arugay from the Mindanao State University Iligan Institute of Technology to present Project 3 from the TR program. Let us welcome her with our hand of applause.
On this Innovate PINAS, the 2022 Philippine Research, Development and Innovation Conference, The team Project 3 will present the outputs for the Philippine government-funded research on recovering nanominerals and minerals from silt for various ceramic applications. Under a research program and 3R approaches, reuse, recycle, reprocessing of nickel laterite ore mining waste for environmental remediation and material valorization, in collaboration with two other universities in the Philippines, De La Salle University, Central Mindanao University, with Agata Mining Ventures Incorporated as our industry partner. We also had an international collaboration with University of New South Wales. The amount of NMW generated by nickel laterite mining operations is huge. One of the mine sites in the Philippines produced voluminous silt as shown in the table for the years of 2016, 2017, and 2018 respectively. Although the use of siltation pans in nickel laterite mines is effective, the NMW management approach is unsustainable. The main objective of this project is to investigate the nanominerals and minerals recovered from silt from siltation pans of nickel laterite ore mines for various ceramic applications. Utilization of silt results in creating business and jobs and adds economic value to mine waste, thereby reducing silt volume, increased capacity of siltation ponds, and reduced maintenance of operation cost of siltation ponds. Wise utilization of silt could support at least 5 UN Sustainable Development Goals as presented. Products of Project 3 are categorized as the following: bulk products, powders, and system. For the bulk products, we have construction materials such as ceramic roof tile, ceramic floor and wall tiles, and porous bricks, with the construction industry and ceramic floor wall roof tile industry as end users. We also produce products for industrial and municipal applications, products for thermal management applications, namely low temperature insulator bricks, heat shield, and heat sink for thermal energy harvesting and insulating application, ceramic tubes for insulation pipes and refractory cover for high ceramic and metallurgical temperature applications. For powders, we have subsieve silt powders and magnetic powders extracted from silt for pharmaceutical or cosmetics application and industrial applications. To maximize the utilization of the silt, a design of circuit for purification of minerals and making of ceramic products was created to keep track of the flow of the material, such that the amount of materials that go to the waste is minimized. We had computer-aided design for ceramic products and molds for technology adoption. Due to the pandemic, there are limitations that resulted to extension in the conduct of thesis and discontinuance on the characterization of ceramic products in other engineering fields that resulted only to the completion of 7 undergraduate students, and 2 of them got the Best Thesis Award last January 2020. We had 3 international presentations, 1 presented during the 40th PAASI anniversary and 2020 APAMS, 1 oral presentation and 2 poster presentations during ICAC 2021, wherein one of our posters was awarded as Best Posters for Trustee Awards of the Engineering Ceramics Division. We also had an international presentation organized by iCare and published in an open access journal. At least 2 patents are drafted and are in review phase. The produced NMW tiles meet the following standards requirement. Presented is the capacity building of ceramic laboratory. If you are interested in this project or have questions specific for this project, you can contact us through this email. We would like to acknowledge the DOST PCIEERD and our industry partner UNveils for a successful collaboration. Thank you for watching.
That was a great presentation from Dr. Evelyn Arugay. Now we proceed to the last project under the 3R program and the last project for the mining and mineral sector. We have here Dr. Michael Promentilla from the De La Salle University to present Project 4 from the 3R program. Let's give him a warm round of applause.
Good day, everyone. It is my privilege and honor to present our PCIEERD funded project entitled as 3R Approach to Sustainable Management of Nickel Laterite Ore Mining Waste, Reuse, Recycle, and Reprocessing for Environmental Remediation and Material Valorization. I would like to take this opportunity as well to thank and acknowledge our industry partner, AMV, Agata Mining Venture Incorporated, for being our collaborator for this project. I also would like to acknowledge Steyan, where we obtain our coal fly ash in order for us to proceed with our development of geopolymer materials using this waste or industrial byproduct. The 3R program actually is an 18 million DOST funded research program wherein it involves 4 component projects and 3 research-oriented universities. These are the LSU or the Salle University, Central Mindanao University or CMU, and MSU IIT. And of course, this involved more than 20 researchers. The project that I am leading is actually on the application of geopolymer to recycle the mine tailing, the mine silt or waste rock as a potential cementitious end product. And in this case, our project uses both coal fly ash and mine waste from the nickel laterite mining area in order to produce this eco-friendly material through the geopolymer technology. Please allow me to share my video on how we envision this geopolymer technology, this research that could have an impact to the society.
If there is someone who could imagine the potential of industrial waste from thermal power plants or rice hull ashes from farms across the country, it would be De La Salle University Chemical Engineering Professor Dr. Michael Angelo Promentilla. Promentilla and his research team named GAMERS, or Geopolymers and Advanced Materials Engineering Research for Sustainability, are responding to the global call for a low-carbon circular economy and sustainability by developing a construction material that can be an alternative to conventional cement, the geopolymer. Promentilla's research on coal ash utilization and geopolymer technology started in 2013 when he received the seed grant from the National Academy for Science and Technology. The project is a response to environmental threats that come from the rapid growth of urban and industrial areas in the country.
If I'm not mistaken, there's about 300 million tons of this coal ash here in the Philippines. It's one of the byproduct of coal-fired power plant. So kung makita ninyo, yung kuryenteng ginagamit natin ngayon is in fact, mainly 40% of that came from burning coal. And one of the byproduct of this coal-fired power plant is the coal ash. So we're trying to find out whether this coal ash, which is actually an industrial byproduct, or you may call it a waste, can be used to produce a geopolymer-based material that can be used for building, for road pavement, and so on.
Promentilla's research also led him to look into the agricultural sector, which produces a large amount of rice hull and waste abaca fibers, which are abundant natural and raw materials. He found a use for these in reinforcing the geopolymer matrix. 3 applications of geopolymer are being explored: a fire-resistant building material, an acid-resistant material, and a geopolymer reinforced by chemically treated waste abaca fiber. Promentilla's team is collaborating with researchers from Mindanao State University, Iligan Institute of Technology, and Central Mindanao University to study the possibility of using mining waste in manufacturing building materials.
That's what I dream about with this technology here in the Philippines. We started 5 years ago, and hopefully after a decade, it will be more accepted. There will be regulations that would enable the use of this kind of material.
Thank you very much for your time. And of course, right now, we are on the path of commercialization under the funding of a fast track program. Hopefully, I can give you an update in the next progress of our research. Thanks again.
Thank you very much, our project leaders from the mining and minerals sector. Indeed, we are hopeful that these innovations and initiatives will soon be utilized by our mining industry. Moving forward, we know that the Philippines sits on vast reserves of minerals, both metallic and non-metallic. Aside from gold and copper, the country is also rich in iron ore reserves of almost 300 million metric tons. Data from the Department of Trade and Industry states that the rapid development of the Philippines and the continuous growth of the Southeast Asian region has resulted in a higher demand for both iron and steel products domestically and regionally. From this, we will now invite our project leaders from the metal sector to give us an overview of their completed projects, starting with Engineer Faye Barrett of the Bataan Peninsula State University. Let's all give her a warm applause.
Good morning, everyone. The Bataan Peninsula State University, through its Research and Development Office, would like to extend its appreciation to the men and women of DOST, headed by the dynamic and very supportive Undersecretary for R&D, Dr. Pistira Guevara, and to our friend from DOST PCIEERD, its dynamic director, Dr. Enrico Caringit, together with our very supportive director for DOST3, Dr. JC Sigat, our friend, for providing a funding support or grant for this graded project being implemented by Bataan Peninsula State University. Indeed, the funding assistance or support coming from DOST greatly contributes to the attainment of BPSU R&D programs and projects. The support and trust of DOST in the R&D programs of the university beneficial for the development of our R&D endeavors.
Crispiness is the most common food texture related to high-quality cooking. It is achieved by using deep frying method, making the food more appealing and enjoyable. However, excessive consumption of oil from deep fried food can negatively affect your health in the long run. Most of the small and medium-scale food enterprises in the country are still using the traditional way of the oiling, which involves drenching of fried foods to oil-absorbing papers overnight. Due to this time-consuming process, demands of the clients, especially their deliveries, were not accommodated accordingly. The BPSU took this opportunity to address their problem by providing a technological innovation that will resolve their problems and concerns.
The Cradle project, entitled Development of the Oiling Equipment for Deep-Fried Peanut and Garlic Chips, is a client demand-driven project. The scope of the project is focused on the reduction of surface oil content of deep-fried foods according to clients' preferred percentage reduction depending on the type of deep-fried food while maintaining the quality and texture of the product. It is an open-loop system. The deoiling method involves a spinning process using centrifuge principle to help hasten the removal of the oil from the product, thus reduces production time. The weight of the product before and after the oiling process is the parameter being used to analyze the desired quality. The percentage weight difference before and after the oiling process is the basis of the percent reduction of surface oil content.
Bali yung pagpaprocess namin ng deep fried products, overnight namin siyang ilalagay sa Manila paper para ma-de-oil siya overnight. So kinabukasan pa po yung packing. Medyo matagal po yung proseso kasi kailangan pang kinabukasan bago maipack yung package. Unlike pagka may de-oiling, sa quality naman po ng produkto, sa paggamit kasi ng Manila paper, hindi pantay yung yung pag-de-oil. Merong natanggal lahat ng oil, yung iba naman hindi. So sa pag-de-oil, maging pantay na yung oil na nakukuha at mas sigurado yung quality kasi dumaan na siya sa proper de-oiling. So magiging masasabi kong quality na yung product na ibibigay namin sa merkado. Malaki po ang pasasalamat ko sa DOST Cradle Project, sa BPSU, sa de-oiling team ng BPSU headed by Engineer Barrett. At sa lahat, dahil po sa kanila, nagkaroon na ako ng dekalidad na produkto na mai-offer sa market.
Indeed, the Cradle program of DOST in collaboration with the academy and in partnership with Filipino company or small and medium-scale local industries through technological innovations has a potential to improve the partner company's products, processes, and services to become more competitive in their respective industries. Nakakatulong na kami sa ating mga MSMEs. Pwede pa maging simula ng technopreneurship. I am grateful to the unwavering support from DOST, partner industry, the Terius Food Product, owned by Mrs. Susan Suba, and the Bataan Peninsula State University for the opportunity to make this Cradle project possible.
Thank you very much, Engineer Barrett, for sharing your experience in conducting your Cradle project with the DOST. So for the next completed project under the metals sector, we would like to invite Dr. Franz De Leon of the UP Electronics Engineering Institute to give an overview of this project 4 under the Bamboo Musical Instruments Innovation Program. So Dr. De Leon.
Good day. I'm Franz De Leon of the UP Electrical and Electronics Engineering Institute. I'm here to present our completed project entitled Development of Prototype Designs of Musical Instruments using Select Philippine Bamboo Species and Processing Technologies. Bamboo has long been used as musical instrument in the country. Our ancestors developed the traditional instruments that are used in recreation and rituals. Given the influence of Western culture, we also developed and adopted bamboo instruments that conform to the more familiar chromatic scale. The K-12 curriculum requires students to learn bamboo instruments in their music subjects. Hence, there is a significant increase in demand for bamboo instruments. However, it was observed that the sound and structural qualities of locally made products have problems in terms of tuning and durability that often leads to bukbok or infestation from wood borers. Knowing the industry's current state leads to an opportunity for the instrument-making community to be reinforced using science and engineering. Moreover, it opens up the possibility of utilizing other local bamboo species. Hence, the Bamboo Musical Instruments Innovation Research and Development Program was born to address this gap. The BMI program provides a comprehensive solution in upgrading the workflow. It is a collaboration between DOST FPRDI and UP Diliman. The first three components include documentation, applying protective processing technology, and building a processing facility. The fourth component, which is our completed project, focuses on developing prototypes using new bamboo species and applying processing techniques developed at FPRDI. The whole prototyping activity is done in close coordination with FPRDI. The raw materials are sourced, prepared, and treated by FPRDI. The samples or prototypes are then sent to UPTEEI for acoustic and vibration tests. The test results are then fed back to FPRDI for documentation and to determine the effects of the species selected or the effects of coating. Among the different local bamboos studied by the program, these were considered for prototyping: black bamboo, giant bamboo, beito bamboo, kawaing tinik, and bolo. Kiln drying and thermal modification were applied to reduce the moisture content of the bamboo samples. Based on the results, thermally modified bamboo are less prone to frequency detuning than kiln-dried samples. Two types of finishes were applied to the prototypes: nitrocellulose and polyurethane. Both increases the overall appeal and provides additional layer of protection, especially against wood borers. Now let's move on to the application of signal processing techniques. Each sample instrument was played and recorded. The sound recordings are then transferred to the computer for further analysis. The spectrum of each audio recording was determined. The spectrum reveals the significant frequency content of a sound that will help explain its perception. A number of derived features were extracted from the spectrum. Aside from acoustic analysis, the project also performed vibration tests. The vibration tests characterize the physical behavior of the instrument when it is played. This is important to understand as the vibration modes are directly connected with the physical attributes of the bamboo, such as its density and moisture content. The BMI program was severely affected by the pandemic. Nevertheless, the staff persevered and the project was able to produce the following sets of instruments. We have angklung made from kawaing tinik, beito, and black bamboo, marimba from giant bamboo, and bumbong from black bamboo and kawaing tinik. To cap the project, a prototyping manual was drafted that documents the recommended techniques in producing the instruments. The manual is expected to be made available within the year. When the whole program is completed, it would be beneficial to bamboo producers in terms of increased demand and prolonging the shelf life of the harvested bamboo poles. Meanwhile, bamboo instrument makers can adopt the technologies and processes to produce quality products. Before I end my presentation, let's see and hear the prototypes from the DOST FPRDI Himig Agham Kawain with Colonel Gilbert Ramos and Maestro Ronel Ramos. Thank you for listening. If you're interested for more details, feel free to email me and our program leader. Magandang agham po sa inyong lahat.
What a great set of presentations that we had from the metals and engineering sector. Thank you to Engineer Barrett and Dr. De Leon for presenting the metals and engineering project. So it is great how our RDIs and academe can help address the demand of our clients and stakeholders. It is also astonishing how our R&D can help address or how we can innovate or improve the traditional instruments of our indigenous people. So moving forward, according to the International Trade Administration, the Philippines' rapidly expanding production of processed foods and beverages presents a robust opportunity for U.S. exporters of agricultural raw materials and high-value ingredients. Roughly 90% of the Philippine food and beverage processing industry's output is consumed domestically with excellent growth prospects stemming from the country's resilient economy and strong consumer base. To further give us ideas about the projects that the Council is supporting under this sector, let us now listen to the first project leader. Presenting, we have here Dr. Danila Esparagas from the Central Luzon State University. Let's give her a round warm of applause.
Good morning to everybody. I am Dr. Danila Esparagas, the project leader of collagen and gelatin from byproducts of fish processing industry. This project was led by Dr. Rosalie R. Rafael, who was replaced by Dr. Cesar V. Ordinero as the program leader upon her retirement. I will be discussing the following: 1. Rationale and project description. 2. Potential impact in the industry and/or society in terms of adaptation of the project or program. 3. Discussion of the project journey. And 4. Call to action from the target audience. This project is in response to the Sustainable Development Goals, SDGs 1, 2, 3, and 12. One of the ultimate goals of SDGs is to decrease the waste globally because the quantity of waste produced is increasing annually. This study on the utilization of fish processing waste into intermediate products such as collagen and gelatin offers a solution to the above-mentioned problem. The fisher byproducts such as head, entrails, skin, scales, fins, and tails are processed using appropriate extracting solvents at a certain pH into collagen. And the non-collagenous parts are left in the residue, which is then used in the extraction of gelatin. So this process is shown in this diagram. Characterization was done to verify the chemical compositions of the intermediate products. What is the potential impact in the industry and in society in terms of adaptation of the project? Collagens and gelatins sold in the market are bovine and porcine based. The use of fish-derived collagens and gelatins in food is healthier. Thus, collagens and gelatins from byproducts of fish processing industry is an emerging technology. How far have we gone through our project journey? We conceptualized the project in 2017 and decided to process fish waste into collagen, gelatin, fish oil, fish hydrolysate, and protease. Upon presenting to the technical panel, they decided to make it a program, and so the projects were divided into collagen and gelatin as the first project and fish oil and fish hydrolysate as the other. So for our project on gelatin and collagen and gelatin, we were able to optimize the extraction procedures for both the collagen and gelatin. So we did some actual laboratory experimentations and also characterizations of this collagen and gelatin that we were able to extract from the different fish waste from milkfish, tilapia, tuna, yellowfin tuna, and sardines and mackerel. We also studied some applications of collagen and gelatin to food model systems like the marshmallow, gummies, and gelato. Lastly is the call to action from the target audience. Our target audience are the fish processors, the technology adapters, and the university. The fish processors would be the source of raw materials, which would be zero value. The technology adapters will be the one to process the waste into collagen and gelatin, which could be high-value intermediate products. And the university would be the one responsible for product development and technology development for the processing of this waste. That's all. Thank you very much.
That has been Dr. Danila Esperaga. Now, moving forward, we have Miss Daisy E. Franca from the Industrial and Technology Development Institute. Let us give her a warm round of applause.
The DOST GIA-funded project, upgrading and enhancing the capacity of the Packaging Technology Division in Packaging Research and Innovation, was implemented by the Packaging Technology Division of ITDI-DOST. It aims to upgrade and enhance the capacity of PTD in developing new packaging technology and innovations, performance evaluation of packaging in the supply chain, packaging testing to assure food safety, and world-class packaging design addressing the packaging needs of MSMEs in the country. From this project, two major laboratories were established: the Simulation Packaging Testing Laboratory, or SPTL, and the Green Packaging Laboratory, or GPL. The laboratories were unveiled last June 20, 2022, led by the DOST Secretary Fortunato de la Peña. The packaging pilot plant was renovated to accommodate the installation of packaging line for liquid products such as juices and sauces. Likewise, the packaging testing laboratory was upgraded to comply with the ISO 17025 accreditation. PTD Manpower has undergone training in the areas of smart packaging, like intelligent packaging colorimetric sensor, packaging design and engineering, packaging testing, and label design and branding to enhance its core competence. The project has undergone and faced many difficulties and challenges brought about by the pandemic. The upgrading and renovation of the laboratories was significantly delayed due to lockdowns, limited movement, and travel restrictions. The acquisition and installation of major equipment were also affected by the pandemic. In spite of these challenges, all target outputs of the project were completed, meaning that the SPTL and GPL are now in operation. The changing landscape in the supply chain, which is more now complicated, and the increasing patronage of delivery services, SPTL becomes necessary and relevant to minimize, if not completely prevent, product damage during handling, distribution, and storage. The SPTL can determine or establish the distribution hazards that the product will be exposed to during distribution. The SPTL has data loggers that can measure all these hazards and can be mounted on different types of packaging. As such, not only will the SPTL aid in facilitating proper trade and boost national economy, but it will also drive the building of better roads and infrastructure and development of more versatile packaging for shipment. Green and sustainable packaging is one of the priority areas for research and development, not only by DOST, but almost all the industry sectors worldwide to address the environmental impact of packaging. Single-use plastics, or SUPs, are currently being studied to be included or part of the environmentally acceptable products under RA 9003 or the Ecological Waste Solid Waste Management Act, while House Bill 9147 or the Single-Use Plastic Products Regulation Act will eventually phase out SUPs. As a result, there is a sudden irrevocable demand for environment-friendly and sustainable alternatives in order to delay, if not reduce, the impacts of climate change. The GPL is finally open to be of service in conducting studies and generating green technologies for adoption by packaging stakeholders and for use by manufacturers and customers. At this point, I would like to invite everyone from the private sector, academic institutions, and other government units to visit us and partner with us or collaborate with us in conducting packaging research and innovations. I would like to acknowledge the DOST management for funding this project and to be sure for all the assistance given us. I would also like to acknowledge the dedication and commitment extended by the project staff to this project. Maraming salamat po.
Thank you very much, Dr. Paragas and Ms. Tanya Crampa, for sharing your innovations for our food sector. we will still be hearing more about the other initiatives under this particular area later this afternoon. But for now, we are once again opening the floor for questions. I'd like to invite our project leaders present in this hall today, Ms. Ramirez of PNRI, Dr. Orbicido of DLSU, Dr. Einstein Opiso of Central Mindanao University, Dr. Arugay of MSUIIT, Engineer Faye Barrett of Bataan Peninsula State University, Dr. Franz De Leon of UPEEI, Dr. Danila Paragas, and Ms. Daisy Tanyafranca. And I think Dr. Mike is with us via Zoom. Is still online. I think he's not online. There's a representative, Dr. Promin. We have Engineer Roy Manena. So please join us on the stage for some questions. Sir, here. Sir, you can sit here. Sige po. Technical glitch, sorry. Okay, so good afternoon po. Thank you for joining us again dito sa event namin. Siguro I'd like to begin with some questions kay Ms. Jenny V. Regarding lang po sa...
I'll be speaking in behalf of Jenny V.
Sorry, sige sir. Sige po, for PNRI on the project for yung sa rare earths. So siguro sir, ang question...
Rare Earth, yes.
It's rare earths. Siguro sir, ang question ko is, how far along is it before we see yung products coming out of the research or any parang more technologies that could be utilized by our industry?
Okay, so the project is still at its characterization phase. So currently, we have characterized this whole ponds of, hills of industrial waste, the phosphogypsum, and until now, the project is still on its preliminary leaching, experiments on preliminary leaching of these rare earth elements.
So mga how many pa to, sir?
From that stage, it will go up to laboratory phase, then bench scale, then a pilot plant. So maybe 2 years for laboratory, then bench scale would take another 2, and pilot plant depends on the feasibility of the bench scale testing.
So give or take around half a decade siguro, sir.
Mga ganun nga po. Sige.
Kaya natin yan, sir. Siguro, I'd like to ask the question next po kay Dr. Arugay of MSUIIT. Same question, ma'am. Parang you mentioned about the projects or yung sa production nung, the products coming out of the research. So may nakikita na po ba tayong timeline for its parang adoption or yung makikita nating entry sa market?
Okay, so good afternoon, everyone, to my fellow presenters also. Thank you for giving us this opportunity. On Project 3, recovery of nanominerals and minerals from silt for various ceramic applications, we have many products, bulk products, powders, and systems. Right now, few of the products are still on, we are preparing the documents for patent application prior to commercialization. And then some of them, we are still on preparing for the pipeline for fast track. So hopefully we can accomplish such documents. And since the products are so varied, we are still prioritizing which to commercialize first. Thank you.
Okay, thank you, ma'am. So offline comment lang. So sa amin po sa division namin, actually, for the fast track, so we'd be glad to really talk to you na rin po and move forward with it.
Now I finally see you.
Yan po. Kay Ma'am Russell po. And so siguro talo naman tayo sa question on, maiba naman po ako ng question. For kay Ma'am Eileen po. Ma'am, question ko sa inyo. How did you initiate yung collaborations niyo for the project?
Thanks. That's actually a hard question. We flew to Mindanao 2017, and we have this target mining company. And when we arrived there, unfortunately, they couldn't entertain us. So we are quite at a loss for half a day whom to approach. And then in the afternoon, we just call our colleague in Mindanao, and they connected us to AMV, the Agata Mining Ventures Incorporated. And the following day, we have our visit, and after that, that's it. So they supported us all throughout the project, from the kickoff meeting to sampling to even they're interested to take the products of the team. So well, it's hard to get the support of everyone, but we just need to prove that, I guess, we could help them in some way. Then hopefully tuloy-tuloy siya.
Thank you, ma'am. Related po dun sa question, I think I'd throw it to Sir Einstein ng CMU. How was it working naman, sir, with your industry partner? I mean, any tips or parang best practices that you could share with our other project leaders, those also listening online, para po sa successful implementation nating projects?
Okay, good afternoon, everyone. And that's one of the major problem that we have in the Philippines, because we lack that academe industry partnership, no? The trust that is given to the academe. So one of our how to overcome that problem is we just presented to them our idea, and since the resident manager of AMBI is from the academe previously, so he used to work with the University of the Philippines, Diliman, and he was very open when we presented to them, and they were really encouraged and even supported us to conduct research with the mining company.
Okay, thank you, sir. Thank you for the tips then. Okay. Siguro talo naman po ako kay Engineer Barrett. And ma'am, kamusta rin po yung experience nyo working and initiating yung collaborations with your industry partners?
In the collaboration po with our partner industry, we just first met with the Cradle, DOST Cradle po na activity conducting in Subic, kung saan po in-invite po ng DOST Cradle yung lahat ng mga food industries owner and also mga academe po ng mga researchers, at doon po kami nag-meet and doon kami nag-come up noong kanilang mga problems, mga needs doon sa kanilang production on how we can help through technological innovations. And then from that, kaya nag-come up po ako ng tinatawag natin na client-driven demand talaga na project, kung saan yung solution po na yon ay based talaga sa need ng food industry.
Thank you, ma'am. So I guess one common thing po na nakita rin natin with the projects na yung moving forward, it's that yung demand rin po talaga ng industry minsan ang nagde-drive for the innovations that we are doing.
Yes.
So I guess it's good rin po na talagang nagagawa natin yun on the ground level pa lang.
Yes, para pa maging competitive po sila sa market.
Thank you po. Talon po ako kay Miss Daisy naman. Miss Daisy, for ITDI po, parang how could we invite more of our industry to like partner with us to utilize our technologies, kahit po yung sa capacity building, mga ganun po?
Actually, the packaging technology division is quite successful when it comes to providing technology assistance, technology transfer to the MSMEs and also to all the industry sectors. Kaya itong project na to, this is very important, yung upgrading innovations. Kasi packaging cuts across industries. So lahat ng innovations nila will not proceed without the packaging. So kailangan mabilis din kami mag-evolve sa packaging. So yun lang, kaya with the SPTL and the GPL, we are hoping that more industry sectors and academic institutions will also partner with us. Yeah.
Thank you, Ms. Daisy. So for the last two questions na lang po siguro, no? Kay Sir Franz, AAAI. Sir, ano po ang nakikita nating timeline for kumbaga yung release nung sa compendium nga nung sa development of bamboo musical instruments, and is there parang foreseeable na magkakaroon ba ng mag-o-offer talaga nung standardized na instruments?
Yeah. The compendium is around 80% complete. 80% because the whole program hindi pa po siya tapos. So only some of the projects were completed. Nevertheless, yung foundational information regarding the processes, the species, and other techniques, those are well documented already. So we're just beefing up the contents in terms of proving that indeed we were able to develop a quality product as compared to the usual practices. So that should be, we hope that it could be completed within the year. And then, well, if you visit FPRDI, you will see their facilities, their bamboo processing facilities, and the actual instruments that were developed already. Fortunately, in this project, right from the start, we were in partner with one of the major manufacturers, the Colonel Gilbert Ramos. So as many of the project leaders have mentioned, importante yung sa umpisa pa lang partner natin si stakeholder because it makes the whole initiative truly meaningful. At siguro yung isang tip na may advice namin is that mahirap kasi yung top to bottom approach wherein you develop the solution first before you contact the stakeholders. Rather, you engage them right from the start para talaga may sense of ownership and then their participation, and you can really learn from them. Hindi lang puro kayo-kayong researchers lang, but you learn together with the stakeholders as well.
Thank you, Sir Franz, for those tips and best practices. Pero to wrap up the session lang, like yung kay Sir Mike from Mintilla, representative, unfortunately, wala nga po siya. Nabanggit in the presentation na meron ng commercialization efforts. Could you kindly give us some updates lang po kung ano ng status ng ating project, kung meron na ba tayo available?
So after the R&D project supported by PCIEERD, we identified a potential specific product line that can be commercialized. So presently, the project is supported by DOST under the fast track. This product will produce a substitute for cement-based construction materials. So we are now on the standardization of the process, and also we are doing market study for these product lines.
Okay, thank you, sir. Thank you very much po sa ating project leaders. Unfortunately, we have to move forward with our program. I'd like to invite again Sir Eric for a quick photo op with our representatives here. Sir Eric Pampinya, also like to come up on stage.
Right, while they're taking their photo, that was a great discussion they've had. So once again, I would like to plug our anniversary giveaway challenge. So please do share the happening for today's celebration through your social media accounts and have a chance to win DOST PCIEERD merchandise. Again, don't forget, hashtag DOST PCIEERD at Ground. All right. So once again, we are back to the awarding of the Excellence in Project Implementation and Completion, or the EPIC Award. So to present our third EPIC Award, may I call on stage Ms. Edna Nashanseno. Thank you, Ping.
Good afternoon, everyone. To continue with the exciting part of our event today, we will now recognize the third awardee for the project implementation and completion, excellence in project implementation and completion. The citation reads, DOST PCIEERD awards this certificate of recognition to this project for their exemplary project implementation and completion in 2021, awarded during the 12th DOST PCIEERD anniversary celebration with the theme, Empowering the Filipinos Through Innovative Engagement, given this 29th day of June 2022 at Dusit Tani, Manila, Makati City. Signed, Dr. Enrico C. Paringit, Executive Director, DOST PCIEERD. So our next winner, congratulations, OLAP.
May we call on team members of the OLA project. As well, we would like to invite our, Mr. Eric on stage again, as well as Deputy Executive Director, Engineer Escorial, Engineer Nudilo Peña, and the project managers for the OLA project. A quick photo opportunity. Thank you.
All right, congratulations to our third EPIC awardee. Once again, congratulations to everyone and of course our OLAP project. So we still have one more to be awarded today, so please stay tuned. So may I call on stage my partner to present the food sector projects that is to be presented for this afternoon.
Thank you, Belle. So for our last segment, we'll continue with the projects under the food sector, beginning with Miss Michelle Evaristo of the DOST Industrial and Technology Development Institute for their project under the Halal program. Let's give her a warm round of applause. Thank you.
Good afternoon, everyone. I am Michelle Bariso from the Food Processing Division of the Industrial Technology Development Institute. And I'm here to present to you our project on emulsified chicken meat products for the halal market. Together with me in the project are Una Grace Solete, Sarah Velasco, Renante Boqueo, and Mike Jason Gao. The current population of Muslim Filipinos is about 7.9 million, which is 7.12% based on the total population of the country. Philippines is a non-Muslim dominant country where halal industry is still emerging. Considering such environment, halal food consumption becomes one of the Muslim consumers' vital concern. At present, the availability of halal products in the whole country is still limited. The lack of sufficient halal options leads to Muslims' struggle for everyday necessity to consume only halal food, especially halal meat products. Globally, Muslim consumers are concerned about a number of issues concerning meat and meat products. This includes intentional substitution or adulteration with haram meat, use of prohibited ingredients, undeclared blood plasma, pork intestine casings, and non-halal methods of slaughter. Emulsified meat are basically made of chopped meat, fatty tissues, non-meat ingredients, and water or ice. It involves the process of chopping or cutting the meat to a very fine particle size, which encourages protein extraction. Proteins have the function of binding the water surrounding fat droplets and keeping them dispersed or distributed. The meat particles are so fine that they are not visually distinguishable. It becomes a concern if non-halal meat and non-halal ingredients are incorporated in the mixture. With this in mind, ITDI proposed a project that aims to utilize emulsification technology to develop halal-compliant emulsified chicken meat products such as chickens, chicken sausage, chicken nuggets, and burger patties intended for the local market. The research was divided into three major activities. The first activity is the formulation and process optimization, which resulted in the development of a standardized formulation and process optimization of the three emulsified meat products. The second activity is the storage stability of the three products, wherein the sensory acceptability, microbial quality, and textural changes were monitored during storage. And the third activity is the technology transfer, wherein the technology was transferred through a training to a Muslim group using the developed training manual on halal assurance system and emulsified meat processing. Now, these are the products that we develop at DOST ITDI. We were able to produce chicken nuggets, chicken sausage, and chicken burger patties under our brand name Primera. The meat and fat component, as well as the other ingredients used in the formulations, are halal compliant and halal certified. The ingredients and the resulting products were tested for the presence of DNA porcine to ensure the halalness of the product. The Industrial Technology Development Institute, through its Food Processing Division, now offers a training course on the preparation of these products. The training includes a lecture on the meat emulsification technology, halal control points for processed meat, and hands-on activities on the preparation of emulsified chicken meat. The training also provides information on suppliers of halal compliant and halal certified ingredients, packaging, and processing equipment. We have successfully transferred the technology to Kasama Halal Producers Cooperative. It is an organized Muslim cooperative in Santo Tomas, Batangas, which are involved in meat processing. The emulsified chicken meat technology is also now being offered as one of the regular trainings of ITDI. In fact, we have already conducted 2 trainings this year, and another one is scheduled this September. Like any other projects that we have handled, the group has encountered some difficulties in its implementation, particularly on the sourcing of halal certified ingredients such as chicken meat, sausage casings, and other food additives. Moreover, locally produced halal certified chicken meat is more expensive by about 20% compared to non-halal chicken. So in order to make the products more competitive in terms of costing, our team has to utilize imported halal certified chicken meat from Canada, Brazil, and the United States. There were also some delays in the implementation of some major activities, which is brought about by the pandemic. The regional target was to transfer the technology to our university partners in Mindanao, but due to travel restrictions in 2020, this was not implemented. The office lockdowns also affected the implementation of our storage study activities. Hence, we requested for 1-year extension of the project. Now, despite these challenges, we were able to accomplish all our activities in the project. Now, I would like to acknowledge the funding support of the DOST management and PCIEERD. I would also like to thank the ITDI management, particularly our Finance and Management Division, for the guidance in the financial aspect of our project during the pandemic. Thank you so much.
Thank you very much, Ms. Evaristo, for sharing your project with the emulsified meat products under the Halal program. Next up, we have Dr. Rima A. Hassan from the Mindanao Autonomous College Foundation Incorporated, who will be sharing about their project on the regional halal native delicacies. Another warm round of applause for Dr. Hassan.
Assalamualaikum warahmatullahi wabarakatuh. The Mindanao Autonomous College Foundation Incorporated is indeed blessed to work in partnership with DOST ARMM under SMT program in our research and development in the development of halal delicacies. The objective is to establish halal assurance system on regional native delicacy such as lokot-lokot of Basilan, Baulo of Tawi-Tawi, Puto of Sulu, and Hanta, Tota, and Pangalan. Specific objective is to enhance and improve the processing method of their existing regional native delicacies, to develop halal assurance manual, to come up with permissible and non-permissible products, to determine the acceptability and profitability of the regional delicacies of the region, to benchmark good practices of food industries who produces halal foods, and to ensure products are halal compliant and follows government requirement on food safety and consumers' production. The Autonomous Region of Muslim Mindanao is a young region located in the southern part of the Philippines. The region is composed of 3 separated islands, the Basilan, Sulu, and Tawi-Tawi, known as the Sultan. The main islands Marawi City, Maguindanao, Lanao del Sur, and Lanao del Norte. The ARMM is dominated by Muslims whose religion is Islam. The ARMM is an agri-based economy, is endowed with rich natural resources and other comparative advantages that can be tapped for economic development. ARMM is known for its rich cultural heritage and cultural diversity. It is not only through the people's aspiration of self-determination or freedom that the Moros are known for, but they have also an array of native delicacies to boost. The population of each of the provinces takes pride in the production of the different culture-laden delicacies. Often, those native delicacies are only prepared during special occasions. Special occasions deserves special food, and their native delicacies are considered special food to serve in the special occasion and to be offered for special guests. Of course, the R&D team journey included series of attended halal trainings and seminars, received various research trainings, visited food innovation centers around the Philippines. We also visited food production, food processing, and food laboratories. We also talked and discussed delicacies potentials in the market to the small entrepreneurs and traditional native delicacy producers. The transition of ARMM to BARMM, the team faced challenges in introducing the research project to the new management. The COVID-19 pandemic is another challenge to the team because of the platform for the project compliance. Alhamdulillah, the team was able to manage.
Hi, good afternoon. My name is Desi, the Mayor's Office here in Mamitan City. We adopt the halal native delicacies. Ito yung mga delicacies dito sa Mamitan City. Ginagawa namin token para ipamigay sa mga visitors ng LGU. Yung mga, hindi lang mapa-local, saka na rin, marami rin pumupunta dito from international. Para matry din nila yung aming mga yung lamitan ng delicacies. Itong yaman delicacies ng Lamitan City, gusto namin matry sa mga nag-visit sa lamitan, mga tourists, para matry nila yung aming delicacy, para ma-advertise na rin sa kanila kung gaano kasarap yung delicacies ng mga yaman. Thank you!
Thank you very much, Dr. Hassan, for sharing about the benefit of the regional halal native delicacies. So our next project, so we're now moving on from food innovations towards more of the educations. So to begin with, the next project under the Halal program, I'd like to invite Dr. Emma Sales from the University of Southern Mindanao to share about their project on the curriculum development of the Halal Science for SUC faculty. So another warm round of applause, please, for Dr. Emma A. Sales.
Good morning. Today, I will be presenting our project entitled Curriculum Development and Offering on Halal Science and Scholarship for SUC Faculty on Halal Science. My companions in the team are as follows: Dr. Emma K. Sales, Dr. Francisco Gil N. Garcia, Dr. Luz Gominda Simborio, Dr. Ruby Hechenova, Dr. Johamid Imlan, Dr. Mark Aljami Mutulani, Professor Sandra Joy Pam, and Professor Munaira Sumael. The University of Southern Mindanao is the lead agency, while the Sultan Kudarat State University and Central Mindanao University are the cooperating agencies in the project. This project is funded by DOST PCIEERD. It started August 1, 2018, and it will be completed December 31, 2021. The project has a total approved budget of 13,135,295 pesos. For the introduction, halal is an Arabic word that means permissible and lawful. The halal industry is a billion-dollar industry, and it needs a lot of human resources to work in the industry. Republic Act 10817, which is the Philippine Halal Export Development and Promotion Act of 2016, in Section 14, it states that there is a necessity that human resources should be capacitated to work in the halal industry. Therefore, it is very important that a certificate course in halal science should be crafted in order that people who will be working in the halal industry can be able to gain knowledge about halal. For the objectives of the project, for the general objective, to develop a curriculum on halal science for human capacity building of halal stakeholders. We have three specific objectives. We have number one, to develop and implement a certificate course in halal science. The second objective is to train SUC faculty on halal science. And the third objective is to develop a mechanism to sustain the program. For the methodology, we started with inception meeting. Then a team conducted a benchmarking activity in established institutions in Thailand, Malaysia, Dubai, and Turkey. We reviewed the courses to suit the need of the Philippines. Then we conducted consultation with stakeholders and target beneficiaries. Then we crafted the curriculum. We developed modules for the curriculum. The developed modules were validated, evaluated before we have it finalized. Then we started with a pilot offering of the certificate course at the University of Southern Mindanao. For the results of the study or of the project, we have accomplished the following. We sent 2 faculty members for training abroad in halal science. We conducted focus group discussions with halal stakeholders. We conducted benchmarking activities in Thailand, Dubai, Malaysia, and Turkey. A team from Sultan Kudarat State University visited Jakin and other halal facilities in Malaysia. We developed the curriculum. The approval of the Board of Regents on the offering of halal science curriculum was already done. We developed the 14 modules. We conducted a virtual launching of the certificate course in halal science because we cannot do the face-to-face approach in teaching our scholars due to the COVID-19 pandemic. Then we conducted also a webinar series. Then we reviewed and finalized the modules. We enrolled 33 students. We had the virtual orientation. And we have now the ongoing classes of the certificate course in halal science. And we rolled out the course already in 3 SUCs. We invited 2 SUCs to offer the course this second semester. And we have this ongoing application for copyright of the modules. The certificate course in halal science that we crafted are as follows. We have the first course, Halal Science 1, with a description of principles and concepts of halal. We developed 3 modules for this course. We have Module 1, Fundamentals of Halal and Haram, Module 2, Halal Ecosystem, and Module 3, Introduction to the Halal Industry. For the second course, which is Halal Science 2, with a description of halal food production, we have 7 modules. Module 1, General Guidelines on Halal Food Production. Module 2, Halal Crop Production. Module 3, Halal Ruminant Production. Module 4, Halal Poultry Production. Module 5, Halal Slaughtering. Module 6, Halal Aquaculture Production. And Module 7, Economics on Halal Food Production. For the third course, we have Halal Science 3, which is halal food processing. Under this subject, we have Module 1, Principles of Food Processing, Module 2, Food Safety and Sanitation, Module 3, Good Hygiene Practices, and Module 4, Good Manufacturing Practices and Hazard Analysis Critical Control Points. These are the 14 modules that we have developed. As I have mentioned, we have developed the module. The validation of the contents were done before we have it finalized and printed. And in here, you can see the pictures of our students that we have captured, and we are doing the online course via Google Meet every Saturday. For the sustainability of the curriculum, we started collaboration with other HEIs. We have also collaborated with the Ministry of Basic, Higher and Technical Education of BARN. We have institutionalized already the certificate course in USM. That means every first semester and second semester, the certificate course will be offered. And we have to continue promoting the certificate course to other SUCs in the Philippines. In conclusion, the crafting of certificate course in halal science has resulted to 14 modules. 33 government officials were enrolled this first semester, 2021-2022. We have initial discussion with 2 HEIs for the offering of the course next semester, and initial talks with MDH-TE BARM and other universities in Malaysia and Indonesia for collaboration. For the recommendations, we recommend that a proposal for the crafting of a curriculum for bachelor's degree and post-degree programs, to collaborate with universities in Indonesia and Malaysia for the online offering of the course, for a team teaching with USM professors and professors in universities in Malaysia and Indonesia, and continue with halal awareness programs. Thank you very much and good morning.
Thank you very much, Dr. Sales, for sharing your journey on developing the modules for the halal science. Related to this training modules on halal, we would like to invite the next presenter, our very own UST Regional Office 11, Regional Director Anthony Sales, to give an overview of their project under the halal program. Again, we request you to give Bertie Sales a warm round of applause. Thank you.
The general objective of DOST Halal S&T program is to develop a globally competent human resource on halal. Its specific objectives include 1. To identify halal stakeholders and to assess their training needs. 2. To develop and design human resource development plan for the identified stakeholders. And 3. To develop and implement training modules on halal. Here are the accomplishments of the DOST Halal S&T program.
Halal is not just for Muslims, but for everyone. Shukran.
Thank you very much, RD Sales, for sharing your completed project for the training modules on halal. Up next, to close off the halal program, we'd like to invite Mr. Bienvenido Flores of the DOST Industrial Technology Development Institute for to share their completed project for the halal assurance system. Another warm round of applause, please, for Mr. Flores. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. May peace and mercy and blessings of Allah be upon you. Pleasant day to everyone. I am Bienvenido Flores Jr. from the Industrial Technology Development Institute of the Department of Science and Technology. I am here to introduce our project. But first, let me demonstrate to you the current trend in our global economy. As you can see, here is the global Islamic economy. Halal has been transformed from an exclusive niche market for Muslim consumers into a dynamic global market phenomenon that shows every indication of playing an important role in global trade. On the global Islamic economy, which is represented by $2.02 trillion of consumer spending by $1.9 billion across 6 real economy sectors for the halal food and lifestyle sector reaches $2.02 trillion in 2019, while on the Islamic finance assets reach $2.88 trillion in 2019. Muslim spend is forecasted to reach $2.4 trillion by 2024 at a 5-year cumulative annual growth rate of 3.1%. With that phenomenon, we propose a project that will take part in the global economic trend. It was entitled Establishment of Halal Assurance System for Selected Banana Products, Banana Chips, Banana Ketchup, and Frozen Banana. It was headed by our project leader, Maria Elsa Falco. The implementing agency was the Industrial Technology Development Institute of the Department of Science and Technology, and it started last July 2018 and ended on January 2021. I will go over the following: background of the study, what has been done, impact of the study, and conclusion. What is halal? Halal refers to food, non-food services, and other activities that is allowed, permitted, and lawful under the Sharia law. Why halal? First, religious obligation. Religion or divine command. It's God's command we have to follow that no question asked. Next, cultural requirement. These are cultural needs, things that are necessary or helpful for an individual to thrive due to their cultural background. These are specification features or services needed especially by a Muslim customer. Due to industry demand, there is a surge on halal products in the market. The growing halal market worldwide is a potential sector, especially for our micro and small entrepreneurs. How much does the global Muslim market spend on food? In 2016, the existing Muslim market, 17% of global expenditure is $1,245 billion and may increase to 18.7% by 2022 at $1,920 billion. In the Philippines alone, we have an estimated population of 9.62 million Filipino Muslim. In order for Muslims to be able to buy the products, halal certification is needed. Why banana? Because banana is one of the major export of the Philippines. Technological advances in food production have led to a huge increase in processed foods. This is the framework of our study. We use halal certified raw materials such as banana and other ingredients. For the methods, we do product standardization, halal assurance system development, directory of permissible and non-permissible ingredients, test results and product specifications, consumer acceptability, and cost analysis and profitability. As a result, all the developed products are compliant to halal standard. This is beneficial not only to Muslim communities, but to global consumers. We have developed a standardization procedure for banana chips, banana ketchup, and frozen banana, which will help our small and micro entrepreneurs compete in the global halal industry. We develop halal compliant banana products. RT-PCR test, all these products are negative of porcine meat antigen. Our cooperators benefited from the developed Halal Assurance System manual for their banana products. We were able to compile a directory of permissible and non-permissible ingredients for the banana products. We have trained and certified 55 Halal lead auditors who will assist our SMEs in becoming Halal certified. We are confident to assist our cooperators to be Halal certified. We established the Halal Food R&D Facility, which is accredited by the International Halal Integrity Alliance. We can cater to the growing halal market by providing these facilities to our small and medium entrepreneurs. Based on the results of our study, the developed banana products comply with the Philippine standards on halal and Malaysian standards. Shukran.
Thank you very much, Mr. Flores, for sharing your outputs under the Halal Assurance Project. Moving forward from the Halal program, we now have Dr. Maria Patricia Azanza of the University of the Philippines, Diliman, for their project on the development of chicken egg white powder and granules from low-value edible shell eggs. Again, we request another round of applause for Dr. Azanza.
10 milyong itlog. Ganito karami ang produksyon kada araw ng 54 na miyembro ng Batangas Egg Producers Multipurpose Cooperative o BEPCO sa San Jose, Batangas, ang tinaguriang egg basket ng Pilipinas. Sa tinatayang 10 milyong produksyon nito kada araw, 1 hanggang 2% ang nasa ilalim ng kategoryang off-specification o undervalued eggs. Nabibilang sa off-specification category ang mga basag, soft-shelled o luno at ang mga maruruming itlog. Tinatayang 82,000 itlog kada araw ang nasa ilalim sa off-specification na classification. Malaki na nga ang bilang ng mga undervalued eggs na dagdagan pa ito ng oversupply ng itlog noong 2017 hanggang 2019 na makaranas ang Pilipinas ng bird flu infestation. Sa dami ng undervalued eggs at surplus eggs ng mga panahong iyon, nakapila ang mga itlog sa bayan ng San Jose, Batangas at minsan nang ibinabaon sa lupa dahil walang mapagdalhan. Malaki ang problemang ito na naging isa ring malaking oportunidad para sa BEPCO na gamitin ang siyensya at pananaliksik upang makahanap ng solusyon. 2014, sa pangunguna ng Managing Director ng kooperatiba na si Ms. Cecil Alduesa Fertucio, ginawa ang isang product roadmap na naglalayong gamitin ang mga low-value at surplus eggs bilang powdered at granulated eggs. Kasama si Ms. Cecil, binuo ang core team ng proyekto. Katulong niya si Judith Alday Mangmang, Cooperative Manager ng BEPCO, at Dr. Maria Patricia Azanza, Profesor sa UP Diliman College of Home Economics. Gumawa sila ng project proposal titled Development of Dried Chicken Egg White Powder and Granules from Low-Value Edible Shell Eggs. Lumabas sa pag-aaral ni na Dr. Azanza na ang dried chicken egg white powder at granules ay may karagdagang benepisyo ng pagkakaroon ng mahabang shelf life. Matapos ang matagumpay na pag-a-apply at makatanggap ng pondo mula sa Cradle Program, na ipatupad ang proyekto kasama ang DOST National Capital Region Food Innovation Facility sa UP Diliman Department of Food, Science and Nutrition, ang DOST Industrial Technology Development Institute at ang DOST One Lab naman ang nag-provide ng mga pasilidad. Sa ginawang research, natukoy na ang mga itlog na may mga extraneous materials ay itinuturing na pinaka-perpekto at angkop na gawing granules at powder dahil ang panloob na kalidad ng itlog ay napakalapit sa mga good eggs. Sa unang taon ng pananaliksik ni Dr. Azanza, nakabuo sila ng isang protocol sa paghuhugas at paglilinis sa mga undervalued na itlog na may mga extraneous materials sa balat ng itlog na kanilang sinanay naman sa mga miyembro ng BEPCO. Pagkaraan ng 18 buwan, ang teknolohiya ng spray drying sa DOST ITDI ay nakagawa ng iba't iba mga formulation ng powdered egg white para sa baking, cooking at iba pang food preparation.
Ability of the industry to be open to the R&D procedure, and in turn naman, the ability of the researcher to be
sensitive to the needs of the industry, because what is within the framework of science and technology theoretical is not always applicable to the framework of what the industry can use immediately. There should be a right balance between the industry's needs and what the researcher as an academician.
Sa kasalukuyan, ang komersyal na produksyon ng BEPCO para sa dried chicken egg white powder at granules ay nagpapatuloy na sa pamamagitan ng toll manufacturing. Ang malaking problema noon, isa ng matibay na solusyon ngayon. Wala nang sayang, wala nang tapon. Ang mga undervalued at surplus eggs, napapakinabangan na ng BEPCO ngayon.
Thank you very much, Dr. Asanta. It's really wonderful how we can see innovations even in the smallest of things, in smallest of problems in our industry. So moving forward, we have next Mr. Adrian Rio, the Bataan Peninsula State University, on their research project regarding black chin tilapia. So again, another warm round of applause, please, for Mr. Adrian Rio.
Good day to all of our participants. I am Adrian C. Perjo, a faculty member of the Bataan Peninsula State University located in the city of Balanga in Bataan Province. My task is to communicate the journey of our research project entitled From Pest to a Valued Commodity, Blockchain Tilapia for the Development of Surimi-Based Products. The project is about value adding of a known prolific fish farm pest in Bataan, Blockchain Tilapia or BCT. It's an invasive species plaguing local farm ponds and deterring productivity. It's been multiplying fast and competing for feeds meant for cultured fish species. It's now been reaching growth sizes comparable to the more commercially popular Nile tilapia. It's being sold very cheaply in local public markets due to its reputation as a pest and due to its bland taste. The infestation has been a concern by the BFAR because it's been compromising the carrying capacity of local farm ponds, causing losses to fish farmers. The infestation has triggered calls to curb their population and for their productive utilization. While the species is bland tasting, it was found to be a lean and moisture-rich fish based on a preliminary study, making it a potential raw material for artificial seafood products like surimi. Originating from Japan, the surimi industry has been spreading to many countries now. In the Philippines, the popularity of surimi-based products is apparent in the commercialization of processed fish meat delicacies, the most recognizable of which are fish balls, fish sticks, and fish cakes. Our project worked on developing the edible portion of BCT into a surimi-based product, a fish loaf, assessed its quality and profitability, and then imparted the developed technology to target beneficiaries. Specifically, we characterized BCT and established its safety and quality as a food processing raw material. We developed a surimi-based product from it and evaluated its quality and stability against a leading commercial variety. We established its economic feasibility through a cost-benefit analysis. We developed processing manuals for the optimized processes, and then we imparted the developed technology to beneficiaries through capacity building activities. The project presented a means to control the BCT infestation and introduced a very cheap and abundant raw material for the fish processing industry. Through and for this project, we hope for stimulation of further innovations on developing BCT into a more valuable commodity, and of course, commercialization of our developed technology via establishment of enterprise operations and private partnerships. Also, through this project, we look forward to sustainable fishery through alternative livelihood opportunities and occupational mobility and improve fishery processes and situation. The present and following slides present the project's most salient activities, results, and outputs. The fish used in the project were sourced from BCT-infested farm ponds located in Orani, Bataan. Fish samples were caught using net traps and gill nets. Two yield indices were ascertained from the samples: processing yield and fillet yield. It was found that the processing and fillet yields of all samples were higher than the reported values for the more commercially used farm Nile tilapia. Also, it was found that the BCT samples have a comparable mineral load with Nile tilapia. The species has high moisture and protein contents too, but is very low in fat, making it a lean fish. The samples have no serious heavy metal and microbial contamination through standard tests, although appropriate post-harvest handling is still highly recommended. The physicochemical and microbial tests established that the VCT pest can be consumed safely and has the quality as a potential raw material in surimi processing. For the surimi processing, we strictly followed international standards. We tried 8 surimi formulations using 3 common cryoprotectants, namely sucrose, sorbitol, and sodium tripolyphosphate. And based on our tests for important surimi functional properties like water retention, foaming, emulsifiability, and gelling, the one with the best quality attributes was the 6% sucrose with 0.5% sodium tripolyphosphate formulation. Our best formulation yielded comparable figures with previous works that use more popular species for surimi processing, like lizardfish, threadfin bream, and purple spotted big-eye. It's concluded that surimi developed from BCT, with the right formulation, can be at par in quality with those made from traditional raw materials. For the product development, the produced fish loaf exhibited a brownish color, slightly darker than that of common meatloaves. It has a firm texture, minimal crusting when cooked, and an umami flavor. So based on sensory tests, it has better acceptability than a commercial counterpart due to its more pleasant odor and taste. The product was stable up to a significant length of storage time, 4 months or more using our two types of packaging. Also, it can withstand several freeze-thaw cycles for a lengthy storage time. In terms of nutritional quality, the developed product had comparable figures with commercial fish loaves. But of course, optimizations can still be done to enhance important nutritional parameters. Additionally, results from a cost-benefit analysis of the product development suggested that the product is a profitable and feasible investment. The product can be profitable based on a 5-year cash flow projection. So all in all, it can be stated that the developed product has the potential for industrial popularization. The project was able to conduct a series of trainings on product processing for members of 3 cooperatives based in Orani, Bataan. The trainings were done in the form of extension work by the project team at the BPSU Fish Processing Center in BPSU Orani. The trainings were done in collaboration with the Orani Bataan local government unit. The very purpose of the trainings were to involve the community in introducing means of productively utilizing the BCT pest and to offer them additional income generating sources. Also, the project team has been able to publish scientific papers in international peer-reviewed journals. Our paper entitled Quality Attributes of Lakshin Tilapia Surimi treated with different cryoprotectants has been approved for publication in Food Research, a Scopus Index journal based in Malaysia. It will be published next month. Another paper entitled A Baseline Study on the Quality and Safety of Consumption of a Pest Species in Bataan, Philippines, basis for its productive utilization in the fisheries sector, has been published already in the Journal of Fisheries Science, an international peer-reviewed journal based in Singapore. Presently, we are working on 2 more papers to be submitted for review in other journals this year. Also, we were able to present the 2 published papers already in 2 international research conferences. The project team was also able to register a full-blown processing manual for the BCT post-harvest procedures, surimi processing, and fish flow production to the National Library of the Philippines. The book bears the project title. Lastly, the project team was able to submit 2 utility models for registration to the Intellectual Property Office of the Philippines. Initial feedback was received by the team last November 2021. The title of the 2 utility models can be seen in the slide. To end this talk, our project was able to develop a product from a recognized fish farm pest with a very high potential for commercialization. We were able to do it using easily accessible and cheap raw materials and using very straightforward processing procedures. Presently, our product development will be put under our university's technology business incubation arm to prime it for commercialization. The project team hopes for accelerated and sustained adoption of our product development through partnerships with enterprises and further innovations on developing the pest into a valuable commodity. Maraming salamat po.
Thank you very much, Mr. Pedro, for sharing the developments on the utilization of blockchain tilapia for value adding this considered pest. So we're now moving from food products and training modules to a grading system now for food establishments in the Philippines. To present their output on this project, we invite Ms. Claire Malibiran of the DOST Food and Nutrition Research and Development Institute to share their project outputs. Another warm round of applause for Ms. Malibiran.
I am proud to present a completed project on the development of a grading system for adoption of food establishment in the Philippines. On behalf of our director, Dr. Imelda Angeles Sagdepa, a pleasant day to everyone. We all know that Filipinos love to eat, and that this changing consumer lifestyle in the Philippines have created opportunities to the food service industry that flourished to over 90,000 establishments in 2019. And according to FNRI National Nutrition Survey, 3 out of 10 Filipinos dine outside their home or consume food from these away from source like turo-turo, karinderya, fast food restaurants. And during the pandemic, consumers become particular on the food safety practices of these eateries. The consumers even check the cleanliness of the facilities, food handler, the compliance to the IATF health protocol, and even look for DTI safety seal. Our food safety system should level up and ensure that the public is safeguarded from foodborne illnesses from dine-in, take-out, and even food deliveries. So that is why FNRI developed a risk-based food inspection and grading system in order to safeguard and empower our frontline on food service system of the country. So join me as I journey with our development of these tools.
Simula 2018, ang FNRI or Food and Nutrition Research Institute ay gumawa ng grading system for adoption of food establishments in the Philippines. The project aims to develop a risk-based and modified food inspection checklist and grading system to rate the food safety of food service establishments in the Philippines.
Through the project, DOST FNRI searched far and wide. From understanding the foreign food inspection checklist of USA, South Australia, and New South Wales, and learning the inspection score and grading system pilot schemes of Australia and Brazil against our existing local health and sanitation ordinances, to arranging consultation meetings from Department of Health and World Health Organization, taking strong recommendations from technical experts, conducting intensive pre-testing in regions in the Philippines, and being pilot tested in Taguig, Cainta, and Taytay, Rizal. Finally, the DOST FNRI
is here to present the new standard of food safety grading system in the Philippines. The all-new modified food safety grading system tools.
dahil ang star-rated na kainan,
Sigurado ang kalinisan. The all-new modified food grading system ay may tatlong tools. Una, ang Food Inspection Checklist o FIC, na mas angkop gamitin ng sanitation inspectors. Dahil sa enhanced checklist, it's easier for the sanitation inspectors and more flexible to different Food Filipino service establishments. Katulong nito ang Code of Standard o COS, ang pangalawang food safety tool. Ito ay mas komprehensibo at mas moderno na guidelines upang mabigyan ng kahulugan ang mga kriteria sa food inspection checklist. At ang pangatlo, ang Operations Manual o OM. Ito ang mas updated at improved guidebook for sanitation inspectors to conduct risk-based inspections.
tara na at bigyan ng star rating ang food service establishments ng Pilipinas.
Para sa Pinoy who loves food,
Para sa Pinoys who serve food,
para sa Pinoy who conducts food safety,
let's check and rate all new modified food safety grading system tools.
Star-rated na kainan,
Sigurado ang kalinisan.
simula 2018,
So this risk-based approach to food inspection will serve as the mechanism to influence the culture of inspection in the Philippines. It will strengthen the food safety compliance of FSEs through detailed requirements and guided corrective actions. It will empower the sanitation inspectors in terms of improved inspection skills, and decision makers will be guided on where to put their resources and their priority in terms of infrastructure funding and training on. So together with the project team, we would like to endorse these tools to the policymakers in updating the IRR for Sanitation Code of the Philippines. And we are also calling on different LGUs to adapt the tools. FNRI is willing to provide assistance and training on the adoption of these tools. And at this point, together with the Food Safety Grading Project team, we are inviting you for a solidarity call with the advocacy that food safety is everyone's responsibility. So the next time you visit these eateries, look for the star rating. A star-rated na kainan, sigurado ang kalinisan. Thank you and have a good day.
Thank you very much, Ms. Manibiran, for sharing your outputs on the food grading system. So indeed, it's refreshing actually to see them. Nagkakaroon po tayo ng mga ganitong initiatives, especially for different sectors in the Philippines. Especially for this one, the food sector, which is, I think, common for everyone. So we're now down actually to our last project under the food sector, to be presented by Mr. Jose Mariano Fleras of the Rise Against Hunger Philippines. This project is on the assessment of the food banking systems for food security. So last but not the least, warm round of applause for Mr. Jose Mariano Fleras.
Hi, I am Marlene, one of the project team members under the project title Assessing the Contribution of Food Banking Systems in Addressing Food Security. I am presenting the completed project on behalf of our project leader, Mr. Jomar Fleras. This project was under the DOST Grants in Aid program. NBC co-implemented the project in Bacolod, and the Department of Nutrition of the College of Public Health in UP Manila led the monitoring and evaluation component of the study. This project was pursued because food wastage remained high in the Philippines despite the serious hunger and malnutrition problems faced by Filipino households. Food banks from existing knowledge and experiences overseas address food security challenges and dietary diversity. This project has the potential to improve the food security status of Filipino households in terms of their caloric intake and dietary diversity. This can also reduce the food expenses within the Filipino households. Lastly, this project can also reduce food wastage, especially in the food industry. It can also result to decreased greenhouse gas emissions that come from foods that are disposed in landfills. The project aimed to harness food banking systems in addressing food security by improving the caloric intake and dietary diversity of food insecure individuals and households in Taguig City and Bacolod City. So this is the food bank project journey. Rise Against Hunger Philippines opened the first food bank in the country in 2017. RAHP believed that food banking, a proven strategy in addressing food security since 1960, will also work in the Philippines. However, empirical data was needed to prove our point. Thus, we applied for this research grant in 2018 and then the project officially started in September 2019. 2020 was a challenging year. The year started with a volcanic eruption, then COVID-19 happened, and we needed to strategize. 2020 ended with 6 consecutive typhoons, and we were a fledgling food bank that was made to respond to the dramatic increase of hungry households brought about by these natural calamities. More Filipino families experienced hunger, especially during the first months of lockdown. We believe that it was providential that we were already organized when the pandemic hit us, but we couldn't have it done without the support of our donors and partners. Through this project, 2 food banks were established. RHP also became a member of the Global Food Banking Network. A total of around 300 million worth of cash and in-kind donations was received by the food banking systems, which served more than 300,000 families from January 2020 to August 2021. Trainings in home gardening or urban gardening were also provided to beneficiaries. Around 2,500 tons of surplus food items were rescued from January 2020 to August 2021. Rice and its products and grains ranked first in the food grains donated in food banks. The nutrition food safety guidelines in food banking was also validated and was used in the implementation of nutrition and food safety practices in the food banking system. Nutrition education materials were also distributed. However, results of the evaluation test revealed that there were just little to no changes in their knowledge, attitude, and practices. The COVID-19 pandemic hindered face-to-face sessions. More comprehensive discussion of materials should be realized and continuous monitoring and feedbacking should be employed to achieve better results. The daycare beneficiaries of the food banking system were targeted in the M&E component of the project. Generally, the food banking systems improve the overall mean caloric intake and mean dietary diversity of its daycare beneficiaries. In addition, the proportion of daycare beneficiaries with inadequate caloric intake and low dietary diversity decreased. The project team urges the government to approve the Food Donation Act in the Philippines to further improve operations of food banks with the goal of decreasing food wastage and addressing food security among Filipino households. Capacity building and food recovery efforts for local government units can be invested by the national government. We can provide funding, technical assistance, and resources to facilitate more partnerships in food banking. And that's all. Thank you everyone and happy 12th anniversary to UST Fisher.
Thank you very much, Mr. Leras and the Rise Against Hunger Philippines team. Thank you as well to our other project leaders from the food sector. We are once again opening the floor for any questions that the audience may have. We encourage everyone to please ask questions if you have any. For our viewers also on Zoom and on Facebook Live, you may key in your comments or your questions and we will relay them to our speakers. I'd like to invite to the stage our project leaders, Ms. Michelle Caristo, Dr. Rima Hassan, Dr. Josephine Migalin, who's representing Dr. Emma Sales, Regional Director Dr. Anthony Sales, Mr. Bienvenido Flores, Dr. Maria Patricia Azanza, Mr. Adrian Perjo, Ms. Claire Malibiran, and Dr. Maria Socorro Ignacio, who's representing Mr. Jose Fleras. Oh, thank you. Boss, thank you very much for you could take your masks off for sige po. Okay. I'd like to address my first question siguro po dun sa halal program, specifically those who develop food products. My question po is, to what extent na po kaya yung level of acceptance of the Muslim communities as well as our MSMEs operating in this halal market towards the innovations that you have made through the project? Ms. Evaristo,
Yes, good afternoon po. Thank you, PCIEERD, for the invitation, for giving us a chance to present the accomplishment of the project. In our project, when we started it, we already identified kasi the adapters. No? Unfortunately, originally, the technology should dapat i-adapt sa Mindanao after the formulation study. No? Pagkatapos ng study, adapt sana nila, bibigay kami ng training. Kaya lang kasi when pandemic hits noong 2020, hindi natuloy. So we have to look for another group, Muslim group, because the project naman talaga is intended for the Muslim communities. So nag-identify kami sa Bulacan, sa Tarlac, and then there's also in Batangas. But then again, yung pandemic kasi, napakatagal. So, nung malapit na, nung 2021, dun kami natuloy. So, ang nakasama namin is with, ang nabigyan namin, ang nag-adapt ng technologies na kasama Halal Cooperative, which is in Santo Tomas, Batangas. And they were very, very grateful kasi existing processor na sila, meat processor, and they actually accepted yung technology na binigay namin. No? Yun nga lang, very limited pa rin yung information when it comes to the emulsification technology sa kanila kasi ang alam lang nila, imimix lang nila, ganon. Kaya in terms of quality, dun sila nahihirapan, lalo na sa mga sausages and nuggets nila. So when we conducted the training, they were very, very grateful. And then, hinihintay lang namin uli yung invitation nila kasi they want us to go back to Santo Tomas and assess, mag-conduct ng TNA kasi meron na silang processing plant for the meat. Yeah. Thank you.
Thank you, ma'am. It's interesting to hear na meron po palang halal community rin sa Batangas. I'm actually from Laguna, so medyo akala ko siguro ignorance na rin on my part na mostly nasa Mindanao ang ating halal community. For Dr. Hassan po, for your developed products, ano na po yung case ng acceptance ng innovations?
Assalamualaikum warahmatullahi wabarakatuh. Actually, hindi po ako si Dr. Hassan. Siya po yung project leader namin. I am Dr. Oranyola po. Doon sa amin naman sa Basilan, I would like to take this opportunity that the Halal Innovation Center, yung Food Innovation Center is nandun sa amin, and I am really grateful sa PCIEERD who made all the possible things na napunta yung mga namin, yung mga facilities na nandoon. And of course, the DOST kay Secretary De La Peña for giving us the chance to scout mga young researchers like us, and for the finance na binigay sa amin sa development of the halal native delicacies. So far, yung acceptance of the product that we had developed is we are grateful na kasi una-una nga, sabi nga ni ma'am na we were able to identify na sino yung mga magiging stakeholders in the after yung project namin. So we are very grateful that ang LGU, the tourism themselves, no, nag-adapt sa ano namin. And in fact, the community, nagtatanong nga sila, saan daw yan galing? Kasi we cannot, hindi pa kami pwede magpunta sa market, ang mga products doon kasi nga may mga requirements pa dapat i-comply. So we are very grateful na tinap namin yung LGU, especially the tourism, wherein tumulong talaga ng malaki para ma-spread out yung products namin. Salamat po.
Thank you, ma'am. That's very nice to hear po. At least involved na talaga ang ating LGU dun sa adoption din ng ating innovation, sorry. For ano naman po, I'd like to ask kay Dr. Migalvin po. Nasa Zoom po ba siya? Or wala po siya ngayon, sorry. Sige, skip na lang ako kay RD Sales na po. Dr. Sales, what do you think is the biggest contributor po dun sa naging successful completion of your project? Seeing as it's development ng yung modules and then it's the pandemic, very needed yung mga face-to-face, ganyan.
Well, kailangan committed yung project leader, ano? At saka yung project team. Kasi yung trabaho namin is to, yun nga, development ng modules and deployment of the modules. Sa development ng modules, you have to engage all the project staff in all the regions. So the first thing that we did was to go around the regions. This happened before the pandemic. So we were able to go around the regions, get the feedback from all the halal stakeholders because we wanted to determine the training needs of these halal stakeholders, including MSMEs, certifying bodies, government agencies, especially those that are members of the halal board. No, so from the training needs assessment, we were able to develop the human resource development plan for halal or on halal. And from there, we started developing the modules. As shown earlier, we had 3 modules, and these were translated into 3 languages: English, Tagalog, or Filipino, and Maguindanao. No, because I think we all know that the majority of the Muslim population in the Philippines are Maguindanaons. So it's important that the modules are in the mother tongue of our Muslim brothers and sisters para madali yung deployment. And unfortunately, the pandemic came and the deployment was a bit delayed. But we were also able to do that through virtual or online webinars. No? So as shown in the presentation, we conducted a number of webinars on the modules. And as the numbers show, we have been quite successful in deploying the modules. And it also helped that we were able to endorse the modules to the Philippine Halal Export Industry Development and Promotion Board or the Halal Board. Kasi nakuha namin yung endorsement nila, they issued resolutions para ma-deploy nationwide yung modules na yon, and also to recognize the certified halal trainers and auditors that we were able to organize as an output of the project.
Okay. Daming insights, daming pwedeng matutunan po ng ating ibang project leaders. So it's more on yun din talagang dedication ng ating project leader dun sa pag-implement and pag-complete ng kanyang project.
That's right. That's right. Thank you.
Thank you, RDB Sales. I'd like to throw the same question po kay Mr. Flores of ITBI. Regarding lang po dun sa extent of the acceptance dun sa ating assurances, quality assurance system. How many users na po or mga ganun, sir?
During our project, we have 5 cooperators. Oh, yun. So they are non-Muslim. So nakapag tie up sila sa amin para ma-certify po sila na halal. So our project will be beneficial to processors and also to our Muslim brothers and sisters. Thank you.
Thank you, sir. Thank you po. Like to jump naman po kay Ma'am Asanza. question lang po, ano po yung parang next steps for the technology? Are there parang similar collaborations that are already in the works, especially for other undervalued po na mga materials natin?
Actually, kausap ko lang kagabi ang sister cooperative ng BEPCO, yung tinulungan ko sa egg. And we are trying to develop another proposal, hopefully through Cradle, na we're looking at fruits and vegetable processing and looking at the possible maging shelf stable ito and using technology, and hopefully we can help the cooperative. It's as big as BEPCO, so matutulungan yon regarding sa technology ng granules and powder for egg white. Ito ay ginagamit na minamarket na ng BEPCO. May toll packer sila at nakapasok na sa industriya, sa institutional market, hindi pa lang sa consumer market. So medyo malaki ang merkado na pinapasok ng BEPCO, but they are now in a commercial scale production, starting from the project that we have started using the FIC equipment. So malaking tulong na nakikita ang resulta ng paggamit ng FIC equipment. And then nag-translate kami sa toll packing, and now they're entering the commercial product, and hopefully they will have their own equipment sa paggawa ng pulbos at paggawa ng granules.
Thank you, Dr. Asansa. That's nice to hear it po. Kay Sir Adrian Perjo, similar question po. Ano na po yung parang current status natin? Any other developments in the works? Mga ganun, sir.
Sir, I'm Alvin Gonzalez po, in behalf of Sir Adrian Perja po.
Sorry, sir. Thank you.
Bali, regarding po sa project po namin, so the blockchain tilapia, or mas kilala po siyang tilapiang Gloria. So kung hindi po siya nabibili sa mga palengke, so kinukonsider po siyang peste ng mga fisher folks kasi nga po malakas po silang kumain. So we are grateful na na-develop po namin siya as a fish loop. And currently po ngayon, nagkakaroon na po kami ng technology transfer para maturo po yung techniques or technology sa mga cooperatives. And currently po, meron na din po kami, nakikipag-usap na po kami sa TBI ng school, ng BPSU, para po sa commercialization po ng fish loop. And tomorrow po sa Souk Fair, so sa MOA, so kasama din po yung fish loop namin sa mga ipe-present po ng BPSU.
Okay, thank you, sir. Thank you po. For ano naman po, kay sino na ba? Sorry. Kay Miss Claire po, for the food establishment grading system. Similar question po doon kay RD Sales. What do you think yung naging biggest contributor dun sa successful implementation of the project given na nangyari ito lahat during the pandemic?
Okay, so good afternoon. First of all, I would like to thank PCIEERD and also DOST, our funding agency. For our experience, may I add to dun po sa Sinay Director Salas, is siguro po yung involvement ng different expertise or ng experts, because we started the development of the tool consulting different experts. So not only the experts, particularly the end user, the sanitation inspectors, the leaders of the sanitation inspectors, including the LGUs and their leaders. So their inputs are very important because the content of the tool is science-based, but the implementation will be most effective if it is from the first-hand experience of the users. And also, aside from the different expertise, yung ability to adapt natin on like we also experienced 2 years of pandemic, and these sectors are the most affected. So hindi po kami nakapag field work to get their inputs on our tools. Also, the pre-testing of the tools and the pilot testing of the tools were delayed. Hindi po kami nakapunta sa mga food establishment because sarado sila during the pandemic. So during those times, we use the times in coming out with the concept of the ABP and how to disseminate our project, the concept of what is our way forward. So actually we are developing then the electronic version of the food inspection. So this is for the future project proposals of FNRI para din mas madali para sa ating mga sanitation inspectors ang mag-conduct ng inspection sa field na handon na lang sa kanilang mobile gadget yung checklist, and also ang result will be printed and forwarded to the yung mga business owner and also the LGU din para sa easy monitoring. So yun po at dedication pa rin po ng mga members of the project. So I thank my project team for staying with the goal to complete the project despite the pandemic. So that's it.
Thank you, ma'am. We can really see how innovative rin po ang ating mga researchers, ating project leaders, especially in the face of the great global pandemic such as the one we've experienced. Last but not the least, kay Dr. Ignacio, sort of a similar question, yung biggest contributing factor and ano po yung parang moving forward, what would you parang recommend the establishment of more food banks in the Philippines?
Thank you for the question. Greatest contributing factor was the cooperation given by our LGU partners. As a matter of fact, our LGU partners here with us, nasaan ba sila? Our chairperson ng LGU, Barangay Ususan, hello. Our Barangay Nutrition Action Officer, nandito po sila to witness this presentation. So sila po yung driving force namin to continue serving the community. Without them, I guess the Rise Against Hunger will not be able to fulfill its objective of feeding the hungry preschoolers, addressing being more inspired to put up food banking system. We've expanded the model that you sponsored, PCIEERD. Maraming salamat po. We're now in Magdalena, we're now in Porac. So yung model that you supported, we are scaling it up. And so we hope to be able to reach partner with other LGU so we can expand the services that we're offering. As a matter of fact, our director, who is not here right now in Israel, is observing food banks in Israel. And some of them will be visiting our good food grocer in Taguig and in Magdalena. So I think that's the greatest contribution that we were able to establish with LGUs. Challenges were, of course, related to COVID. So luckily, we were able to finish the project on time, but some of the indicators that we planned to collect was not collected because of the pandemic. Also, our researchers got COVID. And so with the lockdowns, we're not able to really collect the desired indicators, but luckily we're able to produce results. That's all. Thank you.
Thank you, ma'am, for sharing your experiences actually. I think my main takeaway from everything that you've mentioned is that it's really important yung collaborations natin, not only with the industry, but with other experts, other stakeholders in our respective sectors for our projects to truly come to fruition. So with that, unfortunately, we no longer have any more time. I'd like to thank our project leaders again for joining us for this whole day actually, and for answering the questions. Before we move on, I'd like again to request Dr. Paringit, Engineer Escorial for a quick opportunity with our last segment of project leaders.
All right, what a great discussion we had. So once again, thank you to our last set of presenters. from the food sector. So this just in, we have the winners from our anniversary giveaway featured as well. So congratulations to, drumroll please, Sir Ryan Fit for food and Sir Arnel Beltran. Congratulations. Please proceed to the registration area to claim your prizes. Okay, so before we proceed, I would like to mention that your feedback is very important to us. So may we request you to please honestly provide your feedback with our customer satisfaction form located in your respective tables and kindly surrender it to our secretariat in exchange for our assured merchandise and tokens. So we will appreciate receiving your comments and feedback. All right. So we now go to the last Excellence in Project Implementation and Completion or EPIC awarding. Of course, this is the last segment. So may we call on Ms. Russell Philly to present the fourth EPIC award. Please give her a warm round of applause.
Okay, so we're down to our last EPIC Awards for this year. So the DOST PCIEERD Awards provides this award to projects with exemplary project implementation and completion in 2021, awarded during the 12th DOST PCIEERD anniversary celebration with the theme Empowering the Filipinos through Innovative Engagement, given this 29th day of June 2022 at Dusitani, Manila, Makati City. Signed, Dr. Enrico Paringit, Executive Director, DOST PCIEERD. So the EPIC Award goes to Project Parola. Congratulations.
We'd like to call on stage the members of the Parola project. Also inviting again Sir Eric, Sir Tino, and project managers of the transport sector. Please join our team on stage for a quick photo.
Right, once again, let's give them a warm round of applause for Parola Project. Congratulations as well to the transport sector for being able to receive 3 out of 4 EPIC awards for our anniversary. Right, so again, let's give them a warm round of applause for Parola Project. So this is not the end. We encourage our project leaders to implement their projects efficiently and effectively because we hope that we will see you to be a part of our next PCIEERD EPIC awarding in our succeeding year. So may I call on my partner here back on stage to proceed with our program.
Thank you everyone for being here with us today, and our project leaders, their representatives, and all our other stakeholders who joined us until the end of this session. We are all very grateful that you have shared your experience and shed light on these projects as we aim to communicate more of our initiatives to the people.
Before we officially end, we would like to share to you the highlights from our pre-anniversary event last June 21, 2022. Please enjoy our short video.
one of our outreach was also people services, where we expected to support students in the accomplishment.
Our hands for our Innovation Council's anniversary. I hope you enjoyed the same day edit since we have included some of the clips for today's event. All right, now to wrap up our event today, may we call on stage the Deputy Executive Director of DOST PCIEERD, Engineer Nina Lisa H. Escoria. Let's give her a warm round of applause.
Okay po, dito na daw ako kasi masyado po akong cute, di ako makita. So magandang hapon po sa ating lahat at in behalf of PCIEERD, malabis po ako nagpapasalamat na nandito pa rin kayo hanggang ganitong oras. So may speech ako pero siguro coming from the heart na lang. So it's just a usual graduation kasi sabi namin this program is also our way of recognizing our completed projects. And just like a usual graduation, makikita po natin na meron tayong nag-graduate from the elementary, the high school, the college, and of course, meron na po mga nagpo-postdoc. So that means po, although these projects are completed, some of them will have different way forward. So meron po, nakatulad ng BCT, I'm happy, nasa MOA kayo tomorrow. The case nila Dr. Tony, nila Mama Sansa, na nasa market na. But of course, meron pa rin po na hanggang sa end, PCIEERD will handhold, papasok siya sa fast track, and other graduate programs that the PCIEERD is offering. So parang ganyan po si PCIEERD. We treat you as someone that we could shepherd. So hanggat hindi po tayo nakaka-graduate, the council is there to always help our researchers. So actually, hindi nga po nabanggit kanina yung mga graduates natin from the Institution Development Program. Ito po yung hinahandhold talaga namin from training them, teaching them how to walk and run their laboratories up to the time nga po na nakagraduate. And for this afternoon, I think marami po tayong takeaway. Ito yung mga paboritong C's ng aming director. So una, although may mga challenges tayo nakita, especially pandemic, and we'd like to congratulate our project leaders for really braving that out in spite the pandemic. So yan yung unang C na nakita natin. But then, may another C, which is the commitment, which is very important. So sobra-sobra, palakpakan natin yung commitment ng ating mga project leaders and our researchers. And of course, another important C is communication. May nagsabi kanina na yung research mo will not have importance if you do not listen or communicate with your users, with your partners, so that from the start, alam mo nang tama yung direksyon ng ginagawa mo. So that communication. Pero importante rin po na we should have that collaboration and cooperation. So, kasi kahit mag-communicate tayo kung ala rin, pinakinggan na kita, so what, di ba? Pero we must learn to collaborate and cooperate so that we will be talking towards one direction. And with all of this, so makikita po natin kung ano talaga yung contribution ng ating mga projects. And I'm so proud to hear na yung ating Rise Against Hunger is dumadami na. Noong una sabi namin, paano ba ito i-roll out? They started in Taguig, they have in Negros, and now they have other places where we could look, and we're so proud that we are part of that model po na nagawa ng project. And there's so many things pa that we would like to offer to you in the next few years. So kanina, pinag-uusapan po namin yung instant award. Actually, napag-isipan lang namin ito to really acknowledge and recognize those projects that completed on time. Medyo kakaunti lang po talaga sila, mangilan-ngilan. So next year, we will make that contest or that award more exciting. So yung ating mga project leaders dyan na on time pa, please make your project on time. Baka po next time, meron na siyang CAS award. So next time we will make these things more exciting. And with that po, maraming salamat po for joining us in this important event in the PCIEERD anniversary, and to the whole PCIEERD family, happy anniversary. Magandang hapon po.
Thank you very much, Ma'am Nims, for that very insightful and fun closing message. Again, reminding everyone still present today, both physically here in Lucid and in our virtual rooms, to please answer our feedback. For those in Zoom, a separate link will be provided to you. You would need to fill in your feedback form to get your certificate of attendance.
Please do follow our social media pages to keep updated on the schedule of upcoming events and activities. Thank you for joining us for the Innovate PINAS, the 2022 Philippine Development Research and Innovation Conference. This has been your host. I'm Maribel Manawis.
And I'm Christian Zamora, and we really appreciate all of you for helping us empower more Filipinos through innovative engagement. Maraming salamat at mabuhay po tayong lahat.
Keep safe, everyone. God bless.
Announcement lang po, quick announcement, sorry. For PCIEERD personnel, please stay after the session wraps up. We just need something daw po. Sabi ng IG. Thank you.
Once again, thank you for everyone. Have a nice day. Enjoy the rest of your day.
We expected to support students in the accomplishment of the thesis they involved in the project. However, aside from that, we were able to first support 2 DS minority.
We are the Philippine Council for Industry, Energy and Emerging Technology Research and Development, or PCIEERD, one of the sectoral councils under the Department of Science and Technology. We are all about innovation and progress. We lead and partner with public and private institutions in generating science and technology policies, strategies, and technologies that spur national economic development. We formulate policies and strategies for scientific and technological directions. We fund and support R&D efforts in the industry, energy, and emerging technology sectors. We provide opportunities that enrich human resources and facilitate the development of institutions. We move technology forward, through adoption, transfer, and commercialization of available technologies. We ensure timely and effective delivery of research results. The Council encompasses sectors under these priority areas. And all of these are backed by a highly skilled and science technology workforce for quality technologies and innovations. We are driven in bringing homegrown science and technology to the fore of the competitive global arena, creating impact on the country's progress and improving the quality of life of every Filipino. We uplift lives through innovations. PCIEERD. We are the Innovation Council for Industry, Energy, and Emerging Technologies.
Transmission, closure of borders, lockdowns, millions of deaths. The unprecedented crisis brought about by COVID-19 has brought the world to a standstill. Amongst the first frontline government agencies to lead the fight against COVID-19 was the Department of Science and Technology, Philippine Council for Industry, Energy, and Emerging Technology for Research and Development.
Also known as the DOST PCIEERD, the Council was able to deliver innovations to the Filipino people at the height of the pandemic in 2020.
Among the projects supported by the Council in response to the pandemic include the Specimen Collection Booth. A total of 132 units were deployed to 92 hospitals throughout the country to help frontline workers collect specimens from suspected COVID-19 patients. The Additive Manufacturing Center, or AMCIN, together with its partner centers, also provided 3D printed face shields, ear relief bands, and 3D printed Venturi valves distributed to hospitals all over the country. Ventilators were also developed to address the shortage of essential medical supplies, critical to the delivery of public health services, primarily among COVID-stricken patients. The Council also supported innovations in safety monitoring, border control, and mobility assistance, such as Vision-Based Traffic Information Analysis, or TITAN, Optimal Allocation of Personnel, or OLAP, and the Intelligent Electric Transportation Network Program. The Bayan Co-op's Unified Market Inventory System was also brought online to address shortage and hoarding of essential supplies. ReWear, a washable 4-layer face mask, is able to repel water and similar liquids, adding a layer of protection against COVID-19. Other powerful pandemic inventions also include the Mobile Artificial Intelligence Thermal Scanner and the LISA robot in mitigating the spread of the dreaded novel coronavirus disease. We, the Council, also rolled out human resource and institutional development programs that seek to empower Filipino researchers, scientists, and engineers amid these trying times. These programs are a testament to the capability of the Filipino to make wonders that are scientifically sound and socially relevant.
With Filipino innovators, researchers, and scientists taking the lead against the pandemic, DOST PCIEERD is committed to bringing more innovations in response to the most challenging period of our time.
Research not communicated is research not done.
The Innovation Council and the University of the Philippines Los Baños College of Development Communication has launched the Science Communication Fellowship Program, popularizing research for the people. The program will empower 40 scientists, researchers, and communication specialists to better promote their innovations and research results to the public.
The fellowship program is composed of a series of mentoring activities that will introduce the concepts of science communication, popularization techniques, and skills in developing communications materials. Aspiring Pinoy science communicators should be part of an ongoing PCIEERD-supported project with a remaining duration of at least 6 months. Researchers from completed projects may join, provided that the project is still being sustained in their organization. To be one of the 40 SciComm program trainees, visit this link, fill it out, and submit the following documents until July 29, 2021. Applications will be evaluated through the quality of their capstone projects, guided by these criteria. Number 1, innovativeness, 30%. Number 2, feasibility, 20%. Number 3, impact, 25%. And number 4, sustainability, 25%.
Ready to optimize your science communication skills? Join the DOST PCIEERD Science Communications Fellowship Program to reach and educate more Filipinos.
COVID-19 has shined the light on the importance of science, technology, innovation experts, and researchers in the Philippines, as they were amongst crucial frontliners tapped to aid in the country's fight against the pandemic. Most of these experts helped the country through game-changing programs, projects, and initiatives of the Department of Science and Technology, or DOST, to ensure that the DOST continues to arm experts and enrich the country's S&T human resource. It crafted the DOST Science and Technology Fellows Program.
The DOST S&T Fellows Program aims to engage S&T experts to craft and shepherd R&D roadmaps for sectoral planning councils and strengthen the capabilities of the department's research and development institutes.
S&T Fellows will direct, undertake, and promote R&D in the country that will spur socioeconomic, health, and nutritional growth, as well as speed up inclusive growth and development in the countryside through state-of-the-art innovations. They will be the pathfinders that chart roadmaps of the sectors they are assigned to. As an S&T Fellow, they will help the DOST in identifying cutting-edge research, bringing Philippine innovations to the next level. The S&T Fellow must, number 1, be a Filipino citizen not more than 60 years of age. Number 2, be a career service professional. Number 3, be organized and a good team player. Number 4, have excellent written and oral communication skills, with a capacity for simplifying complex ideas and concepts for the understanding of various stakeholders. And number 5, have an outstanding contribution in their field of specialization. Read the full list of qualifications and application requirements through the link displayed on the screen.
Be an S&T Fellow and champion DOST